Sånn?
Ja.
We can wait just a more minute. We can take up the time afterwards. I see there's still people coming in, so that's why I'll just give them a couple of seconds. All right. Welcome Welcome to this year's NONOG-6 and NICS meeting. We're very happy to have you here, and I hope you'll have an exciting day. It's a full day, so we will try to keep on the schedule so you're not completely exhausted by the end of the day. I would like to start a bit with just some venue details. First, about the emergency exits, which are the way you came in, but there's also another emergency exit around the corner, but you have to break the glass to use it. Hopefully, we won't need to use it. The toilets are under the stairs where we came in. There are some stairs up. They are under the stairs if you need to use the toilets, and there's also a handicapped toilet around the corner here. Besides that, you can see on your program, on the back of the program, when we have the breaks and when we will finish with dinner. But we'll talk more about those a bit later. I wanted to, start a bit with the ones who made this possible. And that is our sponsors. These are our platinum sponsors. NetNode, which has more than 25 years experience, the core of the internet, and then provide all kinds of services from interconnections to time services, DNS, and root servers. And NetNode is kind enough to sponsor today's dinner and some of the drinks. Thank you very much. We have NONOG-6, who has expertise in the design, implementation, and maintenance of network and data centers. And they deliver to customers who build and develop broadband networks. And they are kind enough to sponsor us with our lunch today. Thank you very much, NONOG-6. And FiberWorks is delivering first-class solutions and services for your fiber network. And we also thank them for the sponsorship. They're also covering a great deal of the expenses today. Next, we have our gold sponsors with Cisco, D6, and Flex Optics, which, they need no further introductions, really. And we thank them for their kind support as well. And our silver sponsors, which, they might have the smallest logos here, but together they contribute for more than a platinum sponsor or more than 2 gold sponsors. So thank them too. And you can check on our event site for links and details about everyone. I would also like to extend a special thanks to NICS, who has been helping a lot this year's event. This whole venue is sponsored by NICS, and the coffee breaks and the registration and everything is covered by NICS. Thank you very much, NICS. Next, just a bit of NONOG promo. We would like to invite the ones of you who are interested in helping organizing such events to reach out to us and like you can see, help us, because it's at times it's a lot of work and we could need help in various ways, from helping with promoting and social media to arranging, keeping contact with people. So if you're in Norway and you want to help, just reach out to us. Next, I would like to inform about a quiz which we'll have later today. We have to fix the questions throughout the day. The quiz will have some prizes. It will be at the end of the day, 5:45. And we have 5 RIPE NCC certified professional vouchers, so you could take the exam for free. I think they are roughly 200 euros each, so there's not little. And in addition, we have our brand new T-shirts, which we test for the first time this year. And we give away also 5 of those at the end. And then you can choose, in the top 10, the end can choose one of these prizes. Additionally, we have a survey. You find the link also on your program. And at the end, or whenever you feel you're something you have to say, just use the survey and you can send there your feedback. So without further ado, I think we can invite our first presenter, which is Harman from NICS. Arman has been with the NICS team since 2015, and he's now working mainly with daily operations, and is part of the ongoing efforts to future-proof the infrastructure of NICS. Feel free to ask him anything about NICS. Arman, welcome.
Hello, can you hear me? Good. Welcome to our yearly update. I will speak mostly on day-to-day operations and upgrades we've done. Then one of the founders of NICS, Kjetil, will outline more of the big picture plans and other details. Thanks to NONOG and everyone that helped arrange this event. This is the current NICS team. Yeah, this is me. My name is Herman. I'm absolutely not an expert in either peering or BGP, but I think working with NICS is very fun and meaningful, and I'm happy to be able to do this. The core team of NICS was established last year, and we have meetings where we plan and discuss the future of NICS. The operations team is also supported by the university's Network Operations Center, which means that we have several other engineers that can help with maintenance and troubleshooting. Because our day job is at the university. We run the network. We have about 130 buildings. This is one of them. And our philosophy in the NOC is basically that everyone should be able to do most technical tasks of the engineers, and we value simple design over bleeding edge technology, historically. So this year, we've received a governmental grant for the next 3 years, which Otto will detail. We deployed 3 new switches capable of 400 gigabits at 3 of our sites. And one of our busiest link between 2 data centers are upgraded to 400 gigs now. From we had link aggregation on 200 gig links. This was in August, maintenance window that most of you knew about, hopefully. Current member number is around 75 across all sites, including the regional. About 4 new clients this year, and I think we have the one that disconnected. We have around 240 gigabits average during the daytime. That's all sites combined, and but it's steadily increasing. So around January, the traffic began steadily increasing, which you can see here. We weren't extremely prepared to handle this. So we took us about a week to upgrade one of the links, and it made us also realize that we needed to upscale our infrastructure. And when the Olympic Games in Paris started, we also saw a huge surge in traffic, as most of you probably did. But we need to be ready for these peaks. So we have a need for upgrades. It's not just the traffic; it's also how many 100 gig ports we can sell. We're nearing max on all of our main sites, And a lot of you have been asking about single lambda optical modules because they're cheaper. And we haven't been able to provide this because we haven't had support on our switches, but now we do. So we are expecting more people to connect with 100 gig in the future. And we want to be ready for the next 10 years, preferably. This is an image of one of our main sites at the bulk infrastructure. Most of these ports, all of these ports are 10 gig. And it's not very updated, this image, but we're nearing max on the 100 gigs here. And we need to expand this to be accommodate 100 gig clients instead. And there's not much to go on here. It's pretty full. This is the link that it's between bulk infrastructure and stack infrastructure. And this is just a normal week. We have 140 gigs traffic. But we've observed peaks of around 175. And that means that we could potentially get in trouble if there's a lot of traffic. We have started the upgrades. These are our two apprentices, Tajamal and Abdullah. And we have installed a new rack, which is a bit deeper because we need to, our new switches are very long. And we've also installed new fiber panels. And our plan is to move all of you. This is in our Gaustadalen, Oslo Science Park location. We're planning to move all of the clients from this old infrastructure here. This is our old 6500 Catalyst Cisco switch, which we turned off last year. 6500 off 4500. And we have some servers that we need to run this IXP, which we will also move over here and future-proof. This is our new main peering switch, which you will connect to as clients. It has 8 400 gig ports. We use at NICS, we use about 3 to 4 of them to connect our infrastructure. So we only have around 400 gig ports to provide. So we already have to start thinking about the next step. But this is the logical next step now. And we have 28 100 gig ports also, 40 gig. We prefer just connecting people with 100 gig to standardize. We don't have any 40 gig right now. And why did we choose this switch? There's a lot of reasons. The easiest answer is that our NOC is used to using this equipment in our data center. And that also means that if we use the same equipment, we can use the same storage and spare parts if something goes wrong. So we're ready to just switch out the equipment if needed. If we were to have a totally different system, we would have to have our own spare part storage, and engineers need to know a different system. So that's the easiest reason. This is from the maintenance window in August. we had some goals. It didn't go quite as planned, but we were able to do most of what we wanted to. We needed to reboot our main switch at stack, and it had not been rebooted for a long time. So it was a bit scary, but it went okay. And we were able also to upgrade the busiest link, which was a big achievement, we think. But if you, I don't know if you can see, probably not, but the timestamp here is 0759. And the maintenance window was from 06 to 08. And this is the time where I shut down the old main link. And that was way too close for comfort. But we made the choice to shut it down because we could have run them in parallel, but we were thinking that we didn't have that many maintenance windows left until this conference, so we took a risk, and it went all right. But I don't want to do a major change at 1 minute before the maintenance window is over ever again. So this is the current situation. It's a simplified image, but this outlines how it is today. And our plan for the future, this is more detailed. Our plan is to have 3 main sites. We have Oslo Science Park, then we have bulk infrastructure and stack infrastructure. And we have the so-called old 10 gig switches that most of you are connected on now. They will be connected with a lag to the new 400 gig switches. And then we'll create a new ring here. And right now we've configured it to prefer all of the 400 gig paths, so we don't get in the situation where the switches actually prefer. We have a question? Just wait for the microphone.
Yes. So are you running a VXLAN on top of this? Or
Spanning tree.
Spanning tree?
Yes.
Okay, thank you.
And as I said previously, we value simplicity very high, and that's why. Yes, so we will upgrade our other sites if needed. This is Blix data center, and we will upgrade that in the same way if the traffic is high enough. So we need more maintenance windows. We need to get better at it. We have lots of work to do. We need to migrate all of you that are on 100 gigs to our new switches. And if you were to be able to do an individual maintenance, just let us know. Talk to any of us in the next team. And then there's one less thing to do in the big maintenance windows. And we will always provide live updates when we have a maintenance window in the Slack of NONOG's Slack server. And we will always notify you 5 days in advance. We will try and and notify even earlier than that. But it's not always possible. So if I were to just do a maintenance window now, our main method of doing this has been to just shut down the ports. And when we do this, we have to notify all of you, and you need to do something. You need to redirect the traffic, shut down the sessions. And that's not always practical. Maybe the person who knows how to do it is not at work, and maybe someone didn't get the mail, or even you just think, well, it's better to just have the traffic drop. And if we were to just shut the switch down, which is what we did in August, the scenario will be that we will experience something that I think one talk today will talk about, actually, hold timers in BGP. And the scenario is actually that the router will not understand what's going on. And that will mean that there will be a lot of traffic lost if we just do this. I think a lot of you have probably a lot of experience doing this. We are pretty new to it, so we are excited to get going with this way of doing maintenance. And to prevent this from happening, we need to implement an RFC, which is meant to do an automated shutdown of the BGP sessions. The way we do this is Cisco syntax. We need to configure the switches with these hardware commands, and then we need an actual reboot on the switch. This is one of the reasons why we had the maintenance window in August. Then we create an access list where we specify the NICs networks, both IPv4 and IPv6. Next step is we create something called an access map, which is meant to match the access list to an action. And this is a technology that we don't have routers. The peering switches are just layer 2, layer 3 switches. But this enables us to actually apply an access list on the switch. The last step is we apply the access map to the VLAN. And this will result in an automated BGP session shutdown. This is good. So then we get a new scenario on our next maintenance window. We haven't tried this yet, but next time we're gonna do this. The first thing that happens is that we do what I outlined in these previous steps. The sessions are then culled, and that means that the router is notified that the sessions are going down. Then we have to just wait until the traffic starts redirecting. And then we shut it off, because then we can be more comfortable with that all of you have been able to redirect the traffic. And the requirement to be a member of NICs is that you need an alternate path. So hopefully everyone has that. Any questions? All right. Pricing. I said that we're expecting more 100 gig customers, but we know that our prices may keep some people from upgrading from 10 gigs to 100 gig. Our price range is in the mid-tier of in comparison to other IXPs. This is from Peering Exposed. It's just a sheet you can find online. But we are considering a new price model, which is more based on incremental costs based on what you peer. We're still outlining the details, and the plan is that when we're finished with the backbone upgrade, then we're ready to accept upgrades and new clients. And hopefully you will all upgrade to, not all, but a good amount of you will upgrade to 100 gigs. We also have some regional IX points. I won't speak a lot about them today, but we have a new standard switch which we're deploying, which has 8 available 100 gig ports for customers. And we just deployed the new switch at 6, which at the Green Mountain data center. We will upscale the regional sites if needed. And I'm sure that Hege and Kjetil also has lots of exciting thoughts about the regional points. Our plans. We're going to keep on working with the upgrade, complete our 400 gig topology, increase the number of maintenance windows. We need to get better at this, and I would love to cooperate with you on how you experience the maintenance windows, and that way we can all get better at this. This is our point of contact. You can reach us at the NONOG Slack and follow us on LinkedIn. And you can also just send us an email or just ask about anything you want. And I think we have time for one question. There's one question. Two questions.
What about NIX2? Especially now that you're introducing spanning tree, I would like to have a secondary infrastructure.
Kjetil will talk about NIX2. Yeah, just one quick question.
Tor Andersson, Red Pill Impro. You showed us a graph from MRTG, I think it was, where you said that you had 175 gigabits on a 200 gig aggregate. And MRTG, as far as I know, by default polls NMP counters every 5 minutes. So that's an average over 5 minutes. And that's almost 90% utilization. So I'm thinking, within that 5-minute window, chances are you have actually saturated those links in microbursts. So I'm wondering, do you actually monitor for tail drops or at least standing buffers so that you actually can pick up microbursts and such problems? Because I don't think MRTG will tell you that.
You are correct. And we need to upgrade we have had, what's it called? Too much traffic. And we're thinking about implementing Grafana also, maybe instead of MRTG. But yes, we have a problem and we need to fix it. Thank you.
Thank you very much, Herman. Next, we have Kjetil from NIX. Kjetil is a well-known figure here in Norway with NIX and NONOG. He has been involved with NIX since before its launch in 1993, where he is the CTO and CEO. And he's also the technical director of EUS-utvalget, which is the Norwegian Parliamentary Oversight Committee on Intelligence and Security Services. I think it's... I think I took it in.
Looks like my noting of things. Just a comment on the measurement thing that we use MRTG, but we also look at discards and other errors at the ports. So we're not just relying on MRTG, but we're a bit too close to the limit for comfort. So that's why we've started to a little bit more aggressively both adding bandwidth, but also following up with more maintenance windows to be able to cope with those situations. Just to answer your question. Yeah, you know me. I'm here to talk a little bit about the plans for the coming years. Herman talked about the more operational part of it, and I'll try to stretch out a little bit into the future. What we all know, and what most of the world knows, internet is important. We've got a lot of stuff going on back here in Norway. Everyone says things are important, lots of paperwork, but these words must be converted into action. Paperwork doesn't make a better internet. So we at NIX want to be a piece of a good internet. We want to make internet better. So we are having some plans to be a piece of a better internet. We currently are in a planning session of 3 years. All big democracies used to have 5-year plans. We stick to 3 years. So the reason why we are now doing a little bit more planning is that we have now got a little bit more secure foundation for our work. We'll come back to that in a moment. There's primarily 2 of us that works with these plans. It's Hege, to stand up. So the 2 of us are the main people, at least present here, that work with the future plans. So if you have any questions, please ask one of us. I unfortunately have to go in another meeting after the first break. I'll join you again for dinner, but Hege will be here all day, so just find her and talk to her. One of the things that we are focusing on and that we have been working on for a few years is the community, because a strong internet community is important, as we see here today. We've had a good cooperation with NONOG, and we want to continue that, because it's important to get to know other people in the industry. It's important to learn new things, and it's good to have a place to discuss things informally. And in day-to-day operations, it's also important to know people, because when the shit hits the fan, you have to be able to pick up the phone and talk to someone you've talked to before, to be able to get services to lend a hardware piece or a cable, or make someone pull a cable or plug a cable. You won't get that kind of involvement if you haven't talked to people before. You can't call a stranger to do these things. So we need to meet. And we will continue to support community building. This is, of course, is an Oslo event. We will also try to start out with some community building outside Oslo, because Norway, being a long, thin country, not everyone has the time or the resources to come to Oslo. So we would like to reach out and see what we can do regionally. More about that in a second. And a question to you. Are you familiar with Net London, Net Manchester, the meetings they have? Yeah, well, Fergus, of course, but a few others. These are monthly get-togethers, a low-key, just meet at the site for some talks, maybe have a presentation or two, very, very low key. We would like to try this out in Oslo as well. If there is any, is there any interest in the audience? Show of hands slightly. Yeah, a few hands, very careful. Yeah, Norwegians are not good at this socializing thing. But we will try anyway, I think. We'll try it out to see if it's viable. We'll have to find a site. Not so many good pubs in Norway as it is in London and Manchester, but we'll find somewhere. Governance. This is one of the I would say, good things for us, is that we've finalized or finally managed to get this a little bit more sorted out. NIX, of course, is owned by the University of Oslo, has been since March 1993. And this ownership brings responsibility. And since the university is owned by the Ministry of Higher Education, we've now finally got that kind of responsibility all the way to the top. So the director or management at the university knows about this, and also the Ministry of Higher Education knows about NIX and know that they have a responsibility. So they know that they can't just tell us, no, don't do this anymore. You have to kind of be in for the long game. So this is now in operation, and also it makes it easier for us then to say that, okay, for the next 3 years, we need to use a little bit more money. That was the grant that Herman was talking about. So now we got a little bit of leeway in these 3 years to do something good for the internet in Norway. So this is why we have this plan. We also plan to have an advisory board. Today, the board of the IX is the management at the university. We'd like to have an advisory board that could advise us more on the industry, because the management at the university don't know anything about this industry. So we will reach out to specific individuals in the industry here in Norway and maybe also internationally to form an advisory board to give us input that is more relevant for the industry than what the university management can do. Infrastructure. In the old days, you could just put up a switch, an old switch maybe even, and you would have an IX. Those days are gone, long time ago. So what we are trying to do now is to get an infrastructure in place on all our IXs. Today, the infrastructure inside on each IX varies quite a lot. On NIX1, we have route servers, we have DNS servers, we have a lot of stuff. If you go to Tromsø, not much traffic, but no services either. So this is something we have to make more even, so that if you connect to an IX, whether it's in Oslo or regional, you should meet a kind of a service level that is what a modern IX really needs. We use IXP Manager, and we will continue to use IXP Manager. And we have a very close cooperation with INEX to do this. INEX are the IX in Ireland, and they are developing IXP Manager for the community. So we are supporting them and working together with them. So expect to see more IXP Manager functionality that is useful for you. Do you all know IXP Manager? Do you use the portal? Yeah, so a few people nods. Yeah, I guess, yeah. We also plan to put out route servers on all the IXs, not just NIX1, and we would like to encourage you at this point to use the route servers. We might do more than just encourage you to use it in the future, but some of these services are much more useful if you're on the route server. So we might have to do some route server workshops or something like that, I don't know. But we would like to have the usage of the route server much higher on the agenda for most of you. And as Herman said, we're upgrading hardware on all the sites to support 100 gig all over. And one of the things that we are looking into is redundancy, resiliency, regional, national. We don't really know what you want or what you need. That's one of the things that we're struggling a little bit with. There was a question about NIX2. which was started up 24 years ago, something like that, to be a redundant peering point in Oslo. We see that the traffic is declining. We see that the interest is also fading a little bit. We need to get some input from you. What do you want when it comes to redundancy, resiliency in the Oslo area? We do have a survey ready for you. I'll come back to that in a moment. But that's one of the things we'd like to know. What do you as a community need and want? And maybe how can it be done? I'll talk a little bit more about it in a second or two. But to continue on the resiliency path, we're working on DNS at the moment. I think we all in the audience know that DNS is very important for the internet. No DNS, no working internet for the masses. Maybe for some of us that remembers IP addresses, but a few of us. So today we have some root servers. No real plan. Oh, yeah, we can have a root server, fine. Well, oh, one more. Yeah, okay, we'll put it in here. So there has been no big plan on how we do this. So we are now working on I wouldn't say call it a project, but Hege and I, together with quite a few DNS experts, some of them in the audience, some not in the audience, we're trying to figure out what do we need, and what is Norway needing in a way of DNS? How can we ensure that we have these DNS servers in Norway, maybe even regionally? So we need root servers. How many do we need? 1, 2, 5, 10? I don't know. We have to find that out. Top level domains. What domains are important? .no? No, probably. .com? Probably. What about .uk? Is that important? Maybe for some of you living in the UK. But is it important in a region in Norway? We have to look at some statistics and find out, and also find someone that can actually serve these TLDs. And what about resolvers, public resolvers? There is a big debate in some corners of the internet whether to use these public resolvers like 8888, 9999, or 1111, or should we use the ISP resolvers, or should we make our own resolver, or what should we do? And we need to understand this and decide, should we have some of these or should we not? So our goal then is to put together a mix of DNS servers and deploy this mix on multiple NICS sites. Also to promote regional autonomy. Norway, a long thin country, could be that it's cut in half, or at least that the path between north and south becomes very, very thin. Then it would be great to have DNS servers closer to you if you live in the north or in the west, or might be a lot of scenarios. And we see that a lot of applications now, a lot of operating systems, they are huge on DNS queries. When you type in an address, they do a lot of DNS searches to kind of come up with suggestions of what you really want to write, so you don't have to write it all. And all of this functionality needs a DNS server close to you. So if you have any input to us on this, Hege and I are very, very welcoming it. So please contact us during the day, because we think this is an important thing. But just to be clear, just having DNS servers won't make the internet more resilient. It's one piece, maybe even a small piece. If we want to make things really resilient, we need to have content also spread out. And we don't think that is our task to copy all the content in the world. We might do some work on caching, but in the big picture, content must also be distributed and more resilient, but that is more on the content owner side. But without a resilient DNS infrastructure, there's no need to have a resilient content infrastructure. So this is one of the pieces in the puzzle that we think that we can assist in making happen in Norway. Another thing that we're working on and have been thinking about for a while is what we internally at least call the service AS. And It is a generic platform on all the IXs where we can provide services at the IX. A service could be a DNS server, could be a time server, could be a cache, could be different things, but a service that all the connected parties at the IX could access and use. Currently, when someone comes with a cache or a server to the IX, our IX today at NIX, there will be some speciality done to make it happen. Some caches have their own peering logic included. Not everyone has. So we get a lot of different solutions for really the same thing, offering services on the IX. We want to standardize it, making it easier and less expensive, and maybe more stable, we hope so, to provide services at each IX. Maybe also much simpler for us to implement new services, basic services like time services or something like that, maybe easier to roll out. So, yeah, I think you know all this will be a normal peer and host caches and other services. The target of this is not the big ISPs, because most big ISPs have the caches inside their network because they're big, but small and mid-size ISPs generally don't have that much caching internally, and they could benefit from this. And the larger ISPs might want to look at this for resilience. Just a second. Just to, like, if you have a cache in your network in Oslo, you might want to look at the cache in Tromsø to serve your customers in the northern part of Norway. Yeah, we had one question from Alexi.
Hi, this is Alexi from Finland. Is it your plan to use the same autonomous system at each IX, or should they all have their own autonomous systems for the service AS?
I would say yes, which doesn't really answer your question, but this is work in progress. Currently, we're looking at using the same AS, but we might also have situations where it would be convenient to have a specific AS for each IX, but maybe we need both. This is, as I said, work in progress. Hege is the one that works most with it, but we hope to finalize the design next year, and then we'll see. Maybe we'll start with one option and look for more. But yeah, if any of you from the international scene has good advice in this subject, please talk to us. We need some advice, I guess. Well, we would like to have this operational next year, but we'll have to see. There's limited resources in our end to make this happen as well, so we have to be careful. I talked about regional activities a little bit, and one of the things that we have in our 3-year plan is to be more active out in the regions. We think that for Norway, it's very important to have regional activities, have a regional community. And we are starting a process now to reach out. We'll start in the north. We have some contacts in the northern part of Norway, and we plan, Hege and I at least, to go somewhere up north. The actual site is not decided yet, and try to collect as many of the local ISPs or interested parties. People from Oslo area is also welcome, or southern part of Norway is also welcome, of course. And the main thing is to learn what is specific for the ISP community or the ISP world in the northern part of Norway. I've been quite a lot to the northern part of Norway for the past 20 years, and I know that it's different. Most things are different up there, but we don't know the details well enough. So we need to go up there and learn. And there we have a lot of questions. Today we are present in Tromsø, and is that the right place to be? Or is it some other place up there? We don't really know. And we don't know the infrastructure, not well enough at least. So this is one question. And another question is, should we have an annual meeting regionally as well? Is there any need for local training? Is that something people would like to see? I know that a lot of people up north are tired of going down to Oslo for everything. So what should we bring up north to make this a better thing? And our plan is that when we have started up north, we will continue around the coast in one direction or the other. Well, let's see. Time and sync. 2 years ago at the NICS-NONOG meeting, there was a presentation about time and frequency in Sweden. NetNode had that presentation. And that triggered a great discussion at that meeting and triggered a lot of work afterwards. So we are a local working group. Hege, Petter, and myself have been very involved. Also, a lot of other people have been involved in this. So this is about having a time and sync infrastructure that is not relying on satellite, GNSS, but having accurate time and synchronization available on the ground. And we are still working, but it is progress, I would say. I can't go into any details, but we see that there is progress. And this is, of course, important for a much larger audience than just this industry. It is important for finance, for everything to do about transportation, for the power sector, we have a list, we have a document with a lot of parties that need accurate time. And as we see in Norway, in the northeast, GPSs or GNSS signals are jammed quite regularly. I think it's been jammed now for more than 200 days consecutively. So you're not that affected on the ground yet, but that might change. And we see that from other conflict areas, GNSS is either jammed or actually jammed by one party or the other party for as offense or defense, depending on what you're doing. So there is in this world a need to start working on a land-based time and sync infrastructure. So things are happening. And we might play a part as a possible site for time nodes, might. But we expect things to start happening next year. Maybe not operational, but at least things starting to roll next year. And this is one of the things that this community is very good at. When there is something interesting, we start to talk about it, we put together some people, we start working on it, we pull in the right resources, we get the ball rolling, and then someone takes over and makes it happen. So we should be proud that we are an arena for fostering these kind of ideas and bringing them to life, hopefully. I'll round up with the survey. We are making a survey because we need to make some choices for the future of NICS. And we need some input. One of them is what to do about NICS-2, or what is the need for resiliency in the Oslo area. And we also need some more input on the regional IXs. A few of you are connected regionally. What would make more of you connect regionally? Or shouldn't we do any regional activities? We need some input. And we also have a few questions about our websites. We'll use a couple of hours. No, it's only 5 questions. And all NICS members will get the survey shortly after this meeting, I think. Yeah, Hege is the editor of the survey. So please take 5 minutes, give us some feedback. It'll be valuable for us to know a little bit more in detail what you need. And just since it wasn't a question about NICS-2, one of the things about NICS-2 is that it is today the peering point is it needs an upgrade one way or another. And one way of upgrading is, of course, having it as a separate peering point still. If that is not to your liking, should we have redundancy options at NICS-1? We have many different ways of doing that. We could have the links model, where we have two separate, completely physically separate infrastructures on all sites. You can have the NetNode model, where you have one physical redundant infrastructure with logical separate networks. Or you can say that our redundancy is Stockholm or Stavanger or Trondheim. We don't need it in Oslo. We need some input on what's your needs. We have maybe a couple of minutes for questions. Maybe? No questions. Everything crystal clear. Okay, thank you.
Thank you very much, Kjetil. Let me just find the right slides here. Ben, can you find your slides, please? Yeah, if you know your name of yes, it's there. Yes. So Ben is a systems engineer by day and bad ideas blogger on the side. And Ben is currently focused on making day-to-day BGP operations less awful with BGP tools. Thank you very much for joining us, Ben. This is, I think, only here. So, yes. How do you take it?
Yeah, I can do it.
Do that, and then very well.
Awesome. Okay. I did not plan for that. Okay. Does this work? Excellent. Hi, my name is Ben, and this is a talk about the send hold timer. So, the hold timer in BGP. So BGP is a TCP-based protocol. I'm going to use my phone to figure out this now because I can't look behind me. So BGP is a TCP protocol, and that's a bit of a problem because, come on, baby, because TCP does not, by default, have connection timeouts. And so each peer, to solve this problem, sends keep-alive frames to each other, typically every 30 seconds. And then there is a wider timer in BGP called the hold timer, which basically resets every time you successfully get a keep-alive packet. So that if the 90 number goes to 0, the session shuts down. We just heard about this in the context of shutting down the internet exchange for maintenance. You want to actually block these TCP packets so that you can drain traffic out of the exchange without impacting traffic at the same time. This is why it works. So you can lower this time to be slower, or not to be slower. God, don't make it slower. But you want to make it sooner. People use this as a sort of very YOLO way of doing like high-speed failover, where high speed is measured in a maximum of 3 seconds. You can also, if you really want to, disable the hold timer. If you do that, don't. It is technically supported, but if you do, no, absolutely not. So the real core problem, though, is that BGP is TCP, and TCP is, when you really zoom out and look at it, is best described as an underspecified two-node consensus algorithm. So when you send something, when an application says, hello, I would like to send some data to another thing, it puts it in the send queue. So the application, as far as the application is concerned, that thing is gone. It's sent. It may have arrived to the other side, but it has no way of knowing that that has happened. So here is where this really gets quite nasty. So you have some BGP daemon on one side. I don't know where the clicker is, where the thing on, whatever. You have one BGP daemon on the other side, and you have another BGP daemon on the other. And so there are two queues here. So there's the send queue, and then there's the receive queue. Both sides are completely disconnected from what the application can see, aka the BGP daemon, the thing that controls the actual routes. These can be full in different ways. So if both sides are full, though, things get really interesting. When you try and send something, you can't do it because the buffer is full. So there's two things it can do at this point. It can block, as in just stop the application from working at all in hopes that the queue eventually drains. Or it can just say, hey, buffer's full, mate, try again later. This is kind of normal. So in a situation where you are bringing up a full transit feed or you are sending a full BGP routing table to another customer, this is going to happen because things are slow, things take a while, and the buffer is going to get full. You can't just disconnect a customer. You can't disconnect a session when this buffer gets full. You have to sort of have a better way of handling stuff when it blocks. But yeah, the critical word is, but you just hope. Hope is not a strategy, but you hope that the socket eventually becomes unblocked because you may be stuck forever. In a normal universe, send hold timer, sorry, not send hold timer, the regular hold timer, we'll get into send hold timer later, catches this because the other peer has died and is not going to send keep alives anymore. So you get sort of best of both worlds. However, there is a really nasty problem. Sometimes BGP daemons can get stuck reading their socket, but they will keep sending you keep alives, making you well and truly deadlocked because you can't send anything, but the other side is renewing its ability to hold on to the connection. Everything as far as your side keeps working, but you cannot send anything to them. This is really bad. So the symptoms of this is that your routing table will go sort of stale, so you won't get any new routing data, and this will impact your downstreams too. So if your downstreams are doing this for traffic decisions, which most will be, I assume, you'll just get stuck routes that shouldn't be there anymore, routes that shouldn't be going through that transit anymore. When people look at the AS paths, things don't make sense. Yeah, you should care about this because you and your upstreams may have traffic engineering rules to prefer certain AS paths from another, and if that is not actually true, then you may be sending traffic either to the wrong place or to a place that can't have that traffic at all. Think about when NIX, for example, shuts down for maintenance. If NIX is not actually able to route that prefix, it's going to black hole, and that's very bad. Or even worse, it might send it to a supplier, to someone who isn't that person to the customer anymore. These things can go on for days. Why do I care about this? So I run a site called BGP Tools. At the core of it, BGP Tools is a route collector, which means it just collects people's routing tables and aggregates them together. Stuck routing data is a real big pain because it provides a warped view of the internet that I have to manually detect. Well, manually, it's getting more automatic these days. But it annoys me and it annoys my customers. And so I built this thing to test this out. So this is the clock. So I put a /34 of IPv6 to work. Every single hour, there is a new prefix. The hexadecimal is basically the integer hour of the year encoded. Currently, at any one time, the machine doing this is only ever announcing 2 prefixes. You may notice there are more than 2 prefixes listed here as currently visible. This is the problem. So there are a whole bunch of prefixes here that just are stuck. Where are they stuck? It really depends. Various bits of the internet just not working correctly. I said there's actually 13. I lied. So there's a button on the top that says hide low visibility prefixes. If you show the low visibility prefixes, there are like 40. So there's 40 various states of prefixes. So there's 38 stuck prefixes that should not be there that other people on the internet think that are in the routing table. This is bad. I want to do this on IPv4, but obviously IPv6, the space is very big. On IPv4, the space is very expensive. And so I don't have that much money. So we've clearly proven that this is a problem. So how do we fix this? So we mentioned before the hold timer, counts to 0 and goes up when, or gets reset back to its maximum when you get a keep alive. So what if you just had a send hold timer? The similar idea of a hold timer, but when you can successfully send something to the other side, you just reset it back to its top. You don't have this number very low. In fact, in my opinion, you shouldn't be able to configure the number at all. This is as a worst case level of detection for when the worst happens. So the mechanics are, say we go back to our previous thing, Bird, OpenBGP, and FRR are currently the things that support this, so I'm not just leaving Juniper and Cisco out of here for no reason on one side. So Bird is sending stuff. And so every single time it successfully sends data, it resets the send hold timer. Eventually, if the worst happens and the queues get fully backed up and it can't send anymore, this number starts going down. Eventually, it hits 0 and the connection blows up, which is useful. You actually want this to happen, in which case the stuck prefixes are instantly killed and the internet continues on routing along. So, decide that stuck has potentially been saved. It's hard to know. It's in a bit of a broken state, clearly. But your side has gotten rid of the connection that has been deemed broken and has not been stuck. Currently speaking, there are 3 major implementations that implement this: Bird, FRR, and OpenBGPD. These are basically the full deck of support for open source implementations. You'll notice that none of the hardware vendors support this just yet. That's because not only is this still going its way through the IETF, the standardization body, but also a lot of these companies are sort of demand-oriented. They build what their customers are asking for. So once we get through the IETF stage, or maybe even before, you should consider asking your vendors, can I take questions at the end? Thank you. Hey, what about send hold timer? I said something about the IETF and standardization. So how hard is it to get an RFC anyway? I got time, right? Good. This is going to be a good one. So how hard can it be to get an RFC? We see RFCs as sort of these like Bible-like documents. And so, getting something standardized should be interesting, right? So in this easy, simple 30-stage step, I will show you how to get an RFC. This is one of the simplest ways I could show it. The green is the bits that I have successfully, or me and my co-authors have successfully done so far. I have question marks there because if I knew, I would document what is next, but that's the nice thing about the IETF. You don't really know what's next sometimes. Always full of surprises. So at the core of it, this is what a draft looks like. So the IETF works in this world of internet drafts, IDs, and not every ID becomes an RFC, but every RFC was at some point an ID. So this is the send hold timer internet draft. There are 3 authors here. There's Joop Snijders, there's Ben Carrot-Cox, and there's another person. And so we'll go through the timeline now. So initially I published a blog post called Hunting Down the Stuck Roots. And at the same time, I basically alluded that there was probably a way of fixing this in the BGP protocol. This is what send hold timer was supposed to be. At the same time, me and Joop published draft spaghetti IDR BGP send hold timer. The term spaghetti is there because you can put anything you want there. And why not put something silly? At least it means that you can see what you're looking at. Now, at this point, you start writing a documentation format called XML to RFC. The IETF uses XML to generate their RFC documents. You can write anything you want in here. And so you run this thing. You install XML to RFC in your suitable IETF containment zone on your computer. And then you can just run this command, and it generates all the stuff that you want. And then before you know it, you've got this. So XML to RFC also nicely renders like PDF and HTML files for you. Yeah, it does that sort of iconic look from all the IETF documents. That's how it's generated. You can also generate anything you want in here. For example, here's the Wikipedia page for Skibidi Toilet. If you don't know what that is, you're living a better life than I am. At that point, you then upload it to the IETF data tracker. This consumes that XML and processes it in some way. And then, so you just throw XML into this thing. It emails the authors if it already knows that it exists and say, hey, was it you that uploaded that? Do you want to approve that new version of the document? And then everything onwards is sort of just tracked inside that system. And this is the interface that you get, as I alluded to earlier. You can see each version across the timeline being updated. And at some point, we drop to a different name. When you first publish these things, because the IETF works on sort of consensus-based stuff, you normally would get a lively email discussion. So initially, when we dropped this, about 40 emails, I think, were exchanged with various participants, which is good. It's interesting to see what other people's points of view are. And yeah, it's just interesting. So IETF discussion. So IETF is an interesting standardization body because it requires no money to participate. So you have things like IEEE and 3GPP and the GSM. These people are paying to be a part of the body to standardize the thing that they are hopefully producing. The IETF is not like that. You can just show up, subscribe to the mailing list, and throw your opinions into the ring. This is good because it means that more eyeballs on things. I don't know what it looks like inside things like FreeGPP, but I think that more eyeballs on things is good. The downside is that some people can be very annoying and potentially participate in bad faith. Anyway, assuming that you've gotten far enough down this, you can request adoption to the working group. This basically says that, hey, like I think this is, we want to take the view that this is more than just a good idea. We want to actually like run with it. We want this to go to the next stage of like standardization or closer to standardization. This in itself, because it's balloted across the mailing list, triggers an even bigger, lively email discussion. I would say that a lot of send hold timer was particularly lively because at the core of it, it is patching BGP, and you don't really get away with patching BGP without a fight. There are so many stakeholders in BGP, and there are so many opinions on how to do it correctly that this was always going to be a bit of a dodgy thing to do. Not in dodgy as in bad, but it's dodgy as in how do you correctly write down the instructions in the correct IETFE language to make sure that everybody is satisfied with what you're doing. So the other thing that I was going to mention is what is the IDR bit of that document. So the IETF is split into different working groups for various subject areas of work. There's only a few of them. In our particular one, we're interested in IDR. That's Internet Domain Routing, or I think it's Internet Domain Routing, or inter-domain routing probably. Two different sections of networks talking to each other, inter-domain routing. That gets adopted into, because the IDR is focused on things like BGP, which is what most two distinct networks, autonomous systems, talk to each other with. That is sort of their interest. And so that's what people are subscribing for. That's where the moderators are, etc. Once you get this adopted, it's now actually just part of the sort of agenda of the system, of that mailing list, of that working group. This still doesn't mean that you're going to succeed in getting an RFC published, but it just means you're a little bit closer. And then at some point, you get a working group last call request. If you've worked out all the kinks, if you've handled everybody's feedback, you can eventually get a last call request. This is basically the last time for people to say, like, no, I really don't want this, or I think I have some critical issue with this. And assuming you've solved all of them, or solved them to at least other people's satisfaction, you can, basically, everyone checks if the vibe is right, everyone figures out if they like it or not, or if they accept the status quo. And then basically at that point onwards, you're not dealing with the mailing list, you're just dealing with the working group chairs, something called the IESG, IANA, if you need like numbers allocated and things like that. So we got to the point where IESG was requested, last call requested, and then you deal with these lovely folks. So there is a group of, off the top of my head, there's 10 or so people who do the sort of final review. These are sort of experts in the domain, and it goes to a ballot. So if you go onto the IETF data tracker, you'll see this thing at the side. That means that it's currently in this IESG ballot phase. This is interesting because you can see up there, there's like this weird grid pattern. That's basically showing what people are voting for. So there are 4 possible states. There's yes, no objection, I don't want to vote on this because it's a conflict of interest, and discuss, which is the closest you'll ever get to a no. There are no's, there are no no's. There's only room for more discussion. And sometimes the discussion comes with, lots of text. And, sometimes it's genuinely useful. I think discusses are generally quite rare, but discusses generally come with the most feedback. We got through this, we passed the ISG ballot, and now it goes into the land of the RFC editor. So the RFC editor? Yeah. So the IETF basically employ full-time editors to basically just handle the stuff coming in that they would say, hey, we would like this to be published, we want this to be finalized, but because these documents are sort of enshrined, you really want to make sure they don't have any spelling errors or they follow conventions correctly. So these people spend their full time basically going through various RFCs and making sure, or RFCs to be, and making sure they're correct. Now, this is fine because this is where our stuff currently is, which is fine by me. Some stuff can spend a very long time here because there are some RFCs that are over 100 pages long, and checking every single one of those, every single page for XML issues or just general nits is a pretty big task. So I think I wrote a few weeks ago that I think I'm only a few weeks away from being published, but I still think I'm about a few weeks away from being published. Who knows? I think by the end of the year, that would be nice. So yeah, a simple 30, I think this is 30, maybe 38 steps. And there's the whole timeline if you want to, for some reason, get an RFC. In hindsight, I don't think I would do this again, but I don't regret doing it. The other thing that if you are planning to go for like IETF standardization or an RFC is you really do have to have someone who is experienced with the process help you with this. There is, in theory, a like 100-page document somewhere on the IETF website that explains the entire thing to you, but it's basically 100 pages. It's a book, and it's sort of. I think it's very hard for people in the IETF to write about the IETF for people who have never experienced the IETF, and so it still is a bit of a sort of reality warp. So having someone there who understands how this works and has been in your shoes before and has no idea what's going on is very useful. In fact, not even just very useful, basically required. Also, just motivating you to be like, hey, I know we're 3 years in, but keep going. We'll eventually get forward. The 4 years thing, it's entirely possible that a lot of this was screwed up by COVID. IETF runs meetings every half year, maybe every quarter. I think it's every half year. 3? 3 a year. Oh, what a lovely round number. And so, because during COVID, none of this was really happening, or it was happening online, things just didn't work the way they were designed to. A lot of the IETF is people seeing each other face to face and sort of, hi, how you doing? About this draft, what do you think? And so without sort of the face-to-face context, a lot of stuff just didn't work. And as I said, changing BGP behavior is extremely contentious. There's a lot of people who have BGP implementations and have opinions on especially things like failover. So yeah, I was not expecting that much of a fight, but there were some people who really, really didn't like the way we went. Anyway, this is the thing that you should care about though. The vendor list, because ultimately you can have an RFC. As mentioned previously, every RFC was an internet draft. Not all internet drafts are RFCs, and not all RFCs are implemented. So implementation is the really critical one. I would love to see more vendors get out there and implement that. Yes, if you are running software that has the capability of doing this, you probably don't need to enable it. It's probably just enabled automatically. If you have the option to upgrade to something that can do this, please do. RFCs are a whole skill on their own. Like, that's a completely different thing that I hadn't really dealt with before. The fight is not over on stuck routes. This will not solve stuck routes. I think that only about 30% of the stuck routes on the internet are through this mechanism. The rest are just various vendor bugs that I have yet to fully disclose and find, but I think I found a good percentage of them. A few days after writing these slides, we actually got confirmation that the send hold timer mechanism in Bird had actually correctly triggered on a real customer session and had prevented stuck routes from happening. Just really, really good sign that the thing is working as intended. Any questions?
So, Alexei from Finland again. I've got two questions, but I'll start with the first one. So this only affects the local behavior. It doesn't implement or it doesn't introduce any new options or attributes or anything in the packet stream.
It's just changing. The bit that it's specifically changing is there's like a state diagram in BGP. It's messing with that, the finite state machine, which is mostly where the contention came from.
Were there any other question, or should I go for my second one?
There was one over there.
Okay, let's him.
So Tor Andersson again. I was wondering if you have a full send queue timer or your send queue is stuck, doesn't that mean that your keep lives also got stuck? And if so, why don't the remote end tear down the session? Is that because all of the remote ends are insane and have disabled the whole timer? Or
No. So it's much more. It's a really good question to ask, and we're going to have to go way back here. So the thing that a lot of people misunderstand about TCP is, let's see, is this button there? Okay, this is. So this is one. So TCP, you should stop thinking about it as like a magic pipe. TCP is actually like two distinct pipes, only slightly separate, joined together by like a coincidence in your operating system. Is the nicest way I can describe it. So this thing can break down, but this thing can be completely fine. So you may able to be one side may be able to send as much as it wants, but it may not be able to receive. So this is where it goes wrong, because both sides are sending keeper lives to each other. So if this thing clogs up here, if the top one clogs, but this one for some reason keeps sending keeper lives to you, you are not going to be able to send, but you keep getting keeper lives. So you won't kill the session unless you have send hold timer. And let's assume this side is just broken because, well, I mean, it must be broken because it's not receiving stuff. It's not like consuming stuff off the TCP stack. So this thing is already cooked. So you can end up, and as proven already, you can end up in this stuck state where stuff is locked like this forever.
Right, so if the right side, or if the left side here can't send TCP, BGP protocol messages, including keep alives, why don't the right hand side, why don't the right hand side notice the absence of keep alives?
No, but it's still getting keep alives. So this at the bottom, keep alives are still coming through this mechanism. But this side, okay, so like on this side, we'll say that I am, this is me, and this is someone else, right? So I can't send anything to them anymore.
So the keep alives are unidirectional.
Well, they come on both directions, but they are unidirectional. So you're supposed to keep both sides send them to each other all the time.
Yeah, but how can they be sent if the send queue is stuck, if it's full?
Yeah, I can't then send a keep alive to you either.
Exactly.
But it's fine because that's not, if the send hold keep alive, if the send hold timer is enabled, then this will explode because I won't be able to send anything full stop.
I can.
Yeah, go.
Good day, Ben. This is
Hi.
Pim from Switzerland. So I think the question there was, the bird is sending keep alives and the RPD is sending keep alives, yes?
Yeah.
But the send queue is clogged and the RPD is not receiving anything.
Yep.
So why is it not timing out the session because it didn't receive the keep alives from bird?
Well, if it was, yeah, that's a good question. But the answer is basically is if you're in this situation, the BGP daemon is broken. Like this side, the RPD is just, it's clearly not doing any work anymore, but it's doing something, because I think a lot of this comes from a lot of newer BGP daemons are multi-threaded. And so the thread that is generating keep alives is different from the thing that is reading and processing stuff. So that thread may be okay, and it's still sending out keep alives. But the thing that's actually reading and processing stuff, long gone.
Hi, this is Alexei from Finland again. It's been a while since I last read the BGP RFC, but if I remember correctly, update packets also reset the timer. So if the RPD is slowly processing the stuff, then it'll be resetting its timer every now and then anyway. The other question I mentioned I had was that there's also an effort to port BGP over quick QUIC.
Yeah.
Do you think that's orthogonal to this issue or not?
I mean, Quick has many challenges. I'm not entirely sure I see, this is my personal opinion, I'm not sure I see a use case in BGP over Quick. I've yet to see a really convincing argument for that. Quick has its own issues with timeouts, although mostly speaking, what Quick is emulating is sort of proto-TCP, right? It's TCP, but both sides have a better... Quick is a very nice way of cutting the operating system out of things like congestion control. And there's a few other cool things enabled in there too, but I think the core reason why people are really interested in Quick, and by people, I mean people like Meta and Google, etc., is because it means that they can remove the remove the Android TCP stack from their equation. They just need UDP, and they can implement whatever they want. Now, there are many reasons why they would potentially want to do that. Some of them are legitimate. Yeah, and so I don't really see the same need for that in BGP. There are some fringe use cases, but I think, as far as I understand, they are pretty fringe.
BGP has also been already defined over SCTP, but I don't know.
I've never seen that in my life, like in the wild.
I think it's something to do with the telco. Well, somebody in the telco land probably uses it for something completely different. But
Yeah, I've never even seen equipment that has that like configurable. I think that's sort of one of those things that was written down in the same way that not RFCs actually get implemented. I've never seen BGP over SCTP support ever exist in a vendor.
Yeah. Hi, this is Ulrich. I just had a comment to your IETF traveling, and I would say a lot of people get frustrated with the process and think that it's very slow. But I would suggest trying some of the other organizations you named.
Yes, I mean, I have no.
I think the IETU. I mean, it's not even possible to get it under 10 years. So I think compared to the other standards organization, the IETF is still very fast.
Okay.
But you know, I still get the frustration.
Yeah, admittedly, I have not dealt with any of the other standardization bodies. Yeah, so in theory, you can get RFCs hypothetically if everybody loves what you're doing, and you were the first person to think of that. You can, in theory, do this in like less than a year. I think in practice, though, you're spending a lot of time fighting on mailing lists. Cool. Is that it? That was a lot of slides. Short comment.
So back to Ulrich, I'd like to, and to you, I'd like to say that IETF needs operational people. Otherwise, it's just a bunch of academicians coming up with funny stuff. They need input from this community.
Yeah, I think, and yeah, I would say if there's one thing that I have been, the one thing that I have taken away from the IETF process is that I wish more network operators were involved in things like the IDR mailing list. Because some of the things occasionally suggested on those mailing lists were like so far disconnected from the process of actually running a network, where it would have been really helpful for someone to like chime in and say, hello, I run some percentage of the internet traffic in Norway, and no, that's not what happens. That would have been a useful thing. I mean, some people did eventually do that, but the sort of difference between the operators and the people on the implementation side are understandably they're different disciplines, but it would be interesting to mix more together. Because I mean, ultimately, you're using these protocols anyway, so you should probably understand or have some say in how they work. Cool. I think that's it. Thank you very much.
Thank you very much, Ben. Thanks also to Kjetil and Herman, also for bringing us back on time. We have a break now until 11 when we reconvene here. So enjoy your break and your mingling. Yes. Welcome back, everyone. We should be starting the next presentation, so we can keep on track with our day. So our next presenter comes from Finland, is Markus Lira, who is the sales director for Elisa's innovative smart energy solution called Elisa DES. He has been involved in telecommunications industry already during the last millennium. He recently returned to the telco sector after spending the last decade in the global software business. He finds it fascinating that while telcos once viewed electricity solely as a cost, he's now see it as a potential revenue source. So welcome, Markus.
Good morning. I hope you all enjoyed your coffee. Let's start with a little bit lighter foot and with a story about the Finnish character. 3 guys, 3 friends were walking in a forest. It was winter time. They came across with this big animal, a moose, an elk, as you know it as well. The guys were Norwegian, a Swede, and a Finn. Hope you haven't heard about it. It's a little bit changed story. Okay, the Norwegian was looking at the animal and he was thinking, I bet I can ski much faster in this snow than this animal can run. The Swede was thinking that, what a beautiful animal. If I shoot it and get the head on the wall of my cabin in my summer cottage, my Norwegian friend, the neighbor, will be so jealous about it. The Finn was looking at the big animal and thought to himself, I wonder what this animal is thinking of me. So today I'm going to share you what we have done at Elisa, how we have made electricity as from cost element into a new business, a profitable one and also a sustainable one. So I would like to share you the story from real life, how we have turned our radio access network as a mobile operator into a virtual power plant. So first I would like to share you the big picture where we all live in, because that is really having a great impact of what we have developed during the last few years. Then I would like to share how there is a disruption going on in the world related to this business where we are. And then going to the details about what we have done with Elisa. We have created a software solution which is AI engine, and it's creating us both savings with electricity but also new revenues. And then I would like to share you with the benefits that telcos can have from this kind of a solution, because we are also providing it to our fellow telcos, and then it only not impacts telcos, but all of us as consumers of electricity as well. So the big picture here, we all know this, we are all living in the climate change. The global warming has its impacts. There are heavy rainfalls, droughts, fires in the forests, etc., etc. Funny thing is that the last summer in Finland was the best ever I've experienced. It was like you would be golfing in September like it was June. But of course, this is maybe just the start of the big change coming to the Nordics as well. The huge disruption I'm referring to is related to the climate change, so that the increase of renewables is really, really great in our world. There is more wind energy production, there is more solar energy production, just to fight the climate change, that the global warming would stop. At least it would decrease from growing. And at the same time, the electricity, as being a funny thing, you cannot store it easily. There is a lot of growth in the battery parks all around Europe, for example, all around Nordics. The growth of the batteries is estimated to grow significantly in the future as well. We've all experienced probably the changes in electricity prices. What happens when there's no wind? What happens when it's not shining? What if it is shining and it's very windy? The prices may go down to zero. Of course, that's good for the consumers. Actually, they've been negative also. But when it's not windy, when it's not shining, the prices can then have a peak, and that's not good at all for us as consumers. These are the things that we are dealing constantly, and of course it's quite a headache for us as consumers when we think about the price variation. And it would be nice to have a fixed tariff, for example, from my energy supplier, but at least personally, I'm not having a fixed one, so I'm constantly watching what the kind of prices I will have. If I want to go to sauna or something, it affects my behavior. Batteries is one solution, and today we are talking about batteries. But actually, there's a bigger headache for someone else, and this player, this stakeholder, is extremely important for our business. It's the TSO, the transmission network operator, for example, Statnett here in Norway, Fingrid in Finland, because the electricity, I mentioned it being a funny thing, but actually it's not funny at all, because you need to keep the grid, the electricity grid, in balance constantly. Every hour, the production, supply, and the consumption needs to be in balance. Every minute, and actually every second, it needs to be in balance. And like I was saying, that when it's not windy, when it's not shining, there needs to be some flexibility with the grid operator so that they can somewhere get the supply that's missing. And this actually is the business opportunity for our innovation, because the TSOs are willing to contribute financially, basically pay for companies who are big consumers of energy if they can adjust their consumption. And this is also what we have realized. We, as an operator, are a relatively big player with energy. We consume it in our radio network quite a lot. And when we can adjust our consumption, TSO, the Fingrid in Finland, Statnett here in Norway, and every country there's a TSO, they are willing to pay us when we can help them to balance the grid. This is the business potential. And there are actually few drivers in the market at the moment. Here you can see, for example, on the left corner, the increasing electricity consumption forecasted here for Norway, for the Norwegian market. The question only is that what is the pace of the growth? It's not that will it grow or decrease the consumption. It will definitely grow in the future, but what is the pace? In the middle, then you can see that the increase in renewables in Norway is going to be huge by the 2050. Estimation is that it will grow up to 700%. So 700%, that's a huge impact. But for the Norwegian market, you have a special case here because a lot of the electricity is produced by hydro. So the hydro production is very flexible. But it's not the case in all other countries. If you are, let's say, running a nuclear power plant, you just cannot stop it from producing energy. Or if you are still doing the conventional fossil fuels, gas plants or coal plants, they cannot adjust their consumption that easily. But if, for example, we using batteries can adjust our consumption, we are very valuable partners for a TSO. Good thing is here for our business case, which we actually started a couple of years ago already, that the prices of batteries have gone down significantly. I'd say that 80% during the last 2 or 3 years they've gone down. And they are still increased to decrease because the chemistry of the batteries is going to develop. And of course, there will be more production as well. So trying to conclude here that there's a multi-billion market available within energy for companies, for telcos, but also for other companies who are consuming a lot of energy or who are dealing with energy storages or batteries. The market is called reserve markets or balancing services market or ancillary services market, and it's operated by the TSO, and it's pretty much similar to stock market. So there are different kind of products, if you say, which the TSO is offering, and then you can participate them by adjusting your energy consumption. Of course, we want to avoid those cost peaks, and that is one of the key drivers to advance this business. And even though the renewables, or actually when the renewables are going to increase significantly, the gap between being able to adjust and help the TSO to balance the grid is going to need to grow even much more higher pace than what the renewables are doing. So we see that as a promising market for future years to come. So we see that there is still markets for quite many years from now, because we see that this trend is really happening, that the increase of renewable is a fact. For telcos like Elisa, it's been a very natural development that, because we've already invested in our base stations, you know these big towers that you see everywhere in the country. We've invested in those, invested in their connectivity, and we actually had batteries in those sites as well already beforehand. Now we've just put some additional capacity to the sites, but we had the premises. And if you would be investing in a power or battery park somewhere, let's say close to here, you would need to build all the premises and put the batteries there. And the batteries are maybe only 40% of the investment required. But since we had all the premises available, our investment level at the moment is lower, meaning that we can be more profitable also with our concept. When talking about the batteries, the old-fashioned lead-acid batteries are no good for this business because we need to have more cycles and a more advanced technology, and we are talking about the lithium-ion or LFP batteries. Just a small comment about it. Well, this is then what we have done. We have created a virtual power plant out of our base stations, and in the middle you can see that there is this software solution called Elisa DES, Distributed Energy Storage. And it's a full end-to-end solution, so it's charging and discharging the batteries based on the commands required from the electricity market. And the AI solution in the middle is quite capable of, it needs to actually be able to predict prices of the electricity for the next day. and it takes into account various inputs from weather forecast and whatever, and then it makes the predictions, and we need to be able to bid to participate to these energy markets. And then we constantly take care of the batteries on the radio access network side. We charge and discharge them according to the need. So imagine that there are thousands of sites around the countries, and we monitor them constantly and then control their state of charge. The first customer for us was Elisa, our own company. So I come from a kind of an internal startup within Elisa. So the first customer was Elisa, but nowadays we have a few other customers as well. For example, Telenor is our customer with actually their subsidiary DNA, which is our rival in Finland. And we offer this to all of the operators around Europe, and there's been a lot of interest with other companies as well, and hopefully we can disclose more names. We are running this also in Estonia and the small island between Finland and Sweden, Åland. There we are operational as well. So what did we actually do when we made this thing? We selected some 2,000 of the biggest sites in Finland, those base station towers, and we had there already 2 to 3 hours of capacity available from the lead-acid batteries, just as a backup. It's regulated in Finland that you need to have backup service, because if you are disconnected from the grid, you need to be able to provide the service for your customers. So we replaced those backup batteries with lithium-ion, and we added 2 to 3 times more battery capacity for the market trading purpose. And with those batteries, then we can have a pool which we can charge and discharge according to the need. And then we were connected to the FinGrid, the local TSO, who offers this electricity market, and we could participate there. There was a certain process, technical process, that we needed to pre-qualify ourselves so that we are capable of doing it, like the other power companies are doing it as well. But it worked out fine, and now we've been operational for, actually the anniversary of 2 years comes this December. So we participate to the balancing services market, and it was a tough decision at the time for management to allow us to invest quite many millions to this business, but I think they are happier than ever now when they are seeing what kind of revenues we're recording from this. But it's not only the financial outcome which is good for a telco. We have calculated actually that the radio access network, out of the electricity that it consumes and how much it will cost us, taking into account the savings and then the new revenues that we get, we can cut half our electricity bill, which is quite nice. But on top of that, imagine that we had down earlier 2 hours or 3 hours of backup capacity. We can now add 6 more hours to it. So we have up to 9 hours of capacity if there will be a disconnection from the grid. And who knows what will happen if there is these extreme weather events. Somehow the grid might be disconnected from somewhere, but still we can run our service. And some of our customers really, really value this, that the quality of service is extremely high. But then the sustainability element. I'm pretty sure that most of your companies have a strategic decisions or strategy where you have sustainability mentioned as one of your goals. So do we. And when you are consuming electricity from the batteries, basically it means that you have charged them up from the renewable energy, which is the lowest price normally. And this way we can calculate the reduced amount of emissions from our business. And we've been awarded some acknowledgement, of course, from our innovation, and we are still, even though we've been running this for 2 hours, we are living in a world which is relatively conservative, talking about the telcos, and when we are marketing this to other telcos, it takes a while for them to understand this, because imagine telcos being in a services business with consumers and businesses, and then we come and say that, hey, your electricity consumption can be turned into revenues as well. Not only you need to pay the bill for electricity. So it takes a while, but we are in a good pace right now, and hopefully by the end of the year we have gained some new customers, which we call actually partners, because we are doing this not only by selling any licenses, because we don't sell any licenses. We do this as a partnership with our fellow telcos all over. I still have a few minutes available for any questions, so feel free to ask anything, because the story is pretty much here. And I was mentioning that it's not only good for telcos, because when we are able to balance the grid, it means that the TSO has easier life, and it will decrease the variation in prices for consumers as well. So we are helping with telcos, we are helping also consumers so that we don't have that high prices for electricity that we pay. All right, thank you all.
Hello, this is Ulrich. You mentioned that you bought a lot of new batteries for this.
Yes.
What time of return on investment do you calculate on this?
Excuse me, say that again.
When do you think that your investment in the new batteries is going to be paid off?
Oh, less than a year. So imagine this from the profitability point of view now, when the prices of batteries have really gone down. But of course, there's a huge harmonization taking place in Europe, that all the EU countries plus Norway and Switzerland are in this development at the same time, that these markets will be similar, but there are differences in the electricity market in different countries. So the profitability of this business changes a little bit according to countries. Nordics and then the Benelux countries are extremely good for this business at the moment. The Middle Europe, maybe Germany will follow quite soon, and then if you go more down south, they are coming a little bit behind. But it will happen within the next 10 years, the same development, the same trends in those countries as well. And then the markets will be harmonized, so same type of products in each of the countries. And of course, if we see this development of batteries going, the prices going even down from now, this point of time, it's good for the profitability as well. Yeah. There's another question over there.
Hi, Ben from BGP Tools. How much power does one... So you said you had 2,000 or 200,000, I forgot the number of base stations that you've enabled this on. How much does a base station normally consume in power?
That's a little bit confidential, of course.
Oh, okay.
But let's say...
you could multiply the number, right? Like you gave
well, if you keep it to yourself, I can say...
I will definitely keep it to myself.
Yeah. Good. Oh, this might be recorded. But on average, we can say when we've been discussing with the telcos all around Europe, the average doesn't vary too much from 5 kilowatts per base station. Yeah. But with the adding of 5G and maybe the next Gs as well, it will increase the power consumption within the network as well. But that's a kind of average estimate.
I also have a question. You said that you're regulated to have at least 3 hours of uptime on the base stations from the Finland state, and then that you increase the battery capacity to be able to support the variations. What measures do you have in place to make sure you still have 3 hours in case failure occurs when you're on batteries?
Very good question. But basically, the pool is one unit consisting of the backup power, like the nominal backup power that we have defined, and then the reserve that we have for the reserve markets. But we never go under. the certain limit. So there is always backup power enough, which is regulated, which we need to have. So we never go below that. So basically we consume for the business only the kind of the upper part, the reserve market capacity that we have for that. Yeah.
Just have a question regarding having any power saving on the base station itself when it's period in the night when it's low capacity, shutting down sectors or frequencies.
Sorry, don't hear that well. So can you say that again?
So the question is, I understand you do all charging on the battery, but have you done some power optimization and saving power on the base station itself during, for instance, low capacity time during the night?
Extremely good question, and I forgot actually to say that one of the benefits for telcos is that this by no means affects the radio access network of telcos. So there's no harm for the service. Actually, the only investment required is the batteries, and then we need to check that the rectifiers, they work in parallel with these batteries, and we can control them. So we don't need to do anything to the base station. We just need to have the space available, of course, for extra batteries, but you know, they are not that huge nowadays.
Just thinking about doing additional savings here and saving the power to the grid as well, shutting down equipment which doesn't need to be turned on because of capacity.
If I got the question correct, we can control the batteries any way we want, and many things are to be done with the control mechanism, but I'm not sure if I got your questions correct.
Hi. You mentioned the rectifiers. When you switched from lead acid to lithium-based batteries, did you actually have to change the rectifiers or any other gear around the batteries as well?
Not much. There was slight changes, and depending on an operator's network, of course, that varies a little bit because there are different kind of models used. But if they are like very, very old, then maybe renewing them at the same time is a good thing. You know, we could also push back the electricity to the grid, but that's not what we do. So we basically only adjust our consumption. We decrease it and we increase it by the use of batteries. And one of the savings that we gain is that we charge the batteries when the price is low, and then we use the electricity from the batteries when the prices are high. Of course, that's easy to understand, but that's only a small part of the big picture. The real beef is from the balancing services market, the compensation that the TSO is willing to contribute to us. So let's say that 80% of the business value comes from there. Thank you for your questions.
Thank you very much, Markus. It was a very interesting presentation, and I can see the discussions it sparked around. Before proceeding with the next slide and presenter, I just wanted to ask you if you have problems with the wireless, with the guest network. There is another wireless called Conferences with the password Centaurus with a large C. In a capital C.
Can you say that again, the password?
It's Centaurus. I'm trying to put it on the slides. For conferences is the setting. Because indeed I also had problems with the guest network. All right, just let me. Alfred, if you could just, I think it's this one, yes? All right. So we have here with us Alfred Aruna, who is currently pursuing his PhD degree on a joint research project between Simula Met and the University of Twente. His research interests include network measurements, with a particular interest in large-scale DNS measurement. Prior to his PhD, Alfred has more than 10 years of professional experience with internet infrastructure management. Thank you, Alfred.
So, yeah, my name is Alfred. So today I would like to talk about a joint work with my supervisor, Johanna and Matthias, on exposing Norwegian domain name space. So the main question that we are trying to answer in this presentation is to evaluate to what extent we can use public data sets, for example, to collect or discover domain names that are supposed to be private by using, as I said, private data set instead of using technique like zone enumeration, for example. So I will start by introducing a bit about Norwegian legal framework, and then I will introduce the methodology, which will be the two data sets that most data use, and the last part will be about the analysis. So now, before going to Norwegian legal framework, a bit of background. So a registered domain, in this case, for example, ii.xc, imply that some of the delegation record has been added to the zone file. So from this registered domain name, we can create as many as possible fully qualified domain name. This means that, for example, the creation of mx1.ii.sc is done by the registrant, the domain owner, but from the zone file perspective, this information is not present. So we can potentially assume that by collecting a bunch of fully qualified domain names over the internet, we can have a larger coverage of the namespace compared to limiting our analysis to the zone file. So this is basically what we did, and I will go explain this further. So Norwegian legal framework, I'm not a lawyer, but from what I understood, in Norway, the zone file is considered as administrative data, so it's under a bunch of law. For example, the Freedom of Information Act and the Public Administration Act, which basically means that if you request, for example, the zone file from NORID, NORID is not as an entity managing the zone file on behalf of the Norwegian Communication Authority. NORID is not allowed, for example, to disclose the zone file. So this is what NORID is doing. NORID is fully compliant with the Norwegian regulation, but as you may know, the DNS is a distributed global network, so other organizations on the internet are not under Norwegian regulation. So this is where I will introduce the two datasets that we use. The first one is called certificate transparency. So this has been initiated by Google and major web browser providers. So the idea is basically to be able to detect fraudulent TLS certificate. So for each TLS certificate that is created, basically, a copy, I will say, of the certificate is append to a public load that can be monitored. For example, if you have a brand, for example, and you want to make sure that all the TLS certificate that has been created for your brand are created by your organization. For example, you can monitor this log to check whether or not there is a fraudulent creation of TLS certificate. So we collect this data and extract information that we need for analysis. And so far, they have collected around 14 billion TLS certificates. So in terms of data, this is an example of human readable version of NONOG.NET TLS certificate. So we consider few fields, I would say. We consider the starting validity of the TLS certificate. We assume that if you have a valid TLS certificate, this may imply that we have a valid domain name, which is not always the case, but this is our assumption. Next, we look at the subject and the subject alternative name, where we mostly have fully qualified domain name there. So by using the fully qualified domain name, we extract actually the real registered domain name to do the analysis. The next data set that we use is called Common Crawl, which is an effort to crawl the web and provide this data for public analysis. So anyone can download this data and do basically whatever they want. So this is so far a long-term project. They have started collecting data for more than 17 years. Now they claim that they have 2.5 billion pages that they have collected. And in terms of storage is around 9.5 petabyte of data. So this data, for example, has been used by, machine learning for language training. So it's very popular data set in, academic and also industry. So in terms of format, as I show you for the certificate transparency, we only filter some of the data that they provide. So in this case, we only collect the fully qualified domain name part and of course extract the domain name from that. So we combine these two data sets according to the day where the year where they have been provided, and make the count actually of the number of domain names that we're able to extract. So as you can see, just on the slide, TLS certificates, not all domain name has a TLS certificate, of course, so CC actually complements what we observe actually on the TLS data set. So when we combine all those data sets and evaluate the number of unique domain names that we observe on a yearly basis, this gives us a number, and we compare this number with what is provided by NORID on the website. So here is a kind of timelines of the percentage of Norwegian domain name that are available on the public data set. So on the slide, on the figure, I put some, I would say, important milestone. So you can say that, let's say, the correlation of lesson script, I would say, general availability in November 12, and also, more importantly, when Google, for example, they say that to accept a certificate authority, for example, in the web browser, the certificate authority has to participate to certificate transparency log project. So the combination of these two, I would say, important milestone can explain why we see a sharp increase of the number of domain names that has been exposed on the public data set. So overall, when we look at the picture, around 60% of the domain names that are supposed to be private, according to Norwegian law, are public on the internet. So when we consider the source, since I said that we have these two data sets, very few domain name was basically found only by the common crawl data set. Around 27% are from the certificate transparency. When we look at domain names that are available in both data sets, this is around 27%. And when we combine everything together, this is what I used on the previous slide to combine everything together, we are around more than half of the domain name that we found using these two data sets. So this statistic is not specific to .no namespace. We look at other Nordic countries, and it's, I would say, roughly very close. 60% in Denmark, 59% in Finland, 58% in Sweden, and of course Norway, 55%. The important things to mention here is that .hc is an open zone. So anyone can download the zone and do whatever they want with the zone, but still we are around 58% of coverage using public data sets. This indicates that we can assume that by using this approach, collect public data set, extract domain name, we are able to cover around half of the domain name by then. And we can speculate that this trend will increase over time because TLS certificate adoption will increase over time. So just a small conclusion here. As I said, the number of domain names that will be public will increase over time. And when we look at the raw data, because as I said in the beginning, we start with the fully qualified domain name. When we look at the fully qualified domain name, we see some domain name that fully qualified domain name that can be related to, I would say, native services. So for example, we have domain name which start with the first label, the VPN. Of course, I replaced some of the label there and end up with mail.no. We also have another domain like this, auto discover, a bunch of things that are replaced, and that is a start.no namespace. So for the rest of the presentation, I will talk about some cases of those fully qualified domain name. But first, just a bit of vocabulary. If we consider VPN that alpha, that beta, gamma, that delta, mail.no, and we split using the dot, one question may be why the dot is used. Actually, there is no consensus, actually. There is a thread on Mastodon where people that are doing DNS way before me basically discuss, and there is no clear consensus why the dot is used, but the dot is currently used to separate labels. So .no is, of course, the top level domain. According to Norwegian law, mail.no is called the extended TLD or secondary level domain name. And for the sake of the presentation, I will consider the rest as a label. Technically, they are labeled, but for the sake of presentation, I will consider VPN and so on as a label. So when we look at the data of the fully qualified domain name and try to evaluate the origin of those domain names, we found that I would say 15K of the domain name or the fully qualified domain name are related to an extended domain name, while the large majority is directly on the .no. And of course, just to mention that the scale is not the same, so the domain on the ETLD is 15K, but the number of domain directly on the .no is around, I would say, 2 million. So let's look at the extended domain and what can we learn from that. So we compute the number of domains that we found according to each of those extended TLD. So as you can see, more than half of domains are directly on the common.no. We can also see that other public services or secondary school like VG.AS, I guess it's the secondary school related stuff. We have the priv.no, which was the previous extended TLD reserved for end user, something like that, if I'm not mistaken. And we also have interesting information related to public service, mail.no. But more importantly, by looking at the data, even though I don't know everything about Norway, you can have a hint about the administrative distribution, organization of Norway. You can say county, municipality, and also the importance of the city, for example, also that no standard, for example, here. Now, if you look at the large part of the data, domain data registered directly on the .no, the picture is, I would say, there are more data, of course, on the data, so it's a bit challenging to look at all those things. But I want to mention that around 2.5% of the fully qualified domain name use wildcard. So this potentially means that multiple domain names share the same TLS certificate, which can be abused for a certain way, for example. The next thing I want to talk about is, so as I said, we found some label that can be vulnerable. So sorry for the picture, but trust me on this. We have some label that can be linked to, I would say, services like SIP or 3CX, which was subject to an attack last year or something. Last year. So if I'm able to collect this information, I can kind of prepare targeted attack if they haven't, for example, update 3CX. We also have label related to web applications. So Magento, we have PHP MyAdmin somewhere. We have, for example, the use of PHP framework called Laravel, and there is one label which is exactly PHP 5. So I can assume that I can assume that the service behind this domain name is still using deprecated version of PHP, for example, which can be subject also to attacks. Other than that, we... Yeah, oh, sorry. So that's, anyway, the last slide. So just to group what I was saying before, so we have different category of label that services that we have on the data that can be, of course, subject to attack. So the main takeaway for the presentation is that the number of domain names that has been exposed will continue, and as an infrastructure manager, it's better to take this into consideration in a security policy, for example, instead of kind of assuming that even though you have, let's say, Microsoft AD and you only have your domain that you use internally, if you're using TLS certificate, probably your domain name is exposed on the internet. Thanks.
Thank you very much, Alfred. Do we have any quick questions, or you can talk to Alfred a bit later, depending how long you want to slide into the lunchtime? All right, you can reach out to Alfred afterwards. Thank you very much, Alfred. Very interesting. Yes, we are proceeding with another 15 minutes presentation from Frode Fjermestad. If you can just... can you find your slides? I think it's the last one. So Frode from Tempnet started his career at Song Networks, or TDC Song later, TDC, then got Get and Telia by different requirements. And he was keeping the same office during those times. The last 4 years, he has been with Tempnet as an optical engineer. He's part of the Tempnet optical team, where he designs solutions for carrier customers, and does network build-ups and helps the operations team to operate the network. Thank you.
Thank you. And thank you for letting me speak a little bit about our company Tempnet and what we do. Oh.
This thing.
How do I
think with the clicker.
Okay.
Yeah.
Okay. Yeah, thank you. Yeah, I'm going to talk a little bit about the fiber sensing and monitoring of the fiber optic infrastructure. So jumping down to layer 1. So I'm not doing routing and switching so much, but a little bit, just a little brief introduction what Tempnet do. Some of you may know that we serve the oil and gas business and also the wind energy in the North Sea mainly. But we also support the Gulf of Mexico, where we have a quite large network in the US. But many may not know about our carrier business, which is actually the most of the traffic going here is from the carrier business. So I'm going to speak a little bit about the Tempnet and the North Sea fiber network and how we do fiber sensing and how it works. I'm also giving some examples of observations we have done on the subsea cables. Yeah, and we also have our new Northwest cable system, which we have recently built. And this is functioning also as a perfect testbed for fiber sensing. First of all, just a quick introduction of our network. Our main infrastructure is in the North Sea and also showing the GUM system in the US, but today we're focusing on the North Sea network. This is mainly serving, or is built for serving the offshore installation in the North Sea. But we also have used the possibility to also transport traffic between Scandinavia and UK, Netherlands region. And I just did some checks yesterday, how much traffic we are provisioned on these cables or these fibers. So on the north route, we have to Aberdeen. Check, we have around 60 100 gigs. And the south route going from Lista to Lowestoft, we have around 30 100 gigs. And from Amsterdam to Norway and Sweden and Denmark, there are around 40 100 gigs. So we have 10 gigs as well, and 400 gig is coming. The plan is to deliver tomorrow 2 times 400 gigs on the client side between Amsterdam and Copenhagen. So that's our first 400 gig delivery directly to customer. So let's go to more about the fiber sensing, which was the thing I should talk about today. We have 2 types of technologies. That is distributed acoustic sensing, DAS, and the state of polarization, which we call or is called SOP. And the difference between those is that DAS is using the L band. I don't know how much you know about these frequency bands in the fiber, but normal transmission system is using what we call the C band. And also a newer generation is also using the L band, just to mention that. But DAS is using the L band. That means that we can put in a splitter on existing systems to utilize a DAS sensing equipment. We can also put it on a separate fiber pair if you want. But DAS is stopping at the first amplifier because an ETFA amplifier do not amplify the L band. So that's the maximum distance of a DAS is typically 120 kilometers. Could be more if we have on a fiber pair with no amplifier. But that's a typical distance for distributed acoustic sensing. And DAS is you have location info. You can see where you have an incident or where you can have a sensing. But SOP is a little bit different, that we can put in to an existing line system. Will go through the amplifier and have no distance limit like DAS. It has a transmitter and a receiver. So there we can sense for a longer distance, but we have no location info. So if we want to find the location, we need to have all the data sources. I will come into that. We can use IS for shipping information, for example, and other input. And in the North Sea, we have placed DAS acoustic sensing on different places. We have some of these places are we cannot say where it is because of the security law and stuff. But we can say that we have for several years have had DAS at Lowestoft because this cable outside the UK south is laying on a sand seabed. So there's a lot of motion in the fiber, so it's a perfect place to test those type of equipment. So we see a lot of motions, and we see ships and trawlers and stuff like that. Here is an example we have had, or we captured during an earthquake. So we saw an impact on all the cable itself. So the y-axis is time, and the x is the location along the cable. So that's just an example what we have got from this. This can be very useful for, of course, earthquake scientifics, but also for carbon storage. We test stability of a existing well, stuff like that. So the operators are really interested in this technology. And we can also use DAS for tracking trawlers, for example. We can see on the left side, the red is the DAS is detecting some motions on the cable. And the black one is the IS data we got from the submarine maps. Yeah, and we see the same on the right side, just from the DAS system itself, where you can see the ship was trawling alongside the cable. When you put it to trawl down, and it was going alongside the cable, and we were pulling it up again, and then it disappeared. And also at the upper there, you can see just a big boat crossing the cable, so that is also visible if you're going straight over. Yes, and yeah, this is more like a promotion for our own inbuilt or in-house built equipment. Our engineer Steinar Bjørnstad have built this system for SOP. It's a 1U instrument for installation in racks, and it's our network operations center is surveilling this system 24/7. This is just an example here on the left side where we have a cable impact. We can see it, and it's changing. It's a relative value, so it will constantly be changed. So we can see the next incident may be going up. It's a relative value to what it was before. Yeah. And this is also just some example for SOP events. We can see on the lower left picture here, that is when someone is moving a patch cord. That's really easy to see. It's a quite huge event. It can also be splicing work in a manhole. So it's quite easy to see. And you can also see on the lower right, that is a longer time though, but we can see SOP before and after a patch cord movement. So after that it will be more stable. But for example, if we have a digging work around the cable, it's less impact, but we can see it's more like it's lower variations, but maybe on a longer time span. So that's how we can analyze what we think we are seeing. But we have no location info, so we have to maybe drive alongside the cable or look at the IS map to see where we have maybe a ship or trawler crossing by to see where it is. Yes, and we have the Northwest, which I mentioned. This is working as a perfect test bed because we have CLSs easy accessible, and we can install SOP equipment on every place, transmit and receive. And we have also many fiber pairs to play with. We're also installing DAS here. I cannot say where, but SOP is we have on every node. And yeah, we also have installed OTTRs on many fiber pairs. So that is also giving alarms to the NOC if we see some events on the OTTR. So it's really a proactive fault analysis, and yeah. Yeah, so this is the Northwest, where we have installed in Stavanger, Egersund. Stavanger is Green Mountain, by the way, and Lista, Kristiansand, and Arendal, Larvik, and Oslo. Yeah. So to summarize this, we have shown that the optical telecom infrastructure can be used for sensing, not only for our own purpose, maybe it could be used for other stuff as well, for surveillance, for the shipping traffic, which is not in IS, for example, and also for other purposes. We can use for security and availability, earthquake monitoring, and also marine observations. Yeah, and SOP sensing, we can see impact on fiber paths. Yeah, and also enables. It's a great tool for us to monitor our own network. Yeah, that was. Thank you. Thank you very much.
there questions? Yes, there is questions. Can you?
Kai Kjellgren from NetNode. I understand if you won't or can't answer this question, but is it sensitive enough to pick up submarines?
Yeah, I got that question before, and I actually asked Steinar. Of course, if the submarines is going on silence mode, unfortunately, no, because that's so sensitive that it's made for going very or be hiding. So no, not if they're going for full machine. Of course, then it's like a other ship. So yeah.
All right. We shall proceed then with our next presentation. Last one before the lunch, but very interesting presentation in my view at least. Please welcome Arne Erik Berntsen from Posten Norge, the Norwegian Post. Yes. Let me just start the slides first. Perfect. So as you can see, Arne will talk about the network to connectivity experiences, including the 5G private network. Arne started at Posten in 2006, where he had various roles and where he is CIO since 2017. He has led several outsourcing projects and major competitions. Beyond 5G, it is worth mentioning his highly successful migration of the mainframe system, that would be interesting, to the cloud on time and under budget. And currently he's finalizing the migration of the IT systems to the cloud and also working on realizing the use cases in AI. Welcome.
Thank you. I'm the guy between now and the lunch. So I have to keep the timing. First of all, a few words about Posten. And this will set the context about my theme today. Hopefully, all of you are customers of Posten. We are a Nordic company coming from the postal business. When I started in the group, 2006, we were mainly a letter business. 80% of our turnover was in letter. Today, 80% is logistic, and the 20% is letter. 40% of our revenue is coming outside Norway. And when I started, it was around, I think, 20,000 employees. Now it's 12,000. And we are in this middle between cutting down on letter business and grow in logistic business. And that's the flip side of the digitalizations. And we need to operate here in a cost-efficient way to earn money and to provide our services. And our story with 5G started in that area. And I'm not going to be so much technical. I will talk about our usage of this and with some additional themes like Starlink at the end. Here it starts, 2018. Hopefully the people who are here in the audience who are living in Norway have been in this place where you can pick up a parcel. We have these set up around Norway, 1,400 to 1,600 places all around Norway. In 2018, a long time ago, the network here was based on copper from Telenor, fixed network on all these locations all over Norway. And that was a challenging for us. We needed to modernize it, but it's also an operational issue. Because when we were going to change the setup at the shop where we deliver our parcel, we had to establish new network connection in a new building, and that took between 4 and 8 weeks. So we had to modernize it, and we had an operational issue. What can we do with it? 5G was coming in pilot. And together with Telenor and Tieto Evry, we ran a pilot in Elverum and Kongsberg and saw that 5G, yes, we can do that. We can use 5G to replace this. But 5G was not available in Norway in 2019. In all other places we'd like to have it. You need to have coverage. We need to make sure that 5G and 4G plus are available where we are. So we waited until the market was ready, either that Telenor and Telia was having necessary coverage in Norway. And then we did something I think was a very wise thing to do. Everybody has a phone. That one is giving you access to data to your IT service, and everybody also use typically wireless network, fixed network where they are. Typically, we have two different contracts, one for mobile phone usage and one for network. We went out to the market and say, we combine these two into one agreement. Just give us access to our data wherever we are. So we went out in the market, and Telia won this competition, and we moved all these post-in-shop locations to 5G and 4G plus. 1,400 to 1,600 places in Norway. Just a few cases where we have still fixed network, but there we only use a mobile router. And going down from 4 to 8 weeks delivery time. Now we have 1 week for normal delivery time, and we can have an even faster if needed, and it's simplified. It's just a mobile router with electricity, and then it's up and running. We still need to have a router because we have some equipment there. Go we outside Norway, we only have a SIM card, and then it's up and running. So this gave us more bandwidth, reduced cost, flexibility, and gave us operational advantage. How could we take this further on? What's the next step? Now we are in 2021-22. We have these kind of buildings like this. We have many of them. This is a big one, but we have around 1,800, 1,900 locations in the Nordic. We have 30 to 40 terminals, like this one. When we are building, this one I call a small building. When we build these kind of buildings, we typically need to make sure that we have public 5G network to access to your phone in the building, and also Wi-Fi. Two separate ways of building connectivity in the building. You need both. Can't we combine these two? Can we just have one setup in the building? Only have mobile connection, maybe? Then we discussed this with Telia. And the building you saw there, we were starting building it in the end 2022. In 2023, we had to decide what kind of connectivity do we want to have in this building. Either do a classic one with Wi-Fi and this public mobile network, or just combine it. We went for 5G, private 5G, with our own frequencies in the building. No Wi-Fi. So I approved this investment, new building without Wi-Fi. And that was feeling a bit worried. Will we have challenges when we start operating? And we opened the building in 2023, December, with only 5G private network. The people who's working there have PDH, rugged device. They have special equipment with tablets on forklift. They have kind of mobile type of equipment, but also PCs with eSIM. And together with Telia, we made this as a site we could test out everything to see if we are able to do it without any backup plan. So this is a simple picture of the building. Only private 5G network. In this kind of building, this is a kind of warehouse operation. We have racks with goods in the racks. that's, to put it polite, hell for us to make correct coverage because the building is changing all the time with everything in the building. With Wi-Fi in a typical setup like this, I need 70 to 80 antenna to have a perfect coverage. With 5G, we made the same with 4. And only 2 is necessary. The remaining 2 is a backup, redundancy. So I replaced 70 to 80 Wi-Fi antenna with actually 2. I'm sorry to say that I didn't get, or we didn't get what I wished for in the first phase, to just combine the public 5G and the private 5G. So we had to establish separate antenna for public 5G. But we have private 5G in the building. And the tablets and everything is connected up to it. Into the building, classic fiber, dual. We could have used public 5G. We are using public 5G to produce it as a backup on terminals. But we made it classic with the classic dual fiber into the building. But we put something on top of the roof. You can see it on the drawing with a Starlink antenna as an additional redundancy. So, in 2023, I was not able to get the frequency by myself. This is private frequencies for Posten Bring, but we made it Telia provided to us as a service. Today, you can get your own licenses. Maybe I would like to go into that, but we are not doing it here. We buy it as a service. We had our own SIM card. I like that with the Posten Bring logo. That makes sure that it's only allowed equipment that can connect to the private 5G network. And you also use eSIM inbound in equipment to also connect it up. In this kind of building, I said the coverage is like hell with classic Wi-Fi. With mobile technology, perfect. We can reach everywhere. And it's also perfect with roaming. It's working much better. Probably a lot of people here in the audience should say something else. But roaming is perfect for us using 5G as our primary network setup. And also, I said regarding this installation, 4 antenna with cabling compared with 70 to 80 is quite more easy to operate and less costly. We have made this, and it's actually up and running. This is not a test. This is the only way we produce at this site. We make this as a blueprint, which we like to roll out to all our new places. We need maybe hybrid. Some places, not like this one, maybe we have some kind of Wi-Fi for some support in some period. But the long-term goal for me is like to have only 5G. Public, private, whatever. This we can combine with kind of edge computing, whatever we need of service on top of it in order to make it more efficient in our production. So that we are looking for. And up there, you see a picture of the 5G private network you can buy as a service from Telia now. That's the only installation in Norway currently. So we are very proud of that one, but you can buy it. This one tells everything. They are smiling. They are not complaining. They are smiling. These people have been working on another warehouse before with classic Wi-Fi. Then they were not smiling. Then they complain. Now they only complain when I joke with them and say, now you have private 5G for some long period, we take it away and you get Wi-Fi. Then they get angry. But they are smiling. And that's a very good sign. It's working. It's not an issue, it's actually helping them. With simplifying, with, for me, reducing cost. Now I've talked a lot about the positive thing. There are some issues, except that also the driver of the forklift needs to clean his tablet. There are issues. And the issue is that everything needs to be connected up to the 5G, need to support 5G or 4G plus the physical hardware. In our operation, we can use some kind of old equipment and new equipment. And some of this is okay, tablet, PDH, phones, whatever, that's okay, PCs. But this printer, you see there on the forklift, is not supporting 5G or 4G. What do the people do then? 5G router on the forklift as a workaround, classic workaround. Now we are working together with the hardware vendor, the industry, to make sure that they can support 5G from the beginning in the physical hardware. So we are challenging the industry to go that direction to support both 5G and Wi-Fi. Then it's much more easy. Also some fun case around the onboarding PCs with eSIM. Have you tried that? Somebody tried it? I have. If you do it on a phone, it's easy. You get a barcode, or you can send a code to your phone, and the barcode or the QR code, you read that one and you start the process. You scan a QR code. Try to scan a QR code on your PC. That's not easy. Then you take the camera on the PC as a workaround, and you have a QR code on your phone, and then you scan it. And then you start the process. So we have learned something. We have got some attention internationally, locally. This was nominated as one of the most innovative private 5G network in Europe last year. What this means, this tells us, is that what we are doing is something that is in forefront, and we are trying to utilize new technology in an efficient way, and there's a lot of interest in it. A lot of people have been talking about 5G. Here we are using it. The Norwegian Defense, I'm not sure I'm allowed to tell it, but they are also using the same case as study and using it, and also Starlink. So we are talking about the same. And then Starlink. Not only 5G, but we also use Starlink as an additional redundancy, not as a primary source, but as a redundancy. Now we are, sorry about the cables, now we are at the same terminal, which we have only private 5G network. On the left-hand side, the picture seems it's a little, it's not 100% green, the cable there. The left-hand side is the normal router for the fiber connection. On the right-hand side, it's a Starlink router. If the fiber is going down, the Starlink is taking over. You don't you don't experience anything downtime at the location. So in the 5G private network cabinet, it's also a Starlink router. What can I do more with Starlink? This is from the harbor outside Oslo here. Special operation, container operation in the harbor. We had some issues with the cable network. It was down. We had to do something. We couldn't use 5G because if you have this container operation, you put these containers on top of each other, and that is blocking 5G. So here we had to do something else. What do you have above you? You have satellite antenna. At that time, we couldn't buy Starlink as a service, so we used my private net credit card. We bought it, got the Starlink antenna, put it on top of the roof, and we were up and running for almost 1 year with only Starlink in the harbor operation. Now, together with Telia, we have made this as a service, so you can buy it as a service. So it's combined with your network. But we can use it as a special operation. Can we stretch it even further? This is a small sorting facility. We have 30 these kind of machines. We have 95 across Nordic. This one is a very small one. You can see the lights there. That one scans the label. Based on the information the scanner see, it questions the system in the cloud, what to do with the parcel, and reply back to the machine, and the machine knows what to do with it. The requirement for latency for normal operation is 20 milliseconds. And the system is in the cloud, Azure. And in this test facility, we also can use Starlink here as a redundancy. If our normal either 5G or cable networks is going down, Starlink with real-time production through a satellite antenna to the cloud, back to Starlink satellite antenna and to the sorting machine, and real-time operation on the sorting facility. We are stretching latency on the Starlink there, but it's a redundancy which we can combine with 5G and actually think of new ways of doing our operation. What next? For you, it's lunch. For us, what can we do more? I like to do 5G in all our locations, and hopefully maybe a primary. What are we then doing? When we are buying new equipment, we need to make sure it can support 5G, and preferably have eSIM inbound, either in the container, PC, whatever equipment we buy now. So in the future, I can either connect it through Wi-Fi, 5G, whatever I like. I can just connect it up where it is. And if you go outside where we not have our office, it's connected to the public net. Perfect. So we are trying to buy everything with eSIM inbound or in the physical equipment or 5G support to be ready. So the last question, we are asking us for the future, do we actually need LAN, local area network, with classic setup, cable network, 5G slicing, coming, it will be able maybe next year. We are asking for it all the time. You can establish your own network on top of public network and your private network with your frequency. You actually need to configure new buildings with local area network. I didn't do it in Drøbak. Can I remove it completely in all our 1,800, 1,900 locations? That we are actually challenging the vendors now to see if we can do that. We need, as I told, we need to get slicing, but we also need to make sure that all physical equipment are able to support it. We can't have all this 5G backup router on forklift drivers, physical areas. So we need to have it to support 5G. That was the last comment before lunch.
Thank you very much, Arne. Do we have any questions? We have some minutes for questions. No.
Everybody is anxious to get their lunch.
Yes, I guess they will catch up with you in the foyer. Thank you very much, Arne. You are now invited to lunch. And we will reconvene here at 1:15 to go on with our agenda. See you. Lunch is served in the Yes. Are we ready to start? Let's see how many made it past lunch. It seems quite a few, but we had a bit of losses. We are ready to start now with a presentation from NetNode. Kai Kjellgren is a seasoned expert in network architecture and interconnection, with well over 2 decades of experience in the field. Since 2002, he has been working as a senior network architect at NetNode, a leading internet infrastructure organization and one of our main sponsors. His primary focus is on peering and operations, and he is a regular speaker at international conferences, sharing insights and technical developments and evolving landscape. So welcome, Kai.
Thank you. So, hi everybody.
You had a great lunch? Yes. Good. Anyway, I hope you also got some coffee so you don't fall asleep when I stand there talking. Anyway, I have a tendency to come here and speak about time and time again. Last year it was NTS. This year it's rough time. So, yes. Okay, can't you hear me? Hello? Yes. 1, 2. Should I sing something? Damn, I never get to sing. Okay, can you hear me now? Okay. Oop. Fem. Okay, it's better now? Oh, great. So now we'll sing. No. Anyway, rough time. What is rough time? And well, before we go to rough time, we go to why is accurate time important? Well, I guess I don't have to point that out to you since the audience in this room is pretty sort of good on realizing why time is important. But I mean, basically all of our protocols need correct time to work. And the accuracy is somewhere between a couple of minutes or hours, depending on which protocol you're talking about. And problems with not having accurate time is you can get a fallback to insecure protocols, which is inherently bad. And that also is might be a vector for exploiting your services. So, I mean, it doesn't matter what you look at. If you look at the electric grid, you look for like electronic door lock, your web server, everything need an accurate time to start up with. The problem is, or as I should say, not the problem. Most devices can keep time. Well, basically all devices can keep time. But when they're powered on, if they're powered off, even if they have a real-time clock, they maybe not be equipped by a battery. The battery might run out. So you need some way to get time to the device. And this is not a problem if you can trust the network, because then you can use NTP. But if you have malicious actors trying to sabotage your equipment, then NTP is not secure at all, because it's very easy to do man-in-the-middle attacks and so on. I talked about that last year quite a lot, so I will skip that now and just hope you have good memory. Anyway, so these are examples like the Raspberry Pi that has got an RTC, but no battery installed. And then you also have the thing that you might have devices that you've ordered 10,000 of, and they are on the shelf for years. And then when you activate them, that little NTP server that you put into the firmware, well, doesn't exist anymore. So there are different ways of getting time. NTP, as I mentioned, good, but has no security whatsoever. NTS, which I talked last year about, is actually very nice and all. However, it also has the bootstrapping problem. You have to have somewhat accurate time before you can use NTS. And then it's also heavyweight. So for all the little IoT devices, you know, your fridge, your microwave oven, your toaster, your shoes, I don't know, they don't have very much capabilities memory-wise or processor-wise. So then NTS is actually not viable. And you can use HTTPS and so on, but then again, if you use HTTP, there's no security. And if you use TLS, then you also have the bootstrapping problem. So yeah, rough time. It's a possible solution. It's something that Watson Lad from Akamai and Markus Dansaria of NetNode has been working with extensively. And it's actually a way to verify system time. So you could check if a time server did what it was supposed to do. And then we sort of realized, okay, this can actually be used also to bootstrap devices. And a lot of development has happened since then. So the big things is it's secure, it's lightweight, it's resource efficient, especially on the IoT device. And unlike NTP, it always requires cryptographic verification. So that way you will know that time information that you received is actually authenticated. So the concept is basically you have an EDDSA signature, specifically a 25519, and you also use a Merkle tree. The idea with this, I don't know if I'm going to be a bit forefront here, but the idea with this data structure is that it will offset the signature process quite a lot, because you can generate a signature, it's costly, but you can use it for thousands of devices after that. So even though the server has to generate the ED25519 and it takes a lot of power, it will still be beneficial because you can use it for so many devices. And the problem then with having this device that has been on the shelf quite a long time. So instead of using certificates, it uses a public key. And it's hard-coded in the client. So a little bit is that the bootstrap issue is now instead moved over to a key distribution issue, which may be a problem, but it's also so that if you can have enough keys and they're valid long enough, it should actually work quite a lot better than using TLS, for instance. So also you have huge lists of rough time servers. Instead of having like 1 or 2 NTPs, maybe you have a list of 20, 30 in the firmware. So hopefully when you boot up that device, at least 2 or 3 of those will still be working. And the protocol, sorry, I have to scroll here a bit, whoops. Nope, never mind. Anyway, the protocol works like this. Let's see, I'm actually gonna jump to this and then jump back. So the client generates a nonce and then sends that to the server, who use that nonce, take a signed response and include the nonce back. This means that the client will always know that it was the request it sent to the server it sent. And yeah, this is a very effective way of actually signing or timestamping whatever. You can timestamp whatever with this version of, well, authentication, basically. So this can also be used to get a traceable cryptographic proof of misbehaving servers, because you can send this with your own nonce, get it back, and you can time it towards others or your own clock. Typically, you can send to say 5 servers in a like 1 second interval, for instance, and then you should actually get 1 second interval increases of the time you receive. If you don't get that from one of the servers, you know the server is doing something strange. So you can actually use this both ways around. Also, you can basically use this to sign everything, as I said before. So we see rough time to be able to do a lot more than just be, well, rough time. Anyway, so where are we? Right now, it's actually working pretty well. We have time between like single seconds resolution. That means, well, it's better than 10 seconds, and it's maybe not down to half a second yet, the way it's rigged up right now. It is secure because, well, NTP is not, and this is secure, so we would say this actually have a very good use space in the community. And also, it can run on very resource-restrained devices. So, the problem we have right now is, since nobody's basically aware of this, we have a little bit hard to figure out, so what time scales should we use? What kind of format should it be, and what kind of resolution? Do we need sub-second? Do we need sub-millisecond? What are the needs here? For most protocols, probably around a second should be just fine and dandy, right? Because if you run something heavier than an IoT device, then of course you can run NTS. So after you bootstrapped it, in comes NTS. And also then all these leap seconds and leap smearing. Yeah, well, if you say that 10 seconds is okay, then that sort of is not very relevant anymore. And also the format of the protocol. So this is actually, as you can see, very much in development. It's in IETF, in a draft, being finalized. And now it's in a state to get feedback from the community. So also there is, I mean, in order to prove that this works, we have actually done a lot of different implementations in C, Python, and Go. And there's also, I mean, there are lots more to test before we know this, especially also on the server side. Also how to do interoperability and all that. However, this is actually going to be on a hackathon now in IETF in Dublin in November. So that's going to be very exciting. See what they actually find out there. And also, as you might understand, for this to work, you can't have like 2 rough-time servers located in Stockholm. That will just defeat the purpose completely. There needs to be rough-time servers as many as NTP servers around the world. Because otherwise, it doesn't work, right? So anyway, this is now actually being built out by contacts from NetNode, so we're putting out or having help from people in the community to run these servers so we can do real-time tests and see if it actually works as we think. We hope it does. So if you're interested in this and want to sort of help out or have a look at what we're doing, here is all the information. I really hope this catches on because I think it's a really cool concept. So, thank you.
Thank you very much. Okay. That was half of the NetNode presentation. We have the other half now, which will be presented, which will be presented by Lars Johan Liman, who is NetNode's resident DNS dinosaur, and Greybeard, as he describes himself. He's in charge of NetNode's DNS root servers operations, a role which he had for 30 years. He's involved in DNS policy and technical projects at all levels on our 3-shaped globe. Just let me... There we go.
Thank you very much.
Step there? No step there? Danger. So thank you. Yes, I'm Lars Johan Liman. I've been tinkering with the DNS longer than I care to remember. We always try to look at DNS from different angles at NetNode, and this is a project that we've been part of for the last year, and this is actually a cooperation between NetNode,
SUNET, the Swedish University Network, and the Internetstiftelsen, the .se registry, together with some technical DNS experts that are small consultants and chip in from various directions. So, what's the problem? The problem is privacy leaks using the DNS. When you send DNS queries, the pattern of your queries will actually tell you things about what you are doing on the internet. And depending on where you intercept the queries, they can give more or less information and more or less specific information about the user. And since regulations from the European Union have made it more difficult to use cookies, people have come up with other ideas to trace web users, one of which is to plant things on the web page that have unique DNS signatures. So when the browser looks up the DNS queries in conjunction with that, they will actually leave a pattern that can be used in ways similar to cookies, but they are not prevented by the regulation. And there are other cybersecurity-related things. You have, for instance, botnets who collaborate. They use a lot of domain names. I mean, when they connect back to control centers, and you can by looking at these queries, you can analyze and see what's going on with the botnets and try to use that to mitigate the impact from the botnets. So, what can we do about this? Resolvers. If you look at the DNS resolvers that your end client send queries to, you can do a lot by looking at the queries that come in there. Especially the larger the resolver, the more information you can gather. If you do this the right way, if you look at the part of the data that is less integrity sensitive, you can still do a lot of large number analysis on that without problems for the personal integrity. If you anonymize data, or which is very hard to do, you can take a middle step there, something called, and this is a difficult word, pseudonymity. You remove, for instance, the source IP address, because when you analyze large numbers, it doesn't really matter who sent the query. It's just the content of the query that's interesting. And if you do this on a large scale, you can get intelligence out of that can help you find things that consist threats to the systems for various reasons. But in order to do this, you must have aggregated data that has been pseudonymized so that the identity of the sender of the query is removed as much as possible. And you have to feed it into a larger system that does the analysis. So that's what we're trying to do. But in order to do this, you need collaboration. You need as many resolvers as you would like to take part in this and send the information to the central system. That requires collaboration. But you can only have collaboration under certain conditions. So collaborations will only happen if there is trust between the parties that collaborate. And in order to gain this trust, one way of doing that is to be transparent about what you do. You hold it out, this is what we do, and you can all try it at home and do whatever you like with this, but this is the process that we're running. And one way to get transparency into your process is to do it with open source code. So by using open source code, we hope to go the other way around, generate transparency. From that, we hope to earn trust from the participants, and from that, we get their collaboration so that we can get this going. There is a project in Sweden, there obviously a similar one here in Norway, regarding robust DNS, where the Swedish authorities are looking at how can we provide a robust DNS environment for the Swedish population. And our goal here, the goal for the project is to produce an open source software which can be used on the resolver side as accompanying software, or even maybe as the resolver itself, to generate this pseudonymized data stream to the central facility,
but also to design the software that does the analysis. And it's very important to point out here that the pseudonymization process is transparent so that everyone can see that this data is removed and this data is removed to make it less integrity sensitive, and also that the analysis is transparent. This is what we do with the data. This is how we generate the intelligence that we want to feedback. So the TPIR project is trying to make an implementation that will fit the goal of the Robust DNS project. The Robust DNS project is operated by the telecoms regulator in Sweden. And we are trying to make an implementation that can fit into their requirements. So we have two parts of it. The edge, which sits near or at the resolver, pseudonymizes the data, aggregates data so that it's even less integrity sensitive, and feeds that to the second part, which is the core system, of which there are much fewer in our model. So, central core system receives real-time and privacy-enhanced data from the edges, and then you have multiple edges that feed data into the central system. And back down we get, is that the one? No, it wasn't. That's the one. It feeds data back here in the shape of alarms and filters suggestions. So you can use the data near the resolver to do filter options or enhance the responses to certain DNS queries. But it's very important to say that this is not an order, this is not an instruction. This is making data available to some policy process down here that takes that as one source of input. So that takes us to the next picture. And if I had been a normal presenter, I would have said, you can't read it, but it doesn't matter. So I'm not your normal presenter. So here's a little more detailed picture. Here is the actual resolver that receives queries from the stub resolver. This is the end user. And it sends off data to the edge minimizer. This lower box here is the edge box. And we have the minimizer that does two things. It sends stuff to a local analyzer, which aggregates data again. You get the large bulk data. We had this many queries for google.com. We had this many queries for blah, blah, blah. So this is the aggregation of large data chunks. It goes up to the central system where it's further aggregated and sent to the core analyzer. But it also sends events. These can be things that are sudden occurrences of something. It can be, for instance, this is the first time I've seen this domain name. Liman.se, what's that? And that can be used, for instance, when you have a botnet system that jumps between domain names in order to try to evade being found out. And all that is fed back into the analyzer. And then we have configuration. It generates output here in terms of configuration that changes the local minimizer. I want to know more about this. Do count the occurrences of this thing. And you can send instruction back to the processor down here. But it also sends intelligence back to the policy part near the resolver. And this policy part should receive things not only from the core system, but also from other sources, and make a joint decision about what to do with a certain domain name. Lima.se, don't respond to it. He's really, really strange guy. And you can also see the possibility that you have other subscribers to this information. It could be law enforcement, it could be, whatever you like. So, how far along are we? Well, we have actually, this is an old picture from, maybe 9 months ago, where the next steps back then were to finalize the design and implementation of a policy of, proof of concept thing, which we have. That's done. It's actually up and running. We have set up services for testing and development, up and running. Set up a service for early adopters, not yet done. We're thinking about how to do that. discuss with service providers who operate resolvers. Underway. We have very good dialogue with Telia and Tele2 and Sunet and other large resolver operators. And to find a long-term solution for the operation of the operation of the system on the longer term, and also for keeping the software up to date and functioning and evolving the software. That's also underway, not quite done yet, but definitely ongoing discussions. So the project, we saw 3 phases of this, and we're coming along nicely. Established project done, develop proof of concept done, plan coming phases, that's underway. We are in the last quarter of this year, and we're now looking ahead for the coming years. And this is what we look at next year, to build a production platform, integrate with partners, and build an organization for maintenance and development of code and platform and so on. And at the maybe in phase 3, we don't necessarily see this as years. We don't really know where the time limits are to go into full operational mode and provide this to whoever wants to use it. And I should point out, backing up here, that these edge systems can be operated by virtually anyone who wants to connect to the same core system. And you can have multiple of these systems developed. You can have an edge that potentially supplies information to 2 analysis centers and get feedback from 2. So there are lots of options there. So part 1, we got funding from the national regulator, kindly enough. We had resources provided by Sunet, Internetstiftelsen, and NetNode. And then again, select partners, some specialists that we need in order to get the software developed. And that's where we live. That's what I had to say today. I'm happy to take questions. Possibly in the break afterward, I see we have 1 minute. But otherwise, yes, there is one question. Is there a mic?
Bernd from DKIX. One question, how does this relate with content blocking in various countries? So like Starlink is blocked in Brazil for a few days. How does this relate to this project? Because if you say it is about resolution, DNS resolution, so resolver servers, where is this censorship and under which jurisdiction is the central element running? Who can influence blockings or non-blockings?
Yeah. To begin with, I don't believe in blocking content by DNS because it's so easy to circumvent. That said, going back to this picture, the general idea here is not to support that type of activity for blocking, but it's quite possible that this policy process receives input from some other system that instructs someone to block content based on DNS. But that's not what you're going to get from this system up here. This is more to analyze the ongoing traffic rather than to receive instructions. But it's definitely the idea is that you should be able to feed this policy processor with blacklists or even whitelists. Never block google.com, for instance. So it comes in from the side here, but it's not part of the project that we're designing here.
So it means for a free internet, okay, it would be good to support this. Is it, or what is the outlook for how to support this project? So install those the lower part in as many places as possible?
Well, it all comes down to this function here, the policies process. And what you can do if you want to is to install this lower box near your resolver and provide information and don't listen to what's coming from above. You help others, but you don't use it yourself. So that's one way. But the focus here is in the analyzer is to look for malicious activities that could be potentially harmful for the end user here. Malware sites, botnets, criminal activities, state-sponsored activities and whatnot, and not necessarily regulation that comes, because that's a different pathing. Thank you very much.
Thank you very much, Niman. All right, we continue our program for today with critical digital communication infrastructure with Olav Lisne from SimulaNet. Let me just open the slides. So, Olav Lisne is the director and founder of Simula Metropolitan and professor of communication system at Oslo Metropolitan University. He has had several governmental assignments in his home country. He headed the National Commission on Digital Vulnerabilities in 2014 and 15. He later headed the commission that evaluated the use of lawful interception of internet traffic crossing the national borders of Norway, paving the way for new legislation for the National Intelligence Service. He currently serves as a member of the Norwegian Parliamentary Oversight Committee on Intelligence and Security Service, EOS-utvalget in Norwegian. Currently, he leads the National Commission that is to give advice on how to retain national control over critical digital infrastructure. Welcome, Olav.
First of all, I would like to thank the organizers for having me here. Second, I see that I was right in the prediction that I gave yesterday to someone who visited us, that I will most probably be the only one here wearing a jacket. I see one more, but not more. I am, as was said in the introduction, I'm heading a commission for the Norwegian government, and they've given us a rather tall order. They asked us to give them advice on how to retain national control over critical digital infrastructure. And as most of you will believe, doing this is close to impossible. But I will tell you about something about how we approach that question, how we approach the problem of being asked to give that kind of advice. And I will start with a background for that this commission was formed in the first place. Now, these are headlines from the Norwegian media, and some of you might not be able to read them, but I'll take you by the hand and guide you through it. Top left, the government allowed for a sale of a part of a company called Global Connect. And as many of you will know, Global Connect is a company that owns fiber infrastructure in some of the Nordic countries and also in Germany. And as you also will know, fiber infrastructure, well, that is obviously within the realms of what you would typically call critical digital infrastructure. That sale was done to a company called Mubadala, which is placed, has its headquarters in Abu Dhabi. Bottom, Telenor, the Norwegian incumbent, split out part of their fiber infrastructure into a daughter company, and then part of that company was sold again to a fund that was based in New York. Again, this was something that the Norwegian authorities had to make a decision on whether they should use legislation to stop this or not. They ended up not doing it. Third example, again, Telenor. They had an activity on satellite services called Telenor Satellite, and for quite a long time, that was actually for sale. And what the Norwegian state did with that was that they used one of their existing companies called Space Norway, 100% owned by the Norwegian state. They did a mission in that company so that the state put more money into the company so that the Norwegian company owned by the Norwegian state was able to buy Telenor Satellite. And this was done in order to retain national control. And of course, in all of these cases, what the Norwegian government really struggled with was that they had to make these decisions more or less on full volley. You know what full volley is, right? No, okay, never mind. In a very short time, in a very short time, because these kinds of transactions, the opportunity appears and it disappears after maybe 14 days. So the decision had to be taken very, very quickly. What challenged them at the time was that they had no philosophy, no structure of thinking as to how they should approach that kind of problems. So they asked us to give that basically to them. And from a high altitude, we can say that, well, losing these kind of companies, losing ownership in these kind of companies is problematic. And it happens in many ways. You can have acquisitions of a company fully or partially. That is what actually happened in the case I just told you about. Then acquisition of smaller parts in several iterations. Well, smaller changes to the ownership structure, but it happens in many iterations, so you end up in a situation that you would not want to be in, but through a very large number of small steps. Splitting out and selling parts of a company, yes. Telenor Fiber is an example of that. Influence and governance of companies with complex structures of ownership. All of these things are problematic. But it isn't all bad. Right? Because when people want to come in and buy part of a big, say, telecom incumbent in Norway, what does that mean? It means it brings capital to the country. Capital that can again be reinvested in the critical infrastructure and thus improving it. So there are positive effects from these kind of things. So we need to be very careful because it's extremely simple to say that we simply disallow every transaction like that. But there are costs to that. And those costs is that you lose some efficiency gains that you otherwise could have had. You lose on capital that you could reinvest in more and better and stronger critical infrastructure. And you get the point. You end up in a situation where decisions that make sense from a business point of view is not taken anymore. And that has a cost to it. So let's dive a bit further into the question of the problem that we were trying to address. Now, what does the notion critical infrastructure mean? Now, we tend to just throw it off our cuff, right? So just saying critical infrastructure as that was a well-defined thing. It is not a well-defined thing. And surprisingly, when you go into legislation and you go into the structure, at least in Norway, you find, well, it's not really defined at all. It is defined for a very small part of it that is related to state security, the security of the government, the security of these things that are at the very top of making the Norwegian state sovereign and functioning. But there are lots of things related to societal security that you would also believe is part of what you would deem to be critical infrastructure, and that is not really defined. So we ended up going to legislation, trying to find out what critical infrastructure, what does that actually mean? Well, in the mandate it says this, critical infrastructure is something that is important for security of the state. Okay, I can understand that. Of significant to security of the society. A bit more unclear perhaps. Carries services of high significance for critical societal functions. And being a technologist myself, I try to put myself in the mindset of a person trained in law in trying to understand it. And I try to understand security of the state, security of society, and critical societal functions. Okay, have some intuition as to what that is. Important, of significance, of high significance. Struggle a bit more there. High significance, is that less or more than important? Not quite sure. And then we continue to read through legislation and we find a lot more of this. The first three I've already mentioned. Instrumental is there. Significant importance, is that more than of high significance? I don't know. A requirement for of significant criticality. And then you end up in a situation where you see that, again, back to the situation that critical. What is critical infrastructure? Although we have some intuitive understanding of what it is, and even though we have hundreds of pages of legislation sort of leaning itself to some definition, the definition actually does not exist. So what we did was that we said that, well, we identify categories of infrastructure, saying that within these categories, there are elements. Within each of these categories, there will be several elements that for any definition of critical digital infrastructure, this will be within the definition. So there is critical infrastructure in mobile networks, in broadband networks, in transport networks, in connections in and out of Norway, for obvious reasons. We just had a talk about DNS, right? Data centers, yes. Systems for satellite communication, yes. Importing physical installation, including fortified sites. There are some fortified sites in most countries that are there to take care of the most critical things in a situation where there are adversaries who have actually entered your country with weapons. And the list is a bit longer, I will not go into that. But then I have discussed with you the difficulty of defining what is a critical infrastructure. The next question then is national control. What is national control and why do we want it? Again, it has some nice intuition to it, because national control, isn't that nice? We would like to have national control. But again, national control, as I said just a couple of minutes ago, it comes with a cost. If we insist that we shall have national control, then it comes with an inefficiency cost, with a financial cost of inefficiency. So national control, in order to enforce that, we need to be a bit careful, and we need to decide what we want to use that national control for, because that decides the dimensions of what we now need to do. So national control is, in our work, it is not a goal in itself. Rather, it's a means by which we can build national security, for whatever national security means. I will not go into that now. So, national control as a means, what does that mean? What would we want to use national control for? Well, to control geographical placement of some things, of course. Of infrastructure, critical personnel, yes. Of course, that is important. In a situation of national crisis, in a situation of war, for instance, we need to have critical personnel within Norway. Home office of the company, yes. The Norwegian state owns more than 50% of Telenor and uses that to decide that the home office of Telenor shall be in Norway. To be able to take over or to control operations in a national crisis, yes. This is something we want to be able to use national control for. And you do that in the situation with Telia and their mobile networks in Norway. Those are being run and managed from Sweden, but there is legislation in place making sure that on very short notice, Telia must be able to move their operations of the Norwegian part of their infrastructure into Norway. To make decisions with the importance of the performance of the infrastructure. Well, yes. We want to be able to use national control to make sure that investments happen, even when investments can only be justified by redundancy and security means, and not by bigger sales or better bottom line. So we need to be able to do these things. And finally, to protect classified information about the infrastructure and about citizens and companies in Norway. We just had a talk just now about how to anonymize information on DNS. Well, there is a lot more information running on this infrastructure in Norway. And also, as was the case for the fiber infrastructure, where we allowed a company from Abu Dhabi to own parts of it. Well, we do not want people within the board getting access to knowledge about where those cables where are actually dug down, because that is secret. So part of the sale was actually made possible because there are agreements in place that the board of this company will not have access to all information about the infrastructure itself. Okay, but what is it that gives us national control? And again, this is sort of surprising. Some of these things are obvious, right? I don't know. This is maybe not an audience who knows everything about the Limited Company Act. We know a lot of other things, but not the Limited Company Act. But of course, if you own 100% of a company, if the state owns 100% of the company, then they have full control. And they have somewhat less control if they own 50% of the company. Well, they can decide whether the home office should be. But that, and some other things, but not that many things. And you can decide some things even if you have 33% ownership. Well, basically you can veto some decisions that others want to make and that you disagree on. You can do that with 33% ownership. And what about regional ownership? Well, is that national control? Say if the municipality of Bergen owns something. Does that give us national control? Maybe it does, maybe it doesn't. What about a private person? If I own something, if I own some critical digital infrastructure, does that give us national control? Well, I'm Norwegian. Should I be security cleared? Maybe I should. Can I be trusted? Maybe I can, maybe I can't. Other things in ownership, regulation, of course. Regulators are part of this game. They can enforce things that otherwise would not happen. They enforce things like battery backups on base stations. They enforce things like what can that be? How to use frequencies, for instance. So there are some national control as part of regulation as well. And then there are all this way down, and down to you come to advice and supervision, which is something regulators can do, but without being able to enforce anything. And in a sense, that makes you feel that, well, that doesn't give any control at all. Advice and supervision, yeah, right. A meeting where we just talk and sit and discuss things. But think back to what happened when 5G came and all countries in the West were in a situation that they needed to decide whether they could allow the companies to use equipment from Huawei or not. Many countries, including Norway, avoided Huawei not through legislation, but through advice and supervision. And the reasons for that, well, they did not want to take the foreign policy toll of making legislation do that work for them. So they did it through advice and supervision. So this is, even though this looks very weak, it is actually something that in many Western countries has been used to get some kind of national control. And then we come to limits of national control. And this is an audience who will not be surprised by what I say now. What you see here is 4 cakes, and we've taken 2 apps developed in Norway for the Norwegian market, and we've put it into the lab on an iPhone and an Android phone, and we try to find out the servers that these apps intended only for Norwegians contact, where are they physically located? Interesting thing is that approximately 30% of them are located in Norway, and the rest is located around the world. Not in any country. Most of this, actually, I do believe all by now, are members of NATO. So this is not a huge cause of alarm in a sense from a security point of view. But what it does tell us is that national control is a very difficult thing to achieve in modern systems. You can do it as long as you go down in the stack, down to the physical infrastructure that you can actually touch and even carry. But when it comes to systems, it is very, very hard. These are, well, what we did was that we took 100 of the most commonly used web pages in Norway and just tried to find out where are they located. Approximately 50% in Norway. The rest of them again spread out around the world. And here we also see countries that are outside of NATO. And again, this will not surprise you. But I can assure you, most politicians, most non-technologists I show this to, they don't believe me. But this is how the world looks. So there are limits to the national control we have when it comes to systems. And there are clear limits also to the national control we can have when it comes to systems. And if you read the mandate that we have been given, I guess your thoughts will be the same as mine. This is old-fashioned. The problem you're giving us to try to answer for you is not in line with how the world now looks in 2024. And there are other things as well, of course. And again, you will understand why I list these things. IP addresses. Yeah, I can write. DNS, domain names and DNS. We just had a talk here about DNS. Digital certificates and certificate authorities. Norway is a small country. We do not have ownership in any commonly used root certificate authority anymore. And if you go back to your countries, you will find out, and most probably your country does not have either. I know that Finland has. But most of the root certificates that are being used are from the US. Time services. We touched upon time just in another talk just a second ago. If you want accurate time, the absolute cheapest way to get it is for free from the skies. From GPS, GLONASS, or whatever you want to use of positioning. That's the cheapest way. And since it's the cheapest way, what happens? Financial gravitation. Most companies, at least small companies, use what is cheapest. And cheaper than free, nothing comes cheaper than free. And of course, GPS has full coverage all over Norway. So that is no problem. And of course, as I've touched upon, international cloud services is part of this. So this question, even though we were not asked it, is we will try to answer it in the report that we are writing. Not because, well, basically because we feel that it is important. If you cannot talk about Norwegian critical digital infrastructure without understanding that there are limits to national control. And then this comes. In 2014, when I led my first national commission, I made the decision that I will not talk about the full crisis spectrum, from peace to crisis to conflict to war. I will only talk about peace and crisis. And the reason for that was back in 2014, nobody would take us seriously if we started talking about war. Now we have to. And again, for obvious reasons. And there are some surprises when it comes to war, because when you get to that end of the scale, we have now get some experience from what happens in Ukraine. And then surprisingly low-tech things becomes important. People who are able to go down in a bomb crater and fix and again splice together two ends of a fiber cable. Those things then become very important. Relatively low-tech, but still rather specialized. And very few countries have this in the amount that it will actually be necessary in these circumstances. And make no mistake, this slide is by courtesy of Jan Marius Evang, whom I believe is still here. He made me aware of these things. The structures that I'm now talking about, the international things that all systems are dependent on, the attempts were made during the invasion of Ukraine. Attempts was made to make that an area where hostilities took place. So contacts were taken both with ICANN and RIPE in order to try to shut down, well, do its best at least, to shut down the Russian internet. Now, we can sort of take, be sort of relieved that nothing happened then, because ICANN and RIPE stood their ground, and they did not shut down anything in Russia. And as far as I'm able to find out, the main reason for that, or the main argument that sort of rang through, was that in a situation like this, it is immensely important that people in Russia still get information from the outside. But knowing that these things took place, this is something that we need to have in the back of our minds when we see the huge dependency that a small nation, like most of our nations, have to structures that are far beyond our own control. I'll stop with this. We will hand in our recommendations in January, and although I know most of what we're going to say, I will not disclose that to you at this point. Maybe I can come back later and do. But these are the questions we ask ourselves, and I've touched upon most of them already during this talk. And by that, I say thank you for your attention.
Thank you very much. Are there any questions? Or if not, we can proceed. Thank you very much. Yes, we are continuing our presentations. I think this is you, Pim. If you can, we can mirror the screen, I guess. Yes, we have here with us Pim van Pelt from Switzerland, I think. He started his career as a network engineer in the Netherlands. That's why I was unsure. Where he worked for InTouch, Freeler, and Bit. He helped raise awareness for IPv6, for example, by launching at IMS-IX back in 2001, launching IPv6 at IMS-IX in 2001 and operating 6SS, a global IPv6 tunnel broker from 2001 through 2017 to its sunset. Since 2006, Pim works as a distinguished SRE at Google in Zurich, Switzerland. And in his free time, he does geocaching, contributes to open source projects, and flies model helicopters. Interesting. He also works on VPP and runs AS8298 across Europe. Welcome, Pim. Looking forward.
Quick show of hands. Who knows 6-Access, this IPv6 tunnel broker? Oh, hell yeah. For those of you watching the recording later on, that was roughly 40% of the audience. All right, cool. It landed me a Vanity AS number, which is kind of nice. All right, so this is me. Hi, son. I'm Pim, and I've been in the RIPE community since around 1999 or so, and a little bit earlier in the networking industry. You can reach me at pim@ipng.nl and also at .ch. In 2006, I emigrated from beautiful Holland to even more beautiful Switzerland. And in the pandemic, I incorporated this ipng.ch into a tiny, absolutely tiny company that does DPDK and VPP routing, the topic of this talk. The picture here, if you're a hiker, you may recognize it's Bessigen in Norway. So IPNG Networks is AS8298, a developer of software routers. This is just normal PCs that will route packets very, very quickly and very reliably. We are an absolutely tiny operator from the town of Brugzellen in Zurich. Don't worry about it, the Swiss don't know where that is either. The second one is maybe a little bit easier to see. You'll note it's all down south from here, but we also operate a ring throughout Europe from Zurich to Frankfurt and then up to Amsterdam. The north, Lille, and then Paris and Geneva. And because the Lille is not London, but it starts with an L, I believe that we are appearing on the flap with about 2,100 or so BGP adjacencies. And I acquired accidentally a 4-digit Vanity AS 8298 from that 6-Access project I talked about before. Real quick, VPP, Vector Packet Processing, also known as FIDO, is an open source data plane that runs in user space, provides super quick networking using tools and libraries like DPDK, RDMA, VirtIO, VMXNet, AVF, and more, which will easily exceed 100 gigs or 100 million packets per second on a 15-year-old PC, which I intend to show you. Started working on this in 2021, had a presentation about a contribution I contributed to, a contribution I made called the Linux control plane, which allows you to run higher level control plane stuff like BGP and OSPF, VRP, things like that. Today, I'm talking about some weird quirks around ARP and IPv6 neighbor discovery and using unnumbered interfaces, which you may recall from back in the day, to run my backbone without IPv4, mostly without IPv4. So quick intro to VPP. It ships with a tool called VPP CTL or VPP Cuddle, and you can give it this command like Linux control plane create from 100 gig 400 a host interface called ICE0. That thing then exists in Linux, and you can manipulate it just like any other interface, give it a couple of IP addresses, maybe create a sub-interface called IPNG, VLAN tag 101, give it some interfaces, some default routes, and then oh yeah, don't ping nonog.net because IPv6 doesn't work, but you can ping ipng.ch, so maybe someone in the committee here wants to like fix their shit. All right, so Babel, who knows Babel? It's super esoteric. 2 people, 2.5 people wavered. This may be 2 3/4 people, because I also heard of it a little bit. So Babel is another IGP, not too dissimilar from things like ISIS or maybe OSPF. It's a mesh network, IGPs. It's meant mostly for wireless networks where everything talks to everything and figures out best routes with loop avoidance. And Bird has an implementation of Babel. It's pretty mature. It looks like this. You can turn on Babel on interfaces that start with an E. It'll become a parent Y. And then run IPv4 and IPv6 using the same transport. So when you turn this on, these 2 routers that are adjacent will start sending multicast IPv6 packets to one another, form an adjacency, and then exchange routing information not too dissimilar from the other ones that you may be familiar with. This one, though, uses only IPv6 as next hops, which is kind of nice. And I did not really know about it until I started playing with this stuff. So consider this. If you show the Babel entries, which is essentially showing all of the information we picked up, when you see my slides here, the thing in blue, in light blue, is where you want to draw your attention, because that's what I'm going to be talking about. So in this case here, 192.168.10.1 was learned on some interface somewhere. And if I take the IPv6 route to 200::1, there's nothing really weird about it. It just has an IPv6 next hop. But if you look at the IPv4 route to 192.168.10.1, it has an IPv6 next hop. Now, who knew that that was possible? Nice. About 10 people in the audience. So you can indeed do IPv6 routes with IPv6 next hops, and actually also the other way around. And so it turns out a buddy of mine called Adrian Pistol had already added code for this in VPP. So if you look at the fib, the forwarding plane, you can see that this IPv4 prefix actually has an IPv6 next hop, and that works. Forwarding doesn't work, though. That was annoying. So I'm trying to ping from one machine to the other, and the pings are not coming through, and you can trace these packets through the data plane, and it shows us, hey, IPv4 is not enabled, so I'm just going to drop this packet. Okay, that sucks. So my first attempt was to add IPv4 by turning it on all interfaces indiscriminately, and then it worked, but trace routes break, which is aesthetic, but also path-MTU discovery breaks, which is kind of problematic. But the pings were responded to. That's at least the good news. So my second attempt here is to set interface unnumbered, which will mean to borrow some IPv4 address from some other interface somewhere. And now these IPv4 addresses that I borrowed from the loopback interface show up in E0 and E1. They're painted there in red. But it doesn't ping anymore, which is weird. And it turns out VPP, up until now, would not respond to ARP requests that were not on the same network that we were. So if you're in the /29, it will respond to anyone in the /29, but if you're only a /32, it would just never respond to ARP at all. So the third and final fix was to inhibit the propagation of IPv4 addresses from unnumbered interfaces. So here in blue, you'll see E0 and E1 only have link local, and as well allow these ARPs to resolve if you're not on net. And with that, the trace route worked. And what you see now is a trace route from VPP00 to VPP03 in a chain of routers that does respond to IPv4 using the loopback address. So these things will work with exactly one IPv4 address. I didn't run a run Babel. That's an aesthetic choice, I think. So Babel has a couple of flaws too, and I'm not going to sort of get into them here, but one of them is that reconvergence can actually temporarily cause loops and disconnect nodes as it tries to figure out, which in an ISP is not the best thing. So at IPNG, we run OSPF for IPv4 and OSPF v3 for IPv6. So I learned that you can run IPv4 OSPF with OSPF version 3. There is an RFC for it, and I know that the IETF today and other talks has gotten a little bit of flack. I'm going to add to that flack, because reading RFC 5838, it says, although IPv6 link local addresses could be used as next hops, then the rest of the sentence is, we will destroy all possibility for you to use IPv6 as next hops. Because what we do now in these address family aware IPv6 speaking OSPF v3 is we'll put the next hop in these link LSAs as an IPv4 address in the bottom 32 bits of the IPv6 field and call it a day. So it fundamentally breaks any possibility of using IPv6 next hops. But Ondrej from the Bird team came up with a really, really cool workaround to this. I wouldn't call it a hack, it would be an anti-hack to remove this damage that RFC 5838 did. He added a function in Bird called update loopback address. And what it does is it scans all of the interfaces you have to find an IPv4 address, preferring host addresses, which are /32, and then OSPF stub addresses, and finally just any old IPv4 address that we can find. And then it sticks that thing in the link LSA, making all of the routes that we then learn from our neighbor called onlink, which means not directly connected in the L3 domain. In other words, if that /32 can speak to another /32 in a completely different subnet, and that would work. But this is a match made in heaven, because with this Bird commit that Ondrej made, and the fix that I had for Babel before that allows ARP to resolve onlink, and the Linux control plane change that I made to inhibit the propagation of the IPv4 addresses from unnumbered interfaces, we can now run routers with exactly one IPv4 address and one IPv6 address on a loopback and keep all the rest of the interfaces unnumbered. So let's try that out. So in Linux control plane, there is a function now called LCP sync unnumbered, which we can disable, which disables the propagation of these addresses. I give loop 0 here an IPv6 and an IPv4 address, and I make these Ethernet E0 and E1 unnumbered using loop 0. And as a result, because of the disabled propagation, E0 and E1 have no IPv4 or IPv6 address. I'll turn on BFD on all interfaces, because I intend to show that we can now share one BFD session across address families. I'll show you a configuration for OSPF and OSPF for IPv6. And notably, that's the thing. There is a laser here somewhere, maybe not. Okay, so OSPF v3 is typically used only for IPv6, but in this case, I've added address family IPv4 as a channel to Bird, which makes it speak this freaky RFC 5838 and stuff the IPv4 address in the IPv6 field. That's nice. Then adjacencies form, and this is where I think the magic starts to happen. The IPv4 OSPF 3 using IPv6 link local addresses. And if you lost me, that's fine. I lost myself as well. But it's weird here to see this FE80 addresses and in an IPv4 session running OSPF v3. Learning works just fine. For IPv6, of course, there is no difference. That already worked before, and it still works now. But for IPv4, I now learn these things like 192.168.10.3, which is at 198.168.10.3, marked on link. So if I needed to reach it, I would ARP for it from my local interface, and I would find ARP resolution and be able to reach these machines just fine. And so the only real difference you see here, which I think is kind of fun, is like all the IP addresses are found at the IP address on an interface called onlink. But the nice thing is traceroutes work with OSPF v3 as well. So now I have a 9,000-byte OSPF, 9,000-byte traceroute that I do from the lab front end here through these 4 VPP machines all the way to the back. And you can see that the responses from the TTL exceeded come from the loopback IP addresses on each one of these routers. So in other words, they all have exactly one IP address. The same is true for IPv6. And by the way, you never needed transit networks for IPv6. I don't know why people do that, but it works with link local just fine. So now that I had this, I figured I would save myself a whole stack of IPv4 addresses by just rolling this out into that network that I operate. So the start situation is each router has a loopback, right? A /32 and a /128 on loop 0, but it also has a whole bunch of these point-to-point transit networks with a /31 IPv4 and a /112 in my case for IPv6. The game plan is to take all of these machines, upgrade Bird with Ondrej's change, and upgrade VPP with my changes, then rename the OSPF4 protocol to call OSPF4 old, create a new one called OSPF4, and then move all the interfaces from one protocol to the other. Seems pretty simple, pretty straightforward. Turned out to be actually, as described, pretty straightforward. And at the end, each router has exactly one IP address. So the upgrade, I think, is kind of magical. So if you've ever upgraded your Juniper, your Force 10, your Cisco IOS XR, it's like a full night's work to get these things to upgrade. And what I'll show here is the actual commands that I grabbed from my bash history. So first, I'll add 1,000 to the cost of OSPF so that I can drain my links, right? That's the first command, reconfigure Bird. Now the traffic starts moving to other paths. Then I'll rename the OSPF protocol to OSPF old. I'll install the recompiled Bird. I'll actually SCP it, and I'll wget a bunch of VPP packages from my website. Then I'll turn into root. And then that pkill command, I love it. Just kill the VPP data plane, systemctl stop VPP and Bird, depackage install the new thing, depackage install Bird, and then bring all the services back up again. How long do you think that took? Like 6 hours, 2 hours, or 92 seconds? 92 seconds later, that thing was back online, pinging on loop, completely converged in the DFZ like a champ. This is really cool. And then we've seen that the OSPF, the V2 OSPF is now called OSPF4 old, that has these interfaces in it, which still have these /31 transit networks. So the next step then is to reconfigure VPP to make it unnumbered. And that's a two-liner. I'll remove the LCP name that used to be called XE11, and I'll call it DDLN1. That's because this site is called DDLN and it has 2 routers in it. And I'll make it unnumbered from loop 0. So I can test this configuration with VPP config and then apply it into the data plane. And from now on, that /31 is gone, right? And the /112 is gone from the interface. And you can see the neighbor still only on link local. Of course, I have to do that as well on the other router, right? So these two things would go in pairs. And then I guess all I have to do is move what used to be called XE11 from the OSPF v2 into DDLN1, which is its new name, in OSPF v3, and reconfig, and the session comes up. So now I have one in OSPF4 old. That's the other interface that I haven't touched yet. The new one that I just moved is active in OSPF4, which is the IPv6 enabled OSPF v3. And I'm learning my neighbor now via 194.1.163.6, which is its loopback address, on link on the interface called DDLN1. And that is it. So then I just need to rinse and repeat. There's many routers and many of these loopback interfaces to renumber and many of these interfaces to retire. And so I go with coffee in hand, one after the other. And this works, in case you were curious, because OSPF and OSPF v3 can coexist in the same router. It's just all the routes are learned twice, and they are preferred within the proto as E1 external routes, like the connecteds and the statics, and they're external E2 between the two, and so the E1s will always win, but if you don't have any, it'll just take the best E2 that it can find. So costs won't work, so draining is a little bit inconsistent, but if you do it sufficiently fast, I don't think any of my customers noticed. If so, they would have probably been loud about it. And with that, the Frankfurt router looks like this. I think it's super cool. So it has 3 links, one to interaction in Zurich, one to entity in Zurich, and one up north to Amsterdam. They do not have IP addresses, and OSPF is just up, sharing BFD with both IPv4 and IPv6, and forwarding using this ARP resolution that I discussed earlier. So a trace route now in the live network has all the blue hops responding from their loopback IPv4 and IPv6 addresses. No more need for any transit networks at all. And in total, I got to reclaim something like 55 or 54, I guess, IPv4 addresses for use in like more useful things than point-to-point transit networks. Pretty cool. Now, why am I doing this? You could have also just bought a Juniper. But Junipers are expensive, and they tend to take a lot of power. Maybe Juniper's not so much, but the Cisco IOS XR machines like the ASR 9K is definitely a 3 kilowatt affair, not a 30 watt affair. So I took this old machine from 2016. It's a Dell R730, and I think I paid 600 euro for it. And I'm going to show that it is as fast, and in fact faster than an ASR 9K. So how do I do this? There's a switch, which is a Mellanox SN2410, which, by the way, runs Debian. Definitely check that out. And I'll use 3 load generators, which are previous generation Dell 720s, that each have 3 dual 10 gig NICs. So that's 18 in total. By the way, spoiler alert, I didn't have more NICs for this test, so I'll get back to that in a second. Then I'll take the device under test, which actually has 6 of these quad 10 gig network cards from Intel called the 710. 12 of them are on NUMA domain 0, CPU 0, and 12 of them are on the other NUMA domain. And then I will proceed to load test them and see if it works. So I'll use T-Rex for this, which is a tool, it's an open source tool that Cisco wrote. You can get it from GitHub. And in its stateless load testing configuration, you just give it a bunch of source and destination MAC addresses, and its whole job is to send out packets on one side, expect them to go through that cloud called the device under test, and then come back out the other side. And if it came out, great. If it didn't, I lost it somewhere, and I'm going to blame the device under test. That's the idea. So in this case, I'm taking a load tester with 4 ports, and then 3 of these load testers to gang up on the poor VPP machine. And I'll start them all up, and then I'll use a thing called T-Rex console and a load test script that I wrote in Python to go test these things at scale. I use 2 methods at IPNG. The first one just uses 1 CPU thread on VPP. It's a multi-threaded app, so if you had more cores, you can just use more threads. But I'll limit it to 1 thread so I can see how much can that 1 thread do. And then I'll just do 1,000 packets per second, maybe 10,000 or 1 million or 10 million or 100 million packets per second into this machine for that 1 thread, completely saturating the CPU. But then I'll know how much it does. And then the second one is RFC 1544, where you just ramp up the traffic from 0 to 100% of line rate and then measure when did the device under test give too much packet loss. So the first test, there's this really nice textual user interface, a TUI, that shows packets per second. In number 1, like the link states it's up and it's transmitting at 10 gig ether in this case. And then some L1 and L2 transmit stats, like how many bits per second and how many packets per second are being transmitted. And then at number 3, like how many did we get out the other side? Hopefully these 2 numbers are the same, otherwise packets are getting lost. And then there's a detailed packet counter and byte counter at the bottom there, right? So with this tool, I can actually do some really meaningful load testing. Shown here, 4 times 10 gig at 64 bytes, which is the smallest we're allowed to send true line rate, which will be 59.4 million packets per second, and just under 40 gigabits of traffic, which would be 4 times 10, and they all come out the other side. So at least this thing shows that with 1 core, I can do 10 gigs of 64-byte traffic on VPP if I just do a simple layer 2 cross-connect, which means traffic into 1 port just gets copied out the other port and vice versa. Here's a table of results for method 1. At the top left here, you see an L2 cross-connect at 1,000 packets per second, and then I ask VPP, how many CPU cycles did you spend on average moving a packet through the data plane? There's very detailed statistics that are CPU clock accurate. So it takes about 991 CPU cycles to switch 1 Ethernet frame from 1 input port to the output port. Interestingly, this greatly reduces underload. And this is the reason of existence for VPP as a vector-based routing engine or data plane engine. It can amort things like CPU instruction cache, data cache, DDIO, if you know of this, to make really good use of L1 and L2 cache in the CPU. So interestingly, when I go to 1 million packets per second, each individual packet only takes 199 CPU clocks. And if I go even further to 10 million, it takes 140, which is an order of magnitude almost faster per packet than at 1,000 packets per second. So in the end, I measure that one CPU thread can do 15.3 million packets per second this way. And I'll note in passing that this machine has 44 cores. So there's a lot of room for a CPU in here. Then I tested MPLS, which comes in at about 10.3 million packets per second per core, IPv4 at 11.1, and IPv6 at 9.7 million packets per second. Obviously, it would be nice if everything was line rate, but it is not. We can still achieve line rate, though, by not assigning only one CPU thread to an interface with multiple. Almost every modern NIC will have multiple hardware receive queues that it can marshal these packets into, and you can have one thread marshal any number of queues. For example, two. Two would be enough. If I take two CPU threads and take two receive queues, of course, if I had symmetric distribution of traffic into the queues, the two CPUs would handle it just fine. Second method here, and then I'm almost done, is a little Python script that just ramps up traffic from 0 to 100% and then figures out how much comes out the other side. And there's a couple of interesting profiles you can do. When you see vendors say we do up to 20 gigabits, what they typically mean is we'll send it like really big packets so that we don't have that many of them. And so 1514 would be a typical Ethernet size, plus, of course, Ethernet overhead. And it will be very simple to do. It's only 800,000 packets per second to saturate a 10 gig port. Internet mix is a mixture of small, medium, and large packets, which is about 3 million, 3.2. And then if you send the smallest packet you're allowed, it's 64 bytes. You could send smaller ones, but they're called runts, and you're supposed to drop them. But 64 bytes is allowed, and then you can do 14.88 million packets per second with a 10 gig port. And there's an insidious version of this where you send only one flow, always the same source and destination IP and port. And so all of this traffic has to go through one queue. There's no way for us to hash it. Also has to go through one lag member if you had LACP, goes into one CPU, and this is a really great way to break not just VPP, for the record, also your Juniper and your Cisco IL6R machine. So first I do one port, and there's a Grafana graph there that shows this one port in 1514 bytes, it's easy, right? The chassis doesn't even get warm. Then IMIX, which does 9.2 gigs of L2 traffic, and by the way, it starts to matter if you're talking about L1 versus L2 because of the Ethernet overhead, and the smaller your packets are, relatively speaking, the more overhead you have. So in number 3 here, I do 64 bytes, and you can see that it starts clipping there in the middle. And it does roughly 5.67 gigabits per second, which is 74% of line rate. It's not 56, as you might maybe intuit. And that's because at this line rate, you have so much more Ethernet overhead, like the 12 bytes for the MAC, and then the 2 bytes for the type, and then the interspace gap, and the CRC. It all really adds up, right? So your 64-byte frame turns into 84 bytes on the wire. But it's not bad doing 74.6% with one network card. Then I tried 6. So this is 6 ports, each with one CPU thread. And I note it scales almost linearly. So we still do line rate with 58 gigs on 1,500 bytes. We still do line rate with IMIX, and about 72.4% or so with the really small packets. I'd say it's good enough, but it's mostly important to prove that if you add more CPU threads, you just get more performance. And then the gold medal, it's really nice how that UTF-8 does not render the same on Windows. A bidirectional 18 ports, 18 VPP threads. So now I'm sending 180 gigabits per second of traffic, which is 14.7 million. VPP is packet bound, so this is actually really easy for it. As long as you have enough PCI bandwidth, it will scale up to a terabit, no worries. Easily 100, it did 180 in this case. And then the other direction, where we send like really, really small packets, my claim was you can do 100 million packets per second on this. So again, 18 ports, bidirectional traffic at 128 bytes. And I'll tell you in a second why that is. did 165 million packets per second just linearly. And I'll note again, the machine had 24 NICs and I could only use 18, and it had 24 CPU threads completely unused, so I could add them in as well. And then why did I not use more CPUs to perhaps get more bandwidth through or more packets per second through? The answer is Intel sells you these 4 times 10 gig NICs, but the silicon is capped at 35 million packets per second. And if you had 4 times 10 gigs, that would be 4 times 14.88, which is almost 60 million packets per second, but the NIC never received them. And so here we're bumping into not the VPP throughput, but the Intel network card throughput. And with that, I could prove as well 100 million packets per second on this 11-year-old Dell R730. 4 minutes left on the clock for questions. The easy ones go to me. There's one VPP committer in the room, so the hard ones can go to him.
So, Tor Andersson, Red Pill Pro. I'm interested in knowing how the size of the fib impacts the performance. Like if you have a full DFC with million-ish routes, is that...
Yeah. It's a really good question. The practical answer is it doesn't. Because your hardware router is going to use some CAM, which is hugely constrained. This one uses memory, and you could put 128 gigs of memory, right? And it's easy, but memory is expensive. Most of the fib will fit in L2 cache or L3 cache for sure in the CPU. One thing is important here, when you run VPP in a high-performance situation, you don't let anything else run on the CPU. So you would take, say, this 22-core die, and you would move 20 cores to be completely isolated, and use 2 cores for Linux and the control plane and things, and the other 20, including their L1, L2, and their shared L3, you leave completely to VPP. Most modern CPUs will have like 125 or 160 megs of L3 cache, and a whole fib, if you take a million, which would be the current internet, is what? A fib, a bunch of trees that point at a MAC address, essentially, and an interface index ID. I'm not sure how big it is, but maybe 16 bytes or so. So a million would be 16 megabytes plus some pointers, right? So it easily, the whole thing fits in the CPU. And because it does, you're at nanosecond lookup. You're as fast as CAM.
Thanks.
Thank you.
Any other questions?
You gave up?
No, it was good. Here.
Who is the audience for these products, if you'd like?
So not everyone can afford a hardware router. You know, if you look at small ISPs or enterprises that do want to play along with 10 or 20 or 100 gig, they may not want to or be able to afford your Juniper and your Cisco router, but they can reuse a PC that they already had, right? Especially if they're a little bit older. So I think it's popular across the board as a fast data plane, even for Linux host applications and things like a Kubernetes CNI, if that makes sense. Very fast in load balancers. You can do all sorts of hyperscale type load balancing with it. Also run an ISP like I do, where each of the machines runs at 35 or 40 watts of energy consumption, rather than what my friend does that provides me the intercity links on his ASR 9K that's 4 kilowatts. If you think of sub-Saharan Africa, it's easier to build there with commodity PC than it would be to import large amounts of things like an Arista or a Juniper. It is a little bit more higher learning grade, right? But I've run mine now, knock on wood, for about 3.5 years, and I've had only one pretty bad issue with VPP that made the routers crash. Otherwise, it's rock solid. So I think any one ISPs that are sub 100 gig, that don't want to buy 10 pops worth of MX204s, or they're actually out, so 304s, would be a good audience for this. And anyone who uses Cisco IOS XR will note that this whole thing is modeled very closely behind Cisco IOS XR as well, so you'd be a fish in water if you were to use them from a Cisco background.
It's not really a question to Pim, actually. It's more of a question to the person who asked before. But to sort of enlighten you a little bit as well, is that specifically in Africa and sort of the rest of the developing world, most of those people are buying, or a large number of those networks are buying things like MikroTik because they hit the price point correctly for basically being viable. Now, MikroTik have some downsides attached to them, mostly speaking the software quality, but they're fantastic in terms of performance. If you can build effectively a better MikroTik out of a 2U server that you can potentially import or even just have sitting around in the secondhand market, that's a massive deal. You can provide faster internet to many more people. And so like this is potentially a massive game changer for people who are less sort of capital flushed for such things.
Yeah, and maybe to add to that answer as well, I didn't talk about that much, but VPP has an enormous feature-rich environment. L2 forwarding service, cross connects, MPLS, L3 VPNs, L2 VPNs, private wires, all of that stuff. And because of the Linux control plane, you can use any old control plane with it. Bird, FRR, OpenBGPD, they would all work out of the box without any changes. So if you're already used to that with your Linux router and you're struggling at 10 gigs plus, moving to one of these is an obvious choice. It's still Linux, it's still cheap, it's an order of magnitude faster, and open source. One last question, I think, and then I got a jet.
Hi, this is Alexei from Finland. Does VPP have some sort of a built-in firewall or access list generation?
It does, yes.
Is it like Cisco-like as well?
It's even more awkward than Cisco, yeah.
Oh, great.
Yeah. And so the way VPP works is it has a plugin system, so there's a bunch of core stuff in the middle that's always linked in, and then you have any number of plugins that you can write. There is an ACL plugin, it's a stateless plugin, so you can give it lists of L5 tuples, proto, port, IP, prefixes, things like that, and add them either to a permit or a deny. It doesn't do stateful firewalling, but certainly for stateless, that works just fine. And then there's a second implementation, which I think is super clever. There's one that you can add a bunch of IPv4 and IPv6 prefix into a fib object, and then hold the fib against all incoming or outgoing traffic to do L3 only filtering, but with fib lookups, which are much faster than linear linked lists.
Does it have any rate limiting primitives?
It does, yes. It also has rate limiting. It's relatively lame. As Dave Tott would say, it is not codal. It's just color-aware, 2-bucket rate limiting that can do bits per second and packets per second per interface. And if you're into the DDoS or anti-DDoS world, it also does IPFix and flow probe. And if you catch a talk next year, you'll see that we're working now on S-Flow as well, with an S-Flow agent in the data plane that will allow us to do sampling at a very affordable CPU cost per packet. Thank you for your time.
Thank you very much. We will proceed further, but before that, I'd like to thank Pim for saving 10 minutes. You're supposed to have 45 minutes.
I started early.
Yes. So we will just proceed, and then we'll hopefully end the day 10 minutes earlier. So, our next presentation, the last one before our break, is Test Before Deployment from FiberWorks by Jørn Nielsen, who began his career in the cable TV industry in 1995 and transitioned to the optical industry in 2000. He currently serves as product manager for fusion splicers, test and measurement instruments for fiber optics and Ethernet at FiberWorks. Welcome, Jørn.
Thank you, Emily. I realized when all the people here have these incredible resumes, and I was kind of short when I sent these few lines to Marius yesterday.
Well, my name is Jørn Nilsen, and I've been to Fiberworks for a couple of years now, 6 years in total. I would start to talk about testing before deployment. And before switching to the next page, I 20 years ago delivered a couple of fiber optic lines for the NICs in 2000 or 2001, then when they started with the NICs2 downtown in very close to this location. And I thought that, 1 gigabit per second, that was tremendous. But this is like the roadmap, what IEEE have been doing for the last 30, 40 years. And you see that when we started at the beginning of 80s with 10 megabit, and the first 30 years, we had this slow increase in data rates from 10 megabit to 1 gigabit. And from let's say 2010 and upwards today, we are looking at 40 gigabit. That is like a dead end. We have 100 gigabits. We have 400 gigabits. And just February this year, the 800 gigabit was approved by IEEE. And we're probably looking at 1.6 terabit per second in July 2026. Okay, why should we test before deployment? Well, Norway is quite long-stretched. We have been saying that and repeating it towards the day. It's a long-stretched country, and we are also spanning towards 3 time zones when we're looking at the map in a correct perspective. We travel a lot with cars, airplanes, whatever, ferries to get to the different data centers. We also have this barrier with getting the access to the data centers. That itself is a cumbersome process, especially when you have these high security data centers. You have to go through the assets to get every bits and pieces that you get into the data centers, if it's transceivers, the DAC cables, test instruments, whatnot. Everything needs to be signed for, scanned, uniquely tagged and checked into the different control systems. This is time and cost intensive. So it's all about preparation. You would probably need the right tools for the deployment. And you need to perform verification of the equipment that is going to be used in the data centers when you are connecting the different routers to the SAN, WAN, LAN, to the outside world. That is blank page, not intentional. So basically, we're talking about 3 testing tasks, categories. We have the system verification at the testbed level. I'm not going to talk about that. We're going to step 2, system installation and integration. This is where we are talking about today at the deployment stage. System monitoring, this is also not a topic today. So during a deployment, the team needs to perform acceptance testing on equipment and then verify network and data center performance using simulated traffic. How do we do that? Well, this kind of equipment, the transceivers and the DAC cables, they need to be evaluated prior to the deployment to ensure that they meet the specification. These kind of things, of course, have a fabric approval. When they have been manufactured, they are going through burn-in stages, but after that, they are handed over to UPS, DHL, whatever, and it's been shipped to, our warehouse, to Cisco, to the different other hardware vendors out there. A lot of things happen to these components. We need to check the key characteristics that includes the bit error rate performance and optical power levels, both in terms of the output and the received power. Also, we need to do some quick readouts of the I2C registers to check that this could be rewrote in the fast pace. Also, it is important to check the power tolerance and the overall power consumption of the module. And of course, when we have the high data rates that we're talking about today, we need to have assurance that the clock generation and offset needs to be evaluated. So that leads me to this sweet beauty. This is an actual 400 gig tester, and today at the ECOC in Frankfurt, my vendor VX, together with the Internet Alliance, launched the Dual 800 gig tester. So we're talking about tremendous speeds here. One of the biggest hyperscalers in the world are actually using this on a daily basis in data centers all over the world, including the data centers that I have in Norway. They need the correct tools to verify this. We could use this for advanced network testing, going through, let's say, Stavanger to Oslo. But this is not what we're talking about today. We are evaluating the different small components that are interconnecting the equipment inside the house. So we need easy configurable test and a user-selectable duration for the bit error ratio test. And if we also have like 400 gig transceivers and higher, we also need to have some validity of the post-forward error check. We could use one instrument as a dual port. You just plug these two in the different ports and do a local test. But if the cable is getting too long, let's say a 10-meter dock cable, then we need to have two instruments. Like I said, this illustration. So, what do we need to do, basically? I'm a cable guy. I don't have a clue about TCP/IP and all the impressive stuff that you're talking about here today. I need an instrument that is giving me an auto-configurable setup that is doing all the nitty-gritty work with configuring all the equipment. I'm plugging in the dock cables, selecting the duration of the birth time and the frequency, the FEC duration. All this is expressed in seconds, and well, it doesn't make sense to use like 1,000 seconds or 3,600 seconds. You use a reasonable amount of time. The default is like 300 seconds per test, so it takes about 10-15 minutes to do a final test. You need to decide by yourself if it's enough just using a 30 or 60 seconds test. Enter the desired time, tap start, wait a little bit, and then you hopefully get a pass. And having a pass means that, okay, I'm good to go. I could plug this equipment, the DAC cables, the active optical cables, into my equipment and starting the process to give the services and whatnot that is needed for cloud, Azure, AVS, what else is behind there. You have this pass. You could obviously look into the different summaries of each lane's frequency and the deviation offset that is expressed in parts per million. We could look at the aggregated and the aggregated bit error count. We could look at each different lanes, if it's 4 like it is on a 100 gig, or if it's 8 in 400 gig. Well, you'll get it there. Also, all the events here. It's just 2 events. We have started the test and we have ended the test. All this could at the end be exported to a test report if you need to have it. I could also show you this, but then I will probably screw up. It's a PDF here, so I could open it, but I will screw up the presentation. Okay. What if we are putting up a service that is going outside the data center with a transceiver module? This could be a short range inside two of the cubes on the data center, or you could have the really coherent versions of the 400 gig giving you 120 kilometers of distance. That is quite impressive. We need also to have the same easy tools to actually do this type of verification that the things is working before we are activating it. So equally to the duck cable test, we also have this advanced optical transceiver test possibility. It gives me the possibility to monitor and verify the optical signal levels, the BERT, the voltage and frequency swing tolerance, the I2C, read-write, and pre-and phases modulation. And it's quite easy here as well. I just need to, put up the, that is on a different page, sorry, the time for the BERT. But I could also use the auto test. That's my go-to when I have the time to wait the default 5 minutes on the test. When we're going through the different pages, we will see at module information the temperature on the cage and the module itself. The cage is the surrounding opening at a router on the switch. And this is the module itself that have different temperature. And when we have the high powered devices, it could get incredibly hot. The prefec should preferably be as low as possible because reasons I don't know, I've just been told, so sorry about that. Frequency offset should obviously not deviate between the different lanes because that would mean problems. During these tests, we are forcing the different voltages. Let's see if I could just find this one. We will, through this setting, we will provoke, try to stress the transceiver as much as possible to get it to make faults, to make BERT faults, to make the frequency deviate. So it is quite a stressful test for the components. We have the optical power readouts and the optical power outputs and aggregated power of all the different lanes that is used in, let's say, this 400 gig that has 4 different data lanes with 4 internal wavelengths. Same as here, we could have this final test report as backup of that the component that I'm putting into the data center actually is good to go. But as a cable guy, I'm equally concerned about what happens with the fiber optic connectors. I would say that in the small details that we have a big issue. And one of my vendors are saying that up to 80% of all the network failures are caused by contaminated connectors. And believe it or not, even new connectors are prone to contamination because it is not manufactured in clean rooms. It is made by real people in factories, in dusty environment. And when it gets to you, it is used in the real world. That could be a dusty place. And even taking off the dust cap on a fiber optic connector could build up some static energy that could withdraw the particles that is inside the air that is surrounding us. We have lots of particles in, let's say, 2 to 5 microns in diameter in size, and that is actually blocking 50% of the light coming through a fiber optic connector. And there are people that is using it. We are going to connect it to the patch panels, to the transceivers. You can easily touch the end face. So also here, we need the correct tools. Cleaning is critically important. So we have been talking about this from the beginning when I started. Clean every time you connect, and then you have no failure. There is one thing I will talk about in a slide or two. Plugging in a dirty connector will for sure damage the equipment that they're using. If it's a test instrument, if it's a coherent 400 gig, they are shitty expensive. You're talking about tens of thousands of euros, and that is not something you would do. You will destroy, you risk to destroy the other end. New connectors are commonly contaminated out of the bag, so it's important to clean all the test ports, test chambers, and launch cables when we are doing tests. We need the right tools at hand. So we have had this type of microscope that is using an IEC standard called 61335. And this is both for single fiber and this multi-fiber connectors. This is its beauty. And very short summary of what we are looking at. We're looking at what is inside zone A. That is the most important zone of a connector. If there is any contamination, if it's dust particles, any other types of damages, this test will fail. You will need to try to clean it. If it's not possible to clean it, then you just throw it in the bin and take a new patch cord. We have this zone B, that is the cladding of the fiber optic glass. That is also, well, kind of important to have as clean as possible and no damages. But obviously, this is not where the signal is going. The signal is going in the core of the fiber optic, and the cladding is making just a different barrier, so the light is trapped inside the core. So it's not that bad to have anything there. Using connectors like an LC or SC, then we have to glue this fiber glass inside something that we could touch with our hands to the ferrule. You could have as many defects as possible there. And the zone D is area out to 250 micrometers on the connector. We still have plenty of space on the ferrule. The LC connector is 1.25 millimeter and the SC is 2.5 millimeter. So you can imagine that this IEC test is very limited in the area that is analyzed. Okay. Up to February or something, 2022, we had edition 2 of the IEC standard. We have realized that we are starting to use these multi-fiber push-on connectors, also called MPO, or MTP if it's a registered trademark by USConnect. We need to have something that could analyze all 8, 12, 16, 24, 32 fibers on the connector. But we also need to have a visual identification of the steering pins and the guiding holes to ensure that the connectors are clean. And that is the beauty of having a modern microscope in your tool bag. The thing with edition 3 is that this is a less good. It allows more defects on the connectors. From my point of view, I don't like it. The operators that is owning the data center, the telcos that is owning the fiber infrastructure, they don't like it because it gives the people doing the job the chance to not cheat, but they will get away with less cleaning, would I say. It allows more dust, even inside the core. The reason to have this edition 3 is that when we are cleaning these MPO connectors, it could be a nightmare to actually get all of this clean because the tools you're using is cleaning all in one go. So it's easy to actually damage one of the cores, or if there is a small damage already from the manufacturer, but it doesn't impact the optical transmission, well, then let it go. It works probably more than good enough, given that it's not bigger damages than what's inside the standards. I will kind of finalize my presentation with this small thing from Cisco. This was actually published back in 2004. And this has kind of been de facto standard for the industry, where we are talking about how we should do the inspection of the connector, how we should use the cleaning tools. We always start with a dry cleaning session, do an inspection, and if it's clean, then we're good to go. If it's still dirty, then we need to go to step 2, new dry cleaning. And then we proceed with a new microscope inspection. If it's good to go, then connect. Otherwise, go to a wet cleaning process. And you can see this is like a long process. You will probably sometimes get an infinite loop down here where you are not able to get it clean. Then, well, you will never be able to connect it to the equipment that you're going to use. So then you need to do some actions to get it fixed. If it's just about to get rid of a patch cord, then you're lucky. If it's the optical distribution frame itself, then, well, you need to call a technician. Okay, I don't have that much more about my easy transceiver DAC cable testing. My experts are, like I said, in Frankfurt today, and I would more than ever love to have them here to talk more geeky stuff together with you. But nevertheless, thanks for the minutes I had together with you. If there is any questions on the layer 1 side, the physical side, then I could probably answer it. If it's higher up in the OC, so hierarchy, then we'll grab a card and then I will connect you together with the real experts.
Yes, thank you very much. No, I guess people will reach you during the break.
Yeah.
Thank you very much.
Thanks.
We will take a coffee break now, last today. It will still be half an hour. Or I think we can reconvene 4:15. No, 4:45. And then we will end the day 15 minutes earlier if that's all right with you. Thank you very much. I think we can resume our last set of sessions. It's just how many there are? 5, 6 with the quiz before us and the dinner. We will start with a couple of 15 minutes sessions. The first one is by Antonis Charrington, who will be talking about reviving BGP zombies. Just a second. Antonis is a researcher at the Cisco Switzerland with a focus on routing, security, and internet measurements. Welcome, Antonis.
Thank you very much. So, we're going to talk about BGP stack routes like Ben did earlier. Another alternative name is BGP zombies. Over the summer, we were able to host a wonderful intern, Iliana, from Georgia Tech. She's doing her PhD there, and she spent 3 months with us studying BGP. And this presentation includes some of her findings during the 3 months she spent with Cisco and Thousand Eyes. So, what are BGP zombies? Well, Ben answered that earlier, and we only have 15 minutes. So, I hope you remember. And why is this a problem? We went into that. Effectively, when routes get stuck, the routing tables start to go out of sync. So all of the routes that we had to use before are suddenly not necessarily there. And if you deaggregate a prefix for traffic engineering, and then this gets stuck somewhere, you aggregate again, but this path still keeps being used. Or if you have DDoS mitigation and you have certain amount of hours per month, because this route will be stuck and someone will keep using the mitigation path, your quota for DDoS mitigation may run out, as this path is still seeing, megabits or gigabits of traffic. But of course, the most important thing is that, if you think you're routing to a place that's not there, a path that does not exist, it's not great. And this is a problem if your prefixes are stuck in someone else's router, but also if your router has stuck prefixes. Both of these things can happen. And another thing to mention here is that if a withdrawal is lost, the route is stuck. But withdrawals are not the only messages. There are also announcements, and announcements can also be dropped as well. So suddenly, like, your prefix may not have 100% reachability, or some of your paths may not be visible. But you have, hundreds of problems. We learned about problems with time, with IPv4 shortage. Is this a big enough problem to care about? And this is what we try to answer. Like, is it important? Should you be worried about that? And we thought we created the BGP clock to answer this. And what we did was slightly different approach to Ben's, in a sense that there was this prefix that included the hours and the minutes, and it kept being updated every 15 minutes. So 4 times an hour, we had a new prefix out. So the previous one was withdrawn and a new one was announced. And this means that every 24 hours, the prefix would come back again online. And then we changed it a little bit to have this repeat every 2 weeks. And I created a ROA on the RIPE portal. I see Windows and PowerPoint ruined my emojis too, not just PIMs, yeah. So I created a ROA on the LIR portal with my AS, and then we started advertising it. I have a personal AS, 210.312 here, 1,700 BGP neighbors, and I started basically cycling through all of that every 15 minutes. And Ben called it a route cycler in his blog, but today we agree on the terminology. We agree on the BGP clock trademark, No, just kidding. And the idea was that we can get more data like that. So if we have this happen more frequently and it does not repeat as often, we can see much further into the situation of stuck prefixes. And this is one of the prefixes we found. It was stuck in a free SAS, like this is a French AS with over 200 ASNs in its cone. We think all of them had the route stuck, but only 6 ASs there we had BGP feeds from that we were able to tell that this is the case. And this is the common subpath here. So to visualize that, you can see here, like in the red square, it is the AS that we think is causing the problem. And why we think it's there? Because if it had happened after this AS to your left, then it's unlikely for all of the ASs to have a route stuck at the exact same time. And if it had happened before, like in the previous AS, after IP max, then it would probably affect other downstreams of this AS as well. So all of these stuck routes, they look like a palm tree. They have a single trunk that's going from my AS to PIM here, actually, and then it's going further, like the trunk is there, and then all of the leaves of the palm tree suddenly explode. And this is how we can guess where the routes are getting stuck. And this is not a problem of the network necessarily, like maybe the previous network did not send the message. We don't know who's at fault, we're not blaming anyone, we're just trying to understand where these happen to be able to help the operators better address these issues. And we had some larger ones. This is Core Backbone, a German network over 2,000 ASs in their BGP cone that was stuck because they're a very big network. We had a lot of peers that were seeing this route. And this particular network has been observed by Ben here as well to have stuck routes in the past. So it's probably something extreme going on there. And a final case is another German AS here that we observed a very, very long route that was stuck there. So we kept running this BGP clock for a bit less than a month. It causes, many updates. It's not good to keep it running throughout the year. We collected our results. We shut it down. I went to the LIR portal. I deleted the ROAS. Everything was fine. And then, after some point, I started getting emails from RIPE. And you probably can't read that, but if you have RPKI invalids, they send you an email and they say, hey, if this is intentional, just create new ROAS. But if this is hijack or something bad, please have a look at it. And I kept getting, I got an email the moment I deleted the ROAS, and they said, okay. Now it's been around 3 months later, I keep getting the emails. So these prefixes have been RPKI invalid for over 3 months, and they are still there, they're still stuck. So that's something additional we were able to find, that not only do these routes get stuck, but because they're valid during propagation, then they can also bypass ROV by tier 1s and by IXPs, and then they get stuck into the edge networks or into some smaller networks, and they turn into invalid. They're never removed from the routing table. So what did we learn from all of that? We looked, first of all, at the time it takes. So you can see here that over time, over 2 or 3 hours, the prefix is, the amount of stuck routes is dropping very quickly, about 2 hours, and then it more or less stabilizes, and it can stabilize for weeks or months. So these routes remain for a very long time into the routing table. And here you see 2 lines. The main reason is that we found 2 ASs that 10% of the withdrawals were getting stuck there. So for one in every 10 withdrawals, we're getting stuck in their ASs. And we had to exclude them just because it was a very noisy data set with them. And the other interesting thing that we found is that if you look at this graph here, around the 160-minute mark, the zombies are going up. So routes that were removed are coming back into the routing table. So we try to understand what's going on. And for this particular event here, we found that someone was actually creating announcements. And when are announcements created on BGP? When, there is a link down, you set up the BGP session again, so the other peer has to send their full table again to you, or their prefixes or whatever. And these announcements actually reignite all of these stuck routes. And we have identified routes that actually gained visibility over time. They were out there for a few weeks, and then they started becoming actually more infectious than before. So reinfections can happen. This particular one was at Telstra Global. Over 5,000 ASs were affected. And obviously, the more ASs that are under the network where the routes were stuck, the more likely it is to cause these reinfections and have these routes remain forever. And we have a few tens of prefixes that are still like 4 months now. Even though they're RPKI invalid, they still remain stuck on the global BGP table. So that's all I had for you. Thank you.
Thank you very much. Do you have any questions? If not, we can proceed.
There is one.
Oh.
There.
Tor Andersson, I was wondering, did you try to reach out to Telstra and the German one and those that actually have this problem and ask them to debug it at their end?
Yeah, so this usually, like on the internet, unless there is someone being affected negatively, you don't tend to reach out. We currently collect more data to try to understand why that happens. And then we plan to reach out to everyone that we thought was affected by this to figure out more patterns, like if they use some type of common equipment or anything like that. This is some preliminary, results. We're still working on it to identify more of the causes, and then we plan to reach out to the networks we found affected by this and help them figure it out and make sure it stops happening. But the send hold timer that's been proposed, if implemented, would automate this for us. So please use it, please request it from your vendors. I think it would be much easier.
Thank you.
Ben.
So you say request it from your vendors. I couldn't help but notice the company name at the bottom of the slides.
Yeah.
Is that potentially a commitment? I know I know it's unfair because you're not necessarily part of Cisco proper, but would you be able to push Cisco into being interested in?
I mean, I will have to discuss it with everyone, and we will make any public announcements we may make in the future.
Perfect.
So,
perfectly neutral answer.
Yeah.
Yes, thank you. No more questions. Then thank you very much, Anton. It's very good. Yes, we are proceeding now. We have a different topic. We have Ulrich Visser from ICANN, who's going to talk on universal acceptance. He has joined ICANN organization as Regional Technical Engagement Manager for Europe. That was. His main role is to support ICANN organization's technical engagement efforts in the region with trainings, promote DNS standards and best practices, promote research. He had a 15 years tenure at the Foundation for Internet Infrastructure prior to that, the Swedish CCTLD registry, the .se. He has served as co-chair for the Center of Technical Tech Working Group and on the DNSOARC program committee. Thank you. Enjoy.
Hello, everybody. So, yes, after that introduction, I don't need to say a lot. Yes, today, universal acceptance. So today we have heard a little bit, we have been down to the cables and undersea and whatever. So now I want to take you a little bit up the stack, all the way to level 7 and above. And actually, this is a story about something that is actually important for the internet, that maybe not is super important directly for you, but where you can really, really make a help. Well, you probably know that the world is multilingual, and there's a lot of languages in the world. And, well, most people don't have English as their native language, although most of the content on the internet is currently English, but that's rapidly changing. And if we look at the internet population today, so then it's, I think this is from last year, the number, so this year we're probably closer to 6 billion people, not really there yet. But when you see at the geographical distribution here, the really interesting part is where there is no bars. You know, where is the people that still have to come online? And that is mainly Africa and Southeast Asia. And a lot of people in these areas don't speak English. And not only that, they don't read English. They can't read the Latin alphabet. Okay, and that's a problem. Because if you think about, like, how will these people come online? Most probably, they will buy a cheap Android phone, because that's all they can afford. And what is the first thing? You open the box, you take the phone out, you power it on, and the first thing you have to do is make a Google account. And how you do that if you can't write English? So, well, we have made some progress in this, that, for example, in the last TLD round from ICANN, we had a lot of IDN domains, internationalized domain names. So that is domain names in different scripts. So, for example, you could have one for Norway in Norwegian. And some European countries did. India did a lot of them. They have a lot of languages. Small side note, at home I run a small judo club, and we have a family from India, and they speak one of the minor Indian languages. There are only 75 million people. So, yes, and so that I think that is something that is, you know, if we want the world to become online and we want to be everybody to enjoy what the internet can give you in your life, then we need to be able to make everybody welcome, and that means people that can't read and write English. And that is what universal acceptance is about. Okay? So we jump over this, and so I wanted to go just very shortly into the how the DNS does this. And so IDNs is internationalized domain names. We do different scripts. There's a lot of rules around this. They are called IDN 2008, and they basically say which characters can be in a domain name and which can't. And this has a lot to do with security, come to that, and it's not emojis, okay? We come to that too. So what do these names look like? Well, they look like this. These are just a very short list here, but we have now over 1,500 domain TLDs in the root. And, but as you see, there is a lot of ASCII names, and then there is some other scripts. And if you look very closely at the last one, it has the dot on the wrong side, but it's not the wrong side, it's Hebrew. They're writing from right to left, so Yeah, right to left. Yeah, I know. Okay, so internationalized domain names. I got so little time. Yeah, so but the special thing with internationalized domain names is that if you have the ASCII domain names, there's only ASCII. You don't have, you send on the wire what you see in your application. But with internationalized domain names, we have these two forms. We have the A label form, which is the ASCII label form, and we have the U label form, which is the UTF Unicode label form. And as you see, they are very different. Why is A label and U label? Oh, I think there's somebody messed up here. They need to be the other way around. Okay, so the XN-dash indicates that it's a internationalized domain name. And then after that is some Punicode or translation, and that is how it looks on the wire. But that's obviously not very user-friendly. Especially when you look at the Mandarin, it's like, nobody can read that. Okay. So just a small detour. Let's see, why are emojis not a good idea? Well, first of all, they are very similar. These are 6 different emojis, not the same emoji. And if you see them besides each other, it's easy to see. But if you see only one, it's really hard to know which one of those 6 it is. And so, like in these two, this is not the same, would not be the same domain name. It's the it comes in worse. So this is the same domain name, but on 3 different platforms. Well. That's why emojis are not a good idea. Or this one, you have the same emoji, but it has different colors of the skin. And, from yellow to dark, it's easy to see, but from, little bit, then it's just really hard to, if you just see that one emoji, it's really hard to know if it's the same or is it not the same. And that's why emojis are one of these characters that are not allowed in domain names. And there's but what universal acceptance is actually about, that is email address internationalized. So all of you have an email address. None of you has an email address that has a non-ASCII character in it. And that's obviously because otherwise it wouldn't work. Because a lot of places don't accept email addresses with special characters in it. So there is a standard for this. The IETF has worked on this, and they have made a standard that allows this, but still it's not universally accepted. And that's what universal acceptance is about, to change this. It's not about the content of the email. That is a MIME standard. We all hate MIME, I know, but that's what it is. That's what we have. Email address internationalized is about the actual email address and information about that in the header fields of your email. Okay, so there's there's some nuance to this. So if you see this, so if we start here, we have example.sky, and that's a new top-level domain, right? So we all remember the original ones: ComNet, org, mil, edu, int, yes. But that's a new one. It's 3 letters still, but it's a new one. So then you have a little bit longer ones, engineering. It's more than 3 letters, very problematic. And then you have Unicode domain names. And if you look at email addresses, they follow the same, but then you can have even special script in the user part. And people always ask me, but how would I write these? Well, you wouldn't, because you don't have to say anything to these people. If somebody can't read and write English, and they can't read and write Norwegian, what would you say to them? But why wouldn't we not allow them to communicate with their peers in their own language? you know. So, and as a result of doing that, we could also have our own names in our own language with our own characters. It's not so hard, you know. So ICANN has actually made a study into this. And what they tried is go to the, you know, take a list of the most popular websites and then try to register an account and write in an email address. And as you can see, well, the acceptance isn't too good. Yeah, even the low, yeah, the bar in on the bottom, it has the biggest acceptance, but that includes even email addresses that end in .info. That .info is actually older, 20 years, over 20 years we have .info, and still email addresses with .info are not accepted everywhere because it has 4 letters and not 3. Because people use, so if the next time you would think of, oh, we have to do email address validation, how about not using a regex? Please. So you can see that if the TLD name gets longer, then if you start in getting IDN stuff involved, the acceptance gets lower and lower. And if you really go to a totally different script, then it's just almost nowhere. And I mean, you can even see that Arabic isn't just, you know, it's not a small language or something. So, so how does all of this work? I mean, we are still at a nerd conference, so I looked a little bit into how this works. And so there is an SMTP command that says, hey, I can SMTP UTF-8. And there's similar for IMAP. We jump here. I thought I had half an hour, so I have to jump a little bit in my slides here. But you see, in email, nothing is easy. Absolutely nothing is easy. And that is because there is so much involved. So you have the clients that sends an email, and then you have the mail sender agent, the mail transfer agent, the receiving mail transfer agent, and then you have the spam filter, and then you have the storage, and then you have the delivery agent. It's, you know, it's a mess. But in each and every step you see here, everywhere where there's an error in this, we have to support these new type of email addresses, otherwise it will fail. And that's one of the problems. So we try to work through this, and with the help of everybody, we can, at some point in time, get to a solution to this. Okay. So, but on a protocol level, it's really quite easy. What it does is, you connect to a mail server, you say hello, and then the server gives you back a list of capabilities, the banner. And when the server says SMTP UTF-8, then you can send internationalized email addresses. And you do that by saying mail from, you write in the email address, and in the end you say SMTP UTF-8. And that's it. That's the only difference for a mail server. It's really quite easy, but don't do that because you have to support this in all the backend systems. You have to store it, you have to, you know, you have to be able to recall it, you have to be able to forward it. So before you enable this, you have to really test all your systems behind it that it really works. Okay, so getting to this. And the server can we point here? No. So in this mail from, you could also write in this, you know, the A label form with the XN dash dash, blah, blah, blah. That could be in there too, and your server would have to support this. Okay, and then we have the POP3 has a similar mechanism to do this, and so has IMAP. In both cases, if you're so all the transfer agents, everybody has accepted this, and now you're at the last stage, and you come with your client and say, okay, I want to look at my email, and then your client doesn't support internationalized email addresses. Then the server actually had the possibility to downgrade the address. And there's some RFCs to this, but it's not ideal because, you know, some information will get lost. Yes, and I see we're out of time. Yeah. Okay. So just to come to the end here, what you have to do in your organization is actually, if you look at this, then you have to see we can accept it, we can put it in we can validate addresses. For example, if you have a mailing list, it would be interesting to do this. But if you accept these addresses for your mailing list, then your mailing list will also be able to, have to send emails to these addresses. So there's more to this than just accepting, I let people write it in. That's not enough. And so there has to be some process to this that you can really support these addresses. And well, there's more support here on statistics on what works and what doesn't work. Here's some software stuff if you want to implement something yourself. And this actually tells you, because there is a difference between we accept emails and we can send emails, and our server allows us to have accounts with these addresses. So, and for example, if you look very closely, you can see that Gmail actually allows, can receive and send, but currently they don't support accounts with special characters. And yeah, and with that, I would hope that I can encourage everybody here to go home, look at your systems, and just say that you try to accept email addresses where the TLD part has more than 3 letters. All info and engineering and all the other really nice domain names. It should be really easy for your mail server to do, should be really easy to implement, and it is a really good step to getting forward with universal acceptance and making the life easier for everybody on this planet. Okay? And there's more. And that's from you. Thank you.
We have a question in the back,
okay,
which I think we have to take.
Thank you. My name is Matthijs. I'm with the University of Twente. I have one question for you. There's an aspect to this that even if mail providers or people who are in this room were to implement this, you're still, I think, dealing with the issue that some other infrastructures or apps will not allow the characters. Yeah. For example, I make ample use of pluses in email addresses to do the labeling on my side. Yeah. And I had to file bug reports with my fintech apps because they wouldn't accept my email address, basically. So there's always still this part of it. So how likely is this?
This is obviously not something that will happen overnight. I mean, that is like, let's do it one mailing list at a time. Let's do some small stuff here, let's do some small stuff there. I mean, if anybody of you is paying customer to Open Exchange and uses Dovecod, maybe you could add your name to the ticket that they implemented, would really help the internet. So, but it will take 20 years, maybe. I mean, it's like we're deploying IPv6, right? So, and all the domains are DNSSEC signed. Yes, I know. No, this is something that we will live with many, many years. But we have to start somewhere, and that's why I say the smallest start we all can do is like accept.info. Then that's a good first step.
If you are giving this presentation elsewhere, add the "I'm doing my part" from Starship Troopers as the last slide.
Yeah, yeah. But, actually, on this side, the ICANN has done all of this, and we have a case study where you can see what we have done to get to this part. And obviously, not every single application that I can use support this. I mean, that's impossible, but we try as much as we can, and that's, you know, all you can do. And I mean, I get it that businesses have other priorities, but, you know, maybe .info is not so hard to implement.
Thank you.
Good. Thank you very much.
So we have 3 questions from Olof from NLogic. Olof is a network automation ninja, according to his LinkedIn profile, working with network automation since 2020 with operators like Tele2 and Telia, and now he works as a consultant for NLogic. Prior to that, he has accumulated almost 20 years of experience as a network engineer. Olof, welcome.
Thank you. So I know it's late in the day, so I figure we should get our blood flowing a bit. And by that I mean some hand raising. So I have 3 questions for you guys. And there's no right or wrong answer, so don't be shy. So my first question is, how many of you in here knows what Netbox is? Yeah? From here, it looks about the majority, 80% or so. And I think that's expected. It's a well-known project. When I talk to clients, I hear it. They either run it, they want to run it, or they have run it. Question number 2. How many of you in here have heard of service orchestration? That's quite a lot of you too, actually. I was a bit surprised about that. But I think I know the answer, because it's usually one of those buzzwords you hear when we talk about network automation, and no one can really point at like what it is or what it does, or it's not a product, right? And then my final question is, how many of you in here have heard of service orchestration in Netbox? 1. I expected 2. But that is good news, because that tells me I'm actually bringing some new content here, or some new things to show you guys. So my name is Olof. I work as a network automation consultant for NLogic, specifically for NLogic Sweden, but I travel around across the Nordics to do network automation for different clients. And I was asked a couple of months ago by our marketing dude, and he said like, well, you should go to NONOG and do a presentation about network automation. I was like, well, that is so general, that is so broad, like I can't point at something specific. And I've done a bunch of talks about network automation, but this time I wanted to show you something more tangible, something more that you can, you know, go home and tinker with or play with. So what I'm going to talk to you today is obviously service orchestration using Netbox. But before we start, I have a couple of disclaimers. And the first one is that I am not claiming credit for this. I learned about doing this, or you know, the idea or concept of it from a podcast for some dude I forgot the name of. And the second disclaimer is Netbox itself. It is so picky when it comes to design philosophies and decisions and how to do things and whatever. I am probably breaking all of them in what I'm about to show you. So don't fight me over it, I know. And then the last disclaimer is that this is work in progress. This is a proof of concept. I'm just bringing you what can be done. So services in Netbox, but before we start, like, what is Netbox? Netbox is an inventory system, or a source of truth, right? It's where you enter all your details about your network, your devices, your interfaces, your racks, VRFs, IP addresses, prefixes, and so on. And it can be very tedious, because you have to go in there and find your device and add your interfaces, and there's a lot of data entry, right? And you have to put your MTU on this specific interface and the description and so on. So there's a lot of data entry. But Netbox itself is very useful. It's very well known, and it usually sits in the middle of any automation setup. And basically, you hook up all these scripts and Ansible and Nornir or what have you to talk to Netbox to get data out of the system. Like, what is this box? Is it a Juniper or a Cisco or what have you? So it's very common. And then what is service orchestration then? Well, if you think about it, what we as network engineers deliver to our users is usually a service, right? I don't care what kind of network you operate in, but usually it's a service that we deliver. It's a point-to-point connection between two ports, right? Or a layer 3 VPN, or a printer VLAN, or access to the Wi-Fi. But it's usually always a service. We don't, build a network just because we think it's cool to build networks. But if you think of device config, it's like all over the place. I don't care which vendor we're talking about, but it's always like, you want to build a layer 3 VPN. Oh, you have an interface, you have a VRF, you have a BGP configlet, and you have some ACLs or whatever. But they're completely dispersed and not connected. Like if you log into the router, like you have to go through all these configlets to figure out what this service consists of. And if it's an old router that's been there for 10 years, you're lucky if they use the same ID on all these places, so you can kind of connect the dots. So it becomes very tedious to work like that. Or if it's a very large PE router, for example, the config is so huge, it takes so much time just to find the different pieces. But a network service, on the other hand, that's the way we can connect these small configlets together and get an overview of this layer 3 VPN consists of these 3 configlets, for example. And it doesn't scale either because your layer 3 VPN is obviously not just on one PE router, it's probably on hundreds of routers if you have a large customer. So it becomes super tedious. So why do we want to do service orchestration, and why do we want to do it in Netbox specifically? Because if we look at it from a service perspective, we get a whole overview, what the service is, what it should look like, how do we can go through the whole life cycle management of it, right? We have to provision it, we have to generate the config, but then once it's out there in the wild, we're probably going to have to troubleshoot it. And that's where we have to find all these configlets and figure out how it works. But if we have the service as one piece, we can start is this service in sync? And then we can check it that these 3 configlets are in sync or whatever. We can do self-tests all of a sudden, right? Is this service actually functioning as it should be? And since it has all the details of what the service is, it knows how to perform the self-test. So if it has a BGP session, it knows how to check that the BGP session is up or down, or how many prefixes we get, and so on. If there's an interface, we can check for error counters and flap statistics and whatever. So we get this whole, service context to work with. And also at the end of the life cycle, we want to decommission it. So we know exactly which part of the network on the device we can delete or should delete. So we don't leave a bunch of configuration out there. So that's the why. Now, how do we do this in Netbox? Because if you see Netbox, it's fairly good-looking software, right? It has a nice GUI, and when I look at it, it's like, I am not a front-end developer. That looks scary. I don't want to touch it. I don't want to deal with it, and that's why I shy away from it. But Netbox has this system of plugins, and plugins is basically you extend the functionality of Netbox with whatever you want. And a good public example is DNS plugin. So you can install that. It's a small piece of software, and you can modify and change and add DNS zones and records, etc. So that's a plugin. So the plan here is to make a network service plugin. And you can make a plugin for layer 3 VPN or layer 2 VPN, a backbone link, anything that you can come up with that can become a service. And a plugin consists of 3 things, and this is the cool part. The first part is the model. That basically describes like the input and the stuff you need to store in the database, in the Netbox database. So if you're doing a backbone link, for example, you probably have a A device and a B device. That's your input, right? Or an A interface and a B interface. So that's your input. So it takes a bit of time to write that model, but it's not too bad. And from this model, Netbox does everything for you. It generates all the forms, all the tables, all the edit views, the delete views, and connect the dots inside Netbox. So if you bind it to an IP prefix, you can't delete the prefix because it complains that your service is using it, and so on. And all this happens for free. So you just have to write your model, and that's basic Python classes. So fairly simple. The second part of a plugin is templates, because you usually want to generate configuration. And you can either use the Netbox template rendering thingy, or you can just use Jinja 2. And if you're already doing some network automation and have Ansible scripts running and generating config, you can take those templates and put in your plugin, and then you're good to go. You just have to tell it to pull data from Netbox instead. And then the third part of a plugin is your business logic, and this is usually where you spend your time, right? How do we do it in this organization? Like how do I figure out what an MTU should look like, or how big an MTU should be? Oh, I have a Juniper on this side and a Arista on this side, and we're doing a layer 2 VPN. They like kind of calculate, MTUs differently. That's type of business logic. Or, what should the backbone link description look like? Like, should it be the remote interface first, or the circuit ID second, or do we use semicolon, all that stuff? That's business logic. And that's usually where you spend your time. And that's basic Python. So you don't need to be, where it's not hard to find people that knows this. And at this point of the presentation, you are probably wondering, what is this guy on about? Like, I have no idea what this dude is talking about. So what to do? Like, let's do a demo so I can show you something real that you can, touch and feel. But there's two problems here. I don't like failing live. And just before I went to Oslo, they told me that the AV system might crash if I hook up a Mac to this whole shenanigan. It's like, okay, that's not good. So I can't do a live demo. If you want to see it live, I have it on my laptop, and I'm happy to show you afterwards. But I'm going to show you some screenshots instead. And the idea here is that I wrote a little backbone link service. So imagine we're being a little ISP, and we have a bunch of sites across the nation or Europe or whatever, and we want to connect these with backbone links. And I am working as an operator, but I don't want to know all the details of a backbone link. I don't want to know what MTU I should put on there. I don't want to know how a description should look like. That's useless information to me, right? So we need to abstract away all of that information from the user. That's the main goal here. So when I say service orchestration in this presentation, you can kind of change it to service abstraction or just services. Keep that in mind. So this is what Netbox looks like, basically, an empty one. But you can see here on the left side, there's something new. There's a little plugin menu, and you can see that we added backbone links. And that's because it loaded my backbone links plugin. And you can also see a list of backbone links, and it's obviously empty. So I work as an operator for this company, and I get a ServiceNow ticket saying, hey, you need to create a backbone link between this router and this router. Okay, cool. So I click on the add button, and this is what I see. So I enter my circuit ID, device A, device B, and pick the interfaces. It's all generated from the data in Netbox. And this is pretty much all I should care about if I'm an operator. I shouldn't care about any other detail than this, right? You can probably dumb out the circuit ID as well and generate that on the fly if you want to. And you can see there's two fields for the prefix to use or the subnet to use. But I leave those empty and let the plugin allocate them automatically. And what you see here is basically a visual representation of the model I was talking about. So I write this model, this is what I want you to ask for the user and save to the database, and this is what I get. It looks and feels exactly like Netbox. So if I click Add, you get a view over the service. So now all of a sudden, I've created my backbone link, and I get all the details that I need about my service. So you can see that it allocated some /31s and /64s to use on the link. You see some details about the links, and at the bottom left here, you see what appears to be a Juniper interface configuration. I don't care if it's correct configuration, it's a template, don't worry about it. But I, as an operator, I didn't even know it was a Juniper, right? And I don't care. It just happened to be a Juniper, and that's the point here. We were trying to abstract away as much details and knowledge away from the user. But the plugin knew it was a Juniper device because Netbox data says so. So it generated the backbone link for us. And it created a description and put the right MTU for my organization and put the IP address on there and so on. And if we scroll down, we see device B configuration. It looks completely different. Now, this could be hard to tell. I can't really say if that's a Cisco or a Arista configuration, but I know, in this case, I know it's an Arista. But here again, the end user really don't care about the details. They just want these two interfaces, right? And all of this configuration is just a Genia 2 template that pulls data directly from the Netbox database. And it doesn't do an API call. It just uses a simple database query. So it is super fast. No talking between servers, nothing. And when I added this service, what it also did was to save all this information and data about the service in the Netbox database models. So you can see here's a list of the interfaces. And you can see that it actually added the MTU in the description to the interface model. And obviously, a backbone link is a pretty stupid and simple service, right? But imagine this being a layer 3 VPN or a layer 2 VPN, where you have lots of different data. It all gets stored in Netbox. And it also creates the IP prefixes in the IPAM module of Netbox and creates the IP addresses. It does that all for you. It's fully documented. So now if you have other system relying on Netbox, it's all there. You can query a regular Netbox device and so on. And so now we have our little backbone link service, but it's obviously not out on the network. It just lives in Netbox. So we need to push it out. So the next step for our little imaginary operator is to push it. So we can see on the right side here, we have service action. And again, this is mostly generated by Netbox, but you can add and remove these buttons. In this case, I just added 3 for demo purposes. The next steps would obviously be to push it to a device. So if you click push, you get one of these lines in the action history. And you can see that it says Jenkins and semaphore on the different actions. So in my case, I have a Jenkins pipeline that runs when I want to push data to the network. And the benefit of that is that you can reuse your pipelines if you already have them, and you can run all these tests before actually pushing them to the network. So you can run your Batfish and SuseQ and PyTest, whatever test you have already, you can run that in that before actually pushing it to the device. And if it fails, it doesn't push it, obviously. So that's step number 1 for our little operator here. Step 2, so we're going to go through the whole life cycle management of this service. Step 2 is probably someone calling you after a year and say, hey, there's an issue with this backbone link here. Well, okay, I can quickly find it in Netbox now. I don't need to sort through the devices and interfaces and prefixes. I can just quickly find my service here. And I can, for example, in my case here, check that the device is in sync. And I don't care about the full device config. I care about my service. And in this case, it's obviously just 2 config lists for the interfaces. But I can check that these are actually in sync with what the device is. And I mean, if you think about it from 3 VPN or more complicated services, there's lots of configurates that should be in sync. So this is not easy to do manually. So this operator checks sync, and it wasn't in sync, so he can re-push it or redeploy it or whatever you want, but he fixes the problem. Another typical use case or another button that should be here is a self-test. So you can actually ask, hey, Backbone Link, please test yourself. Please make sure you're functioning. So you can write a script that logs into each side, check the light levels, packet error counters, and so on. And it can ping the other side, but not by pinging the IP address that it found on the device. It should ping the IP address that was allocated to begin with. Because what you have in Netbox is the intent. That's what it should be, right? If you want to change the IP address, you need to go in here and click edit and change the IP address, but not the other way around. So it's a fully service-aware self-test. All right, but our operator now, he fixed his issue by just syncing the configuration. Someone messed up there. And the next step in the life cycle of our service is probably, decommissioning. So he clicks the undeploy button, which he did, right? And that kicks off a semaphore job, when actually the check sync was a semaphore job. And semaphore is just a web GUI or a web API for Ansible playbooks. So he clicked undeploy, and semaphore ran this playbook. It removed the configuration, and our service is now undeployed. It obviously exists here. So what he needs to do is obviously delete it. But before he deletes it, imagine you're troubleshooting this service. You can actually get a lot of information from this page already, right? You can get all the action history here. If someone calls you up and say, hey, this is broken, like you can quickly find it here and see that the last action was undeploy. It's like, oh, well, that's probably the issue here, right? And there's also a tab up there that says changelog. And if you click on that, you get every change to this service, from its creation to every edit, every change to the delete. So you get a full changelog. And this is not a lot of code. You get this for free by just plugging this system into the Netbox web framework. So it looks like I've been working hard at this, but this is actually mostly auto-generated, which is the cool part about this. And if you click delete, it obviously deletes it from the Netbox device. And I can hear the questions now. It's like, well, what if someone goes into Netbox and changes the interface description without going through the service? Yeah, don't do that. That's going to break this. That's not cool. So you have to redeploy your service to fix that, or tell your users not to. But the plugins actually work on permission levels, because you can set up users and permissions. So you can force, like, users can't touch anything in Netbox or a certain level, but they can change some plugins. So there are some remedies there. But you can prevent it. You can't, for example, delete the prefix here. Then it would say, hey, this service is using this prefix. You can change it, but you can't delete it. So what's next? Like, how do we take this even further? Because I think this is pretty cool. Like, I have clients that don't want this, infrastructure as code and Git and create branches and all of this stuff, right? Not everyone is on that page. They want something pointy and clicky and what have you. So I think this is a pretty cool idea, and I think we can take it even further. And one cool feature of Netbox that is coming out, or is actually out now, but it's in beta, I guess, is branching. So instead of you modifying, the master data of Netbox, you can actually create a branch of Netbox in the web GUI, just like Git. So you can just take it, and let's say I have a job in a week and I want to pre-stage some stuff. You can create a branch, populate it, create services, and then just merge it in once your job is coming up. And this, they say it should work for plugins as well, but it is a bit buggy at the moment. And if you want to do even cooler stuff, you can actually use stacked services. And this is a concept from NSO, right? Cisco NSO, where you can build this modular plugin. So you can imagine a BGP session, right? You have a service that configures BGP sessions, but you probably have a lot of other services configuring BGP too, right? You might have a transit service. So instead of the transit service configuring a BGP session and have templates and do all this, DevOps test and everything, instead, that transit service configures a BGP service. So it becomes a stack, right? And then later on, you have a peering plugin. Well, that also just configures a BGP plugin and so on. And maybe your layer 3 VPN service, it doesn't configure a BGP session. It configures a BGP service. And that's pretty much what I had to show you today. Now, I know this wasn't a live demo, but I have it. I'm happy to show it to you guys. And this is basically me giving you ideas and a concept of what can be done. This is actually pretty easy to do. I would love to hear your feedback. So, please come and see me after or tonight or whatever. I would love to hear your feedback about it.
Any questions from the room? I have a question, actually. You had the check sync button there.
Yep.
What does that do?
It checks if the config.lets is in sync on the device. So if someone removed the description, it will say, hey, there's a missing description from what's the intent in Netbox.
Exactly. So if somebody goes and changes directly into the network element, you would have a chance to check it. And if you want to redeploy, it just overwrites.
Yeah.
But if there are additional commands which have been added there but not part of your template, those will be...
Yeah, you kind of want to reconcile the changes into Netbox. Yeah. That's another button.
Yeah. All right. If there are no... Yeah, there is a question here.
So this is mostly about resource allocation in a sense. So how are these resources connected to the circuit ID?
The circuit ID in my case was just bogus data. Nothing.
But you have to have something that ties all the resources together and see all these resources. Is this service like VLAN IDs, IP addresses, interfaces?
Yeah. So I guess there's two parts of your question there. So the circuit ID, that could be the vendor circuit ID or whatever, but it's something unique that it identifies your service. And then on top of that, you can have your service allocating IDs like VLAN IDs or route targets or IP addresses or whatever. And it's just tied to this top level service ID.
Or to ask it differently, if I get an IP address from a customer, like something is wrong with this IP address, how can I backtrack that to the service?
Oh, there was a drop down at the beginning, so you could choose to manually enter an IP address as well, but you have to enter it in Netbox.
No, but to identify the service based on the IP address.
You can search for it.
Search for?
Yeah. Okay, I'm not sure I understand the question.
In the database between the IP address and the service.
I have a resource.
If you click on the IP address, do you find out which service is using it?
Oh, okay. Well, I think Netbox does that for you. It's the data is connected in a data a relationship, so you can actually find it backwards as well.
Okay. Then I think we should proceed to our next presentation. Thank you very much, Olof. Very interesting. Our next presentation is online. You can prepare. I guess David will miss his introduction, but we will have David Bianchi from Cisco, who will present about routed optical networking. Prøv den der. Du har også den der. Yes. Yes. So while we get, nej, det är online. Det är video. Vi kan avsluta det. Där är Hello, David. Can you hear us? We can hear you, but I'm not sure how well. Can you please do some sound test? Yes, I'm just trying to take it to the max. Can you retry? We can see the slides. We can see the slides here. You didn't need. Yes. So you could just share. All right. Let me introduce you. David Bianchi. He's a product sales specialist manager at Cisco. He has 30+ years of experience in telecommunication industry, 20+ years of experience in telecom marketing. He has 11 patents issued to his name. He has worked for the main telecom manufacturers in engineering roles on SDH and DVDM equipment design. He moved to product marketing position in early 99, working with major carriers to promote, plan, and develop the optical transport product of lines of Pirelli first and then the Cisco Photonics later. He's an early contributor to the ROA ADM management technology and the IP over DVDM technology. David, you're live. Sorry. We don't hear you now anymore.
Can you hear me now?
Yes.
Okay,
2024.
I don't know what did happen. So let me go. I'm presenting not optical networking and architecture to simplify the networking today. So we have everything ready. Time is now. I've already been introduced before, so let me go ahead. So routed optical networking is an architecture which is essentially looking at sustainability, efficiency, simplification, and multi-layer automation. This is available now because the optics technology evolved, the silicon technology evolved for routing, switching, and DSPs. The software also evolved into more basically automation. And the way to simplify the layering of the network brought Cisco basically to invent the routed optical networking. So the idea about the routed optical networking is to simplify the network layering. If you look at the present mode of operations, today's network, where there are 3 layers typically, DWDM, layer 0, which is always there, which is own control plane and management plane. Sometime layer 1 in the middle with layer 1 switching or TS switching. In the past, SDH switching, its own control plane, its own management plane. And then the packet, so the IP-based control plane and management plane. The idea is to simplify and to go to more routed optical networking where there is knowledge in the router for the optical network and knowledge in the optical network for the routing, and remove what it is not necessary in such a way to simplify the network operation and to essentially go into operational savings a lot. In effect, why now? Why now? Because if you look at what is the present mode of operation and what you can typically do by adopting the current layered architecture, you have, in the majority of the cases, routing and switching. The bit rate is going up and up, 100 gigabit and above, typically. Then you have gray optics, so that goes and connects to a transponder or a maxponder. Then you have this transponder or maxponder in the chassis, and then this goes and connects to a DWDM network, to a RODEM or to a filter with amplifier. Think if you can remove everything here in the middle, so simplify and put your transponder in a router directly in a form factor which is now general, not dedicated form factor, like a QSFP-DD form factor. So this is available today thanks to the ZR Plus technology, Open ZR Plus technology. And that basically brings in simplification and savings. Savings in CapEx, because of course there are less hardware to be brought into the network, but a lot of savings more in the OpEx, because there is a lot of power savings. There is a lot of real estate savings, so sides of the equipment, because you remove chassis, you remove cards, you remove many things. There is power saving because of course you have less hardware that consume power. And higher availability because there are less active components into the network, so higher availability, higher MTBF. This is great thanks to a lot of things. So first of all, now there are open standards for doing that. OIF, Open RODEM, Open ZR Plus, this is basically open standards in there. There are pluggable coherent optics with high capability. 400 gigabit today, but 800 gigabit is coming shortly and above there. Scalable silicon, so that the capability of routing for the big router now is overwhelming, basically, and overcoming much beyond what it is necessary in the network today. It was not the case 10 years ago, 15 years ago, of course. And unified automation, because now you can really automate all this process. And for us, for Cisco at least, this means to have capability in this market. So we have coherent optics available, and by coherent optics means to have optics with standard form factor that can be hosted in a standard QSFP-DD, typically port in a router or switch, with DSP on board. So with all the coherent electronics on board, in effect is a transponder in a QSFP-DD form factor. We have that with various capability and various pricing, of course. I'm mentioning here this 400 gigabit ZR Plus Bright. Bright is the code name for the original project where we basically brought into the market this object here, because it is our flagship seller of the moment. We shipped a lot of them. We also have on a CMATE form factor, so bigger form factor, a 1.2 terabit coherent optics. That's clearly for a different type of application. The interesting thing about the 400 gigabit is that there are free standards. So not even one, there are free standards. And we adhere to all of them. We have basically a portfolio for basically all the free. So this is our basically capability to offer something standard and not something which is just Cisco proprietary. I was mentioning this basically Bright or DD 400 gigabit ZR Plus flagship seller, so the top portfolio seller for us. So this is a QSFP-DD pluggable optics with the DSP on board. So all the circuitry electronics is on board in there. The interesting thing with respect to the previous generation, it has a +1 dBn transmission power. What does it mean, +1 dBn transmission power? It means many things. So first of all, you can adapt it to any add and drop structure of a DWDM layer which is in the network today. So even existing open line system or even existing DWDM system from any third party that had a problem with ingress power and needs some high ingress power, this can be adapted basically with this object here. So you don't really need any transponder. This is a real transponder replacement in the market for 100 gigabit. Second thing, it is +1 dBn transmission power, but there is also a great receiving sensitivity on the ingress, meaning that even if you go over dark fiber, you can go long distance as well. Third thing is basically as an embedded tunable filter, so you can really adapt to whatever basically DWDM you have in there, even if you really need to adapt a little bit the signal frame as well. There are two different versions of this. One is Ethernet only, which is for routing and switching. There is also a multi-rate Ethernet OTN for using for Open ROADM, because Open ROADM is a different standard. We sold and shipped tons of this object here in the market, thanks to the flexibility basically to be added more or less everywhere. Is that Cisco only? No, that is an industry adoption. It's a matter of fact. So this I'm presenting Signal AI basically there, and that's where basically they captured this adoption. This is until basically this year, but of course also the forecast for the next year is to this shift between the transponder technology and coherent optics technology. So nowadays, the vast majority of the deployed coherent connection is through digital coherent optics, no longer through transponder with fixed connector. Of course, some of those go directly to the transponder because even the transponder today are using digital coherent optics as trunk optics or network optics. So they no longer have fixed port or dedicated or proprietary coherent optics as a network port. They use standard, because a PDD form factor. So this is an industrial revolution that is happening today, and basically also the analyst reported this. This is in line with the standard, essentially. You can consider others, right? So if you consider Omdia, you consider basically also ACG, they also are capturing this shift in the network architecture where this, first of all, open optical network. So you need to be able to run this as an open line terminal that goes in any DWDM network there, and adopting basically OpenZR Plus typically as open standard for this technology. ACG Research published the first a report a long time ago about the benefit of the routed optical networking. They just issued a new one with standard updated, let me say, results, and they basically discuss about how this is benefiting in terms of CapEx and OpEx savings in the network. Now again, is Cisco proprietary? This technology is not. So first of all, I would like to just mention you what is happening now at the ECOC 2024 these days, basically. Last week, actually, there was the pre-meeting that this interoperability demo at 400 gigabit ZR, ZR Plus, and even 800 ZR coherent optics. And these are all the companies that participated into this interoperability testing across basically multiple vendors. So as you can see, you can recognize there is Cisco there, but there is a lot of other people that are participating into this. So it's not Cisco proprietary. It's just the fact the industry is adopting this technology and everybody is jumping into the same technology. And this is the other interesting thing, they interop. You can really have interoperability between 400 gigabits that are plus coherent optics coming from two different vendors. This is the first time in the industry this happened. So this is another revolution that is happening in the industry. So just to mention what does it mean OPEX savings and CAPEX savings. This is a very simple example I'm doing using our technologies, our transponder, right? Here in this exercise, the router itself doesn't count because it's always there. The DWDM itself doesn't count because it's always there, it's invariant. But consider to have something which is a typical compact transponder. We have multiple options for this. I'm just selected one. And the transponder inside has using exactly the same technology. It's using coherent optics as a trunk optics. Then you need a couple of gray optics to connect to the router, okay? One in the transponder and one in the router itself. Okay. Consider an example, for example, 8 by 400 gigabit Ethernet, right there. So I'm removing the transponder shelf. I'm removing the cards. I'm removing the gray optics. Okay. So there is CAPEX saving in this, of course, because I'm removing guards, so there is something less to purchase or to buy, right? But apart from that, because CAPEX depends on pricing, depends on discount, it's commercial discussion, so sometimes useless to go in there. It's more, the power savings here. Simple calculation, about almost 85% power savings in this simple scenario, right? 2 rack units less to be used. And of course, a lot of active component less, which means higher NTBF. So higher availability, basically, of the network itself. So that's, of course, let me say, is an extreme simple scenario, right? But in any network we faced, we observed OPEX savings in this respect. It's easy, basically, to calculate. Okay. And of course, the underlying transport can be obviously a mesh network based on the mesh and complex DWDM with ROADM, multi-degree that works. And we have deployed this. So here and there, basically, in a lot of space. Automation can be deployed quite easy now, also basically easy for that. And of course, deployment can also be in where DWDM is Cisco, but also where DWDM is non-Cisco, is from another, let me say, manufacturer or vendor. Same thing, it's also typically more in distribution rings or access rings, etc. You can use filters. So inexpensive, let me say, DWDM, where you can place simple and cheaper amplifier in there. And by the way, we also released an amplifier on QDD for a factor, where we have a user port there. So it's really basically very small for factor and pretty cheap as well in there. So this is typical for metro access rings or distribution rings. This is another basically possibility we already basically deployed as well. So all in all, talking about numbers, so we have a lot of customer engagement, network modeled, proof of concept, etc. So field trials and so forth, right? This is why, because again, this technology can be deployed over dark fiber, and there is a lot of deployment in access space, in data center interconnect, so dark fiber or passive DWDM deployment, a lot of them, over Cisco DWDM or open line system, over non-Cisco, so third party open line system, so more or less everywhere. Some public name here for deployment and for testing. So I'm not basically commenting all of them, just basically presenting where we are with that. These are the public, right? Because as you could see in the previous slide, the real deployment are at least 10 times, right? So of course, not all of them are public. You may recognize some of these numbers. I can just comment a few of them. One is CPARTEC, where we did 1,337 kilometer, 400 gigabit error-free with OpenZR Plus standard. This is still a world record for this kind of technology. And I can also mention another one, which is SNAM, which is a gas carrier. So it's not a service provider, it's basically industry in there, which adopted this technology to simplify the networking. So they had the previous networking layered with DWDM, with IP, with basically all the things. When we proposed them to renew the network and to transform the network and build this based on the route optical networking, they adopted exactly for the simplification. They don't have a big operation team, and they realized immediately that this would be, for them was basically must to do and they must do. This is just Colt basically made all of their number public in a webinar. So they basically presented this is their way to the net zero, basically to be and to go to basically zero neutrality, so to spend less, essentially, less and less and less in power. So reduction in power consumption, meaning, of course, a reduction in carbon emission. And for them, this is basically a must have. Of course, 400 gigabit is not the end of the story. 800 gigabit is coming, and then there is also something else coming. 800 gigabit is coming very shortly. There is another technology which is quite interesting coming very shortly, which is what we call the 400 gigabit ultra long haul, which would allow, instead of deploy, as it is today, the 400 gigabit ZR Plus over connection that are deployable typically over 700, 800, 900 kilometers today on production network. This 400 gigabit ultra long haul is meant to go over 2,000, beyond the 2,000 kilometers. So this allows the complete, let me say, replacement essentially of transponders in this kind of network. So it's interesting, the 800 gigabit because it's bringing a lot of value, for example, in data center interconnect, but also interested the 400 gigabit long haul because it's extending the value and the scope of this technology. In effect, as a matter of fact, the 400 gigabit long haul is more or less bringing the use case coverage of the 400 gigabit digital coherent optics to more than 90% of the cases scenario. Clearly, we are talking about a larger baud rate. So the 400 gigabit OpenZR Plus is in the range of the 60 gigabit per second, while the 400 gigabit ultra long haul, let me get back a little bit, is typically around basically from 96 to 120 basically or more gigabit per second. And this would allow basically a much better OSNR sensitivity. So in essence, so what makes ROM possible, route optical networking possible? First of all, is better silicon presence in the routing, because that allow for larger density of high-speed ports in the router there, and of course the digital coherent optics that is exploding in the market. With that, the glue is also the automation. So more automation in there that glue together the two word and the two layer. So automation also means somehow standards, because there is nothing essentially proprietary. You need to have domain controllers in the automation, typically an IP controller, typically an optical controller, and there are standard interface in there. Orchestration can be basically provided by the vendor, can be provided by automation company, can be provided by or built by the users itself there. But this is all more or less trending to standard. Typically, transport API for optical networking, instead OpenYang and OpenConfig for the rest. With that, we have, of course, this offer and this capability through the cross-hierarchical controller to orchestrate both the world. But again, so this can be provided by ourselves or by someone else. And the interesting thing is that the troubleshooting is also basically easy because everything which is available through the command line interface, consider that a digital coherent optics typically go in a router, and the router is operated by people via command line interface. Of course, there are GUI for doing this, but a lot of people still using command line interface, especially OSXR operating system. Everything which is available there is also available via streaming telemetry, and dashboard can be built basically to capture what is of interest in there. This is another interesting thing in terms of automation, because you can capture whatever you want, whatever you think is better for you. And of course, we can suggest what it is more relevant to monitor, but we see some user is more interested in something and some other more interested in something else. So that's also basically pretty interesting, because you can build your own dashboard for that. So closing this, essentially, the routed optical networking adoption journey on a customer side is to, first of all, to convert the layers. So integrated the transponders function with the digital coherent optics. This means essentially to start adding new services over DCO instead of over existing transponder technology. So you have transponders, leave them they are, but every new service, typically IP services, Ethernet service, whatever coming from router, go and use digital coherent optics and go directly basically to the router with that one. With that, you can also place a hierarchical controller if you want, or you can basically operate by yourself. The second thing is start basically putting also IP controller in there, and then decommission the layer one. Consider that even if you have legacy traffic in there, which is probably not your case, but if you have it, there are now ways to replace or to actually adapt the legacy traffic to the IP world. You can transport SDH over IP, that's easy, right? Everybody can do it. But you can now transport OT2 over IP, you can transport OT4 over IP, so there are a lot of things that you can basically transport there. You can basically decommission the layer one transport in there. So all in all, basically going in there. The control plane then for the service is going to be segmented. And that basically it for my presentation.
Thank you very much, David. Do we have any questions from the audience about RON, routed optical networking? David, thank you very much. You will be hearing from us if there are questions coming afterwards. Thank you for taking the time. And yeah.
Thank you. Thank you all for your attention.
Thank you. Yes, I can see you. Some of you are ready to end the day. Myself as well. We have our last presentation, and then the quiz is just 15 minutes. We have Bjornar Simonsen from ISOC and Orange Business, who's going to talk about the NIS2 directive. Just give me a moment here to set him. So yes, I think Björnar has a slide for himself.
Hello, everyone. So I will talk a little bit about NIS2 and a little bit about DORA. You probably heard about this new regulation that's coming. Short about me, I'm Bjørnar Simonsen from Oslo. I'm almost 50 years old, so that means I've been in this business for soon 30 years, and I've seen a lot of things. I work as a security compliance manager. I come from a technical background, so I used to configure firewalls. Then I got interested in security more and more, and then I gradually slided over into compliance. So now I'm not doing anything technical anymore. That's weird. So where I work in Orange is a place where we manage mission critical and critical solutions for the society. So yeah, and my hobbies are my work, so there you go. It's kind of like that. But what is it all about? I had to Google security because over the years I kind of lost track of what the whole picture. It's important to remember the whole picture when we talk about security. So for many years I've been really specific about, let's say, ISO standards, PCI, DSS, SOC 2 reports, and other things. And it's easy to forget why are we doing all these frameworks and standards anyway. So yeah, the definition of security is the quality or state of something being secure. Let's say freedom from fear or anxiety. My favorite, freedom from the prospect of being laid off. With all the security things going on, if you work with security nowadays, you're kind of guaranteed to have a job somewhere, right? But most importantly, the thing about protection, to guard against certain things or to protect something against something. So in short words, you're going to end up with a security framework anyway, because you have a set of values, you want to protect them, you have to do something. Otherwise, it's not going to end well. So even small organizations, 1 or 2 people, start to realize that, oh, we need to document how we do security. If we're going to have clients, how will they trust us, So there are a lot of frameworks out there. You've probably seen the jungle of different frameworks. You have the CIS controls, you have the common criteria, you have NIST 800. There's so many different standards. And it tends to be each sector, depending on your work in finance or health, they come up with their own standards. But my message today will be a couple of things. But one of them is that most standards contain basically the same things. So if you make your own standard, it should be compatible with something that other people can speak. It's sort of like with languages. If you have a very specific language that only a few people talk, you need to translate it into English or Mandarin or something that other people can understand as well. So if you have some sort of security, you have some processes and policies, make sure you make a mapping to, let's say, ISO 27001 is probably the gold standard when it comes to security and being able to explain your security. Of course, that is what most companies, big companies, go for, 27001, most known. You can also use CIS controls, and let's say CIS controls are very nice because they don't tell you in broad terms what to do, but are very specific and can be very technical. And they're also listed in priority. So requirement 1 will be more important than requirement 2, etc. And if you remember your CIS controls, the number 1 thing is to have inventory assets and your data. And you can also come very far with the NSM grunnprinsipper. And NSM is, the National Security Agency of Norway. They published a set of principles. If you do this, you will be more secure. Whenever NSM gives a lecture, they always talk about, the common things we see are the, common easy things to fix. Someone didn't set their password right or didn't use multi-factor authentication and didn't patch the server. So again, that can be as simple, if you don't have a lot of standardizations yet, the NSM Grunnprinsipper, at least in Norway, can be a good place to start. And on their webpage, they have an Excel document with all the mappings to ISO 27001, so you can translate it to other people from other countries. Common criteria, if you do SOC 2 reports. Well, when it comes to NIST 2, what I'm trying to say is that if you have all of these things, the foundation security, you probably are already a lot of compliant with NIST 2. You probably have about 80–90% already. So that's the good news. The bad news is that you need to be better to be compliant with NIST 2 with the business continuity. So you need to document your processes surrounding business continuity more. So that means at least once a year a tabletop exercise might not be enough. You need to have show more of what is the risks and how are we trying to solve those risks. Not only that, but supply chain is very important. You know, if you buy a pager, a beeper, you want to know that nothing bad happened. You know, someone put something in there. So same with everything. Well, if you buy it, you need to be sure that nobody messed it up. So and these things can be really overwhelming. Here's DORA, all the requirements I found out. It's 64 requirements, right? So it can be very overwhelming. So it becomes like a security bingo. What do we have? What don't we have? So actually, a year ago, I did this for Orange. I sat down and looked at each requirement, Article 1, Article 2. And I did a kind of a, how well are we doing? Or how bad is it? So this is us a year ago. Now it looks better, but that's how I started. And I ended up with, and you can do this too. You just put the requirements and generally what they mean and do a kind of assessment. How do you feel you align to these things? Then you end up with a sort of like a security bingo, where the green ones, we got that covered good enough that we can explain what we're doing. The yellow one, we have some more explaining to do, but we can probably explain it away. And then the numbers that are red is sort of like, okay, we're going to book meetings and fix them. So it's kind of like that. That's true for any standards. Here's some text. Might not want to read everything, but the most important one is that now with NIST 2, you're going to have like a military-style operation going. It's going to be 24 hours you need to do something. And also immediately upon, let's say, a security incident, and also near misses. If something didn't happen, but it almost happened, you need to register that. So my advice for NIST 2 is to log everything, make sure you have your processes, build on your existing processes. I showed DORA, like 64 boxes. NIST 2 is much simpler, only 3 articles are relevant. Well, that's not entirely true. But because the 3 articles, they contain a lot of subtopics. So the subtopics are, from Article 20, 3 things, and then from Article 21, the rest of the things. Article 23 is so special to NIST 2 that it has to do with reporting, so you have to look into that specifically. It's going to be a red one for everyone. So how did I get out of this one? I read the NIST 2, and I mapped it to ISO 27001. And that helped me a lot. Because then, I had my NIST 2 requirement, I have a NIST 2 article. Then, what does 27001 say? And I found out, hey, we have all of these things. We just need to tweak them a little bit. You got your training and awareness, and you got your risk assessment, everything. So you might want to update your incident management to include that now you have to report within 24 hours to your stakeholders. You have to register things much more tight. But we could build on the existing things. So those are like 3 slides. You can probably get this slide anyway. And that's how you do NIST 2. Define a security framework, implement it if you don't have it already. If you have it, great. Do kind of a gap analysis, map them to a known framework, for instance, 27001. And then let your existing processes and framework cover most of the work. Bonus tip at the very end, Google Continuous Compliance. I can't say what tool is the best, but you can find out by Googling. Evaluate at least 3 different tools and find out which one is the best for you. Because you need to automate this. If you're going to handle all the standards that are coming, and you probably have a few standards from before, you kind of need to automate it. So a tool like that should be able to have all your policies, map them to different frameworks. All the controls that are contained in that framework needs to be mapped, so that once you change one control, it updates for all the standards. That's kind of the tool you want. And those tools are available online. Yeah. So that's it from me, how you do NIS2, in a nutshell.
Thank you, Bjørnar. Any questions to Bjørnar? No, I guess people are eager to wrap the day. It's been a long day. Thank you very much, Bjørnar.
Thank you, everyone.
Yes. So, we have only one last thing before our dinner and the mingling. Some of the NICS people are already there, by the way, so there is a place. Let me just close this thing. Before jumping into the quiz, I'd like to remind you of the survey. You have it on the back of your card. Just fill in there what you liked, what you didn't like, and we'll try to take that into account for next time. After the quiz, the winners are supposed to come back to pick their prizes, and everybody else, including the winners, is invited to the venue where we'll eat. The Wild Rover is next to the train station. I just wanted to let you know about that. We will, I'm not sure exactly how to say in English, we will be doing for the first time, we'll see how it goes, bongs for drinks. So it's basically you get 2 tickets for 2 drinks from Kjetil, who is there. And to identify you, he asks me, so you wear your badge or have your badge when you get there. So don't drop your badge on the way there. Besides that, I think we're ready to do the quiz. Basically, it's already open, so you can just go now.
I was asked to make a quiz to make sure you all had paid attention. So this is going to be really tough on you guys. It's so this is the. No. So this is how you, Lars is knowing, he can tell everyone how you do this. You just add yourself. And just to show you, if you can see Eirik behind there, who hates the attention I'm giving him now. He's wearing one of these T-shirts you can win. They're very exclusive. This is the first year we have. It's 100% cotton, and the color is called silver, even though it maybe looks a bit beige. So after, if you win that or some other things, you can, if you don't want a T-shirt. We only have a medium and up to quite extra large. We don't have small because I've been to NONOG meetings before. All right, I think we're going to start. If I can find Mama. Is everyone desperate to join who are not joined yet? All right, so this is the first question. Do you all understand what to do? And you can see there's a timer going on, and it's quite fast. Great. So this is the correct answer, obviously. If you are doing very badly on this, it's also good, because then you can watch the stream that we have been recording all day. You can watch everything again. So that's also a prize for you. How many keep distance stickers have been used today? If you know, everyone has these stickers on there. You can choose lots of stickers. The keep distance sticker was the least interesting one for people. And their answer is, yay, so. All right, next question. What is not a tapir? Is it not a DNS security service? Is it not a mammal? Or is it not a painting technique inspired by Japanese paper art? 2, 1, now it looks. And reveal answer, it is not a painting technique. It is a very silly animal. All right, what is critical? And this has more than one answer. This is from the talk of Olav Lysne. This is possibly the most serious question. All right. I'm not sure how the points are being divided when there are more than one answer, but there are 3 answers. And this was how we like, what does this mean? What does this mean? I spent a lot of time on this, so this you should have a... Okay, so Fiberworks. What did he write on LinkedIn to describe his feelings for his presentation? Was it outside my comfort zone, but challenges are healthy? Or was he excited and looking forward to share his knowledge? Or was this just another normal Tuesday, lol? Just kidding. And believe it or not, I've taken away the most silly questions. So this is the more serious questions. This is outside his comfort zone, but he was taking the challenge. Next question. What is the Nix peak? As you can see from the seriousness of this question, I was not the one who made this question. I see several people are... It's very fun. I can see what you're answering here, but you can't. So this is, yes, all right. Most people had this correct. Are you excited yet? You want to see how, soon we're going to see how people are doing here. At the NONOG Slack channel, for people who don't know what that is, it's an... What can you find there? Someone have given up, I see, on answering correct. All right, it's not weather forecast, even though maybe we should start doing it. The leaderboard looks like this. And we're going to continue, but it's a bit more questions. 2 have got 7 correct. All right. How can you get accurate time in your network? There could be several answers correct here. I'm very glad that people are choosing use Anarka's standby TV clock, but it's not correct. All right. I'm going very fast here, so maybe we should take a... next question. Where can you connect to Nix? I also did not make this question. Svalbard, I'm sorry, it's not... it's Brix, Bulk, Stack, UEO, and NetNode. I was told. So the more important things, where is the dinner today? This was just being mentioned from stage. And I see most people were focusing. It's not at Burger King, it is at Wild Rover. So this is the, not, yes, well, what would be a great tool for network administration? I think this is the last question. The answer, obviously, netbugs. No, this is the last question. Which sticker was the most popular? Yes. The most popular was actually my first NONOG meeting. The second most popular was pairing, so this is good for future NONOG meetings. So now, time to see who won. Is it still the two top? Almost. It's the, oh wow, 1, 2, 3, 4, 5. All right. Olen, Antonios, Håvard, Nikolai, and Simon can go and get a T-shirt, and etc. if they want to. Thank you.
Can you see the next 5 somehow? Kan du se de resten? Fordi de gjør det så...
Ja. Skal de også få?
Ja.
If the next 5 also want a T-shirt, you can also go and get your T-shirt.
Next 5 you should have the shirt.
Yeah.
So we have 10 prizes. Yes, and then you can get to choose. I'll just flick them. Den. Bare dra den.
Ja.
Jeg kan
skal dra den?
Ja. So also these guys could get a T-shirt or a prize of the shows. I had just one more thing to tell you. For the guys who registered allergies, you have to tell yourself about the allergy to the stuff there. They know about your allergy prepared alternatives, but you have to say you're allergic to the stuff. Thank you very much. See you at the Wild Rover.